and we literally have people from pretty much every time zone, as far as I can tell. And this is an amazing thing to be able to do. I am absolutely honored to be doing these talks in general. And specifically right now here at this moment, just knowing that somehow I'm sitting here in my house and I can talk, and people are hearing this in Tahiti and in, all over the world, South Africa, France. What's up, everybody from Wales and Turkey and Texas and, everywhere else. My name's Jamie Janover. I am going to be diluting down and kind of condensing down, distilling, I should say, a very large body of work by a gentleman named Nassim Haramein. Now, Nassim is somebody that I encountered on my travels as a musician. I am not technically a physicist. So let me kind of say that off the front here is I'm going to be talking about physics in layman's terms, because I'm a layman. I am not a physicist. I do not write the math of this physics. I encountered Nassim Haramein because I was on tour as a musician, and I went to a festival in Oregon, and my old friend, who I hadn't seen for a long time, said, "Hey, good to see you. And I have a new boyfriend. His name is Nassim Haramein, and he's doing a talk on unified field theory here at this festival." And so I said, "Oh, cool. I'd love to see your boyfriend's talk. This is my friend Amber." And so I went to this talk, and I saw this guy, Nassim Haramein, do a presentation. It was probably an hour or two long, and he blew my mind. He connected more dots than anybody I had ever come across prior. I think, like most people, obviously like all of you, we're asking these big questions of how did we get here? How did the universe start? What is God? What is consciousness? How does all this stuff fit together? These are the biggest questions that, human beings can ask. And we've been asking this for, since the evolution of consciousness, probably. And the questions are being answered in a way that is different now than it used to be back in the old days. The old days meaning before the scientific method was invented. Before the scientific method was invented, the way we knew things was in a spiritual, philosophical, intuitive kind of way. And now we've invented this thing called scientific method, where we're collecting data and trying to come up with a hypothesis that will explain what we're observing in nature. For a long time, it was just, I don't know how this all works, but my mom and dad told me this is how the nature of reality works. Or maybe you listen to your guru, who you assume is got a deeper understanding and a knowledge. And so you look to them for authority and guidance on how things work. And occasionally people rise to the status of being an ascended master, right? Somebody like Buddha or Jesus or Muhammad. These are, entities that have been trying to transmit very profound fundamental information. And a large body of people would basically have to have faith that that's the correct information as to how God works, or the nature of the universe, how we got here, how the universe is working, what it's doing, where it's going. And then we said, well, maybe we should try to figure this out with a little bit more logic and reasoning. And we're going to come up with this idea called the hypothesis and the collection of data and doing the scientific method, something that we're all familiar with, but it's not very old in the history of consciousness. The scientific method's only been around for a short period of time, really. And so Nassim Haramein is one of these people in today's world that is a scientist. He is a physicist. If you ask him if he's a physicist, he'll reluctantly kind of say, yeah, I'm a physicist in the sense that I do physics and I write the equations of physics. But he doesn't always like to be considered a traditional physicist because, as we're going to find out, he doesn't necessarily agree with everything that physicists are saying right now. And that would be something centered around the standard model of physics. The standard model of physics is the agreed upon model of the known universe that physics professors are teaching in universities across the planet right now. People are getting PhDs in physics, and it's building upon a very long series of discoveries and understandings of great thinkers, the shoulders of giants, that's been building since the invention of the scientific method. And we're trying to come up with a unified field theory, right? A theory that unifies everything in the universe. Technically, in the world of physics, to unify physics, you need to unify all of the forces and the occurrence of matter. So if you can unify the forces and matter, you have a unified field theory. Nassim Haramein is taking that a step further, and he's trying to unify into his theory things that physics doesn't even necessarily try to even touch or talk about at all. Things like consciousness and spirit, soul, God, things that are considered in the realm of theology and not necessarily physics. So Nassim would actually consider himself to be a mystic in the sense that he is willing and able to look to any source of information, no matter where it comes from, for evidence and data to fit together into his unified field theory. I was interested in this stuff a long time ago and had conversations with people about the nature of reality, like I think most of us have. And somewhere along the way, I don't remember who it was, somebody said, "Oh, Jamie, it sounds like you would be interested in this book called The Tao of Physics." And so I said, "Oh, okay, that sounds interesting. Taoism and physics? I'm going to check that out." It's Fritjof Capra. It was written in the 70s. And Fritjof Capra was very astute into the details of modern physics at the time. This is the big kind of the origins of string theory and things like this. He was also very experienced in the world of Chinese mystic kind of information and the Tao Te Ching and Lao Tzu. And there's a page in Tao of Physics where there's a quote of Einstein and a quote of Lao Tzu on the same page. I remember reading back and forth on that one page saying, "Oh, no way. Einstein and Lao Tzu are basically saying the same thing, but boy, they couldn't be saying it in a more different kind of way and from a different perspective." Lao Tzu is basically speaking poetry and, metaphysical kind of spiritual information, really. And Einstein, of course, is straight scientific method in talking about the physics. And they both are basically pointing towards the same direction at the very least. And so I thought this is probably something foundational and something important. And so maybe I should tap into finding out what this base level of truth, of reality is. Because if you can massage my spiritual, intuitive, faith-based, if you will, side of my brain, and also give me some logic and some numbers and some facts so that I can really sink my teeth into it and I could talk to my dad about it, who's very logical, then if those two things merge, then I'm happy. Then I'm able to look at this set of information from both perspectives and they both resonate as correct. Well, this is what happened to me when Nassim started talking. I said, "Oh yeah, I've heard about this kind of stuff before." And then he started saying some stuff where I just shook my head and I said, "What are you talking about? This sounds so different than all the stuff that I read about the standard model of physics." I read all these books for the layman about physics, right? Because I'm not a physicist. So I had to kind of catch up on the world of physics and how they got to this standard model in the first place. So I read things like Dancing Woolly Masters and Elegant Universe by Brian Greene as an excellent book to give you a baseline understanding of things like string theory, which is a very, popular model, and trying to integrate that into the standard model and stuff like this. Also, Brief History of Time by Stephen Hawking is another great one. Classics in the world of physics for the layman. Then Nassim Haramein comes along and totally turns a bunch of stuff upside down. And I kind of scratched my head. A lot of this stuff went just over my head when I first saw Nassim speak. And so I had to seek Nassim out for a few years. I saw him speak maybe 8 or 9 times until finally I said, "Oh, I think I get it." And I actually went to him and I said, "Believe it or not," I probably insulted him. I said, "Believe it or not, I understand what you're talking about. And I'd love to try to explain this to my friends. Is that okay? I mean, I don't want to mess up your theory." And then he told me, "Well, actually, I could spend the rest of my life going around doing lectures about what I've already discovered. What I really need to do is to teach other people to deliver my PowerPoint presentations, to explain my theory in layman's terms, so I can stay home and stay in my lab and do my research." And so that's what Nassim has been up to, is he's staying more in his lab and having these folks that are called emissaries, myself among them, going around and doing his PowerPoint. So the PowerPoint I'm about to go through is hundreds of slides. It started out when I first started doing these talks with just Nassim slides, and I've added a bunch of stuff since then, because obviously a lot of stuff has been discovered and Nassim has written new papers. So I keep incorporating new information, and I've put in a bunch of new slides for this talk today. And let's jump into it, shall we? Oh yeah, the universe. So people looking up into the sky for this entire time that humanity's been around, we all look up and say, what is all that? It's different looking in the day and night, and there's all these dots up there. What is that? And are they stars? What does that mean? What is a star, and where did these come from? And we didn't know until we started getting a little bit more of an idea as time went along. And then society developed, cultures developed, religions developed, and then one prominent religion, Christianity, became popular around the planet thanks to colonization. And there was this worldview, this overall model that we kind of got primarily from the Vatican that said that we were basically the center of the universe. And it certainly seemed like it, right? We had evidence to show that we were probably in the middle, like everything looks like it's revolving around us. And not only were we in the middle of everything, but we lived on a flat planet. Of course, because if you go to the seashore and you look at the horizon, it's flat. And so we would have observational evidence, data to back up our hypothesis, if you will, that the Earth was flat. And so that was pretty much the story until Galileo and Copernicus came along and they started using science, right? And they made observations of the universe and of the planets and all of the bodies that move around us, and said, well, actually, I know everybody in the world basically all thinks it's like this, but I think it's different. I think that the Earth is a sphere and that we're not the center of anything. And man, that did not go over well with the church. This was Galileo sticking his neck way out, so far out that he almost got killed for saying that. He almost got burnt at the stake, because this was the model that we had for the Earth up until then. It was a flat plane. You better not go too far off to the edge of the Earth with my friends in your boat. And you're going to tell me you're going to go that way and I'll see you in a couple of years coming from that way? You're insane. I'm going to burn you at the stake. There's going to be a dragon waiting to eat you as you fall off the edge of the Earth. This was basically the model that we were dealing with. And it took a brave individual, Galileo and Copernicus specifically, to dare to say something totally different, opposite than the standard model of physics at the time, because really this was physics. We didn't understand necessarily about gravity at this time. We didn't know about orbits and stuff. We were just starting to figure out how the solar system works and stuff. I'm not talking about the ancient cultures, by the way. I'm not talking about the Dogon people in Africa, right, that knew about Sirius being a binary star system before the invention of telescopes. Those folks were probably not totally confused. I'm talking about the descendants of Western thought, the Europeans that developed the university system and physics in general and started teaching it and giving PhDs. This is the tradition I'm speaking of, not of the pygmies of the jungles of the world that were passing down stories from generations, thousands and thousands of years ago. This is what we're going to get to later, but for now, we're talking physics. This was the model. We had the Earth in the middle. We had the elements and spheres around us, maybe, and maybe these were all flat planes at the time. And then Galileo almost got killed, almost got burnt at the stake by the Spanish Inquisition. But luckily for him, he actually had a personal relationship with the Pope. And so the Pope excused him at the time and spared his life. And, behind closed doors, the Pope and Galileo probably had a conversation about how Galileo was probably correct about this. And the Pope certainly couldn't go and say that he thought Galileo was correct, or it was going to seem like he's saying something against the church. And so it kind of stayed kind of hush-hush. And it took a long time for the Vatican to formally excuse Galileo. Now, today, the church says, oh, yeah, Galileo and us, we had a disagreement and it's okay. Basically, obviously, Galileo was correct about this, and they formally excused him, but it wasn't until 1992. So in some cases, institutions and ideas and worldviews and standard models, if you will, take a really long time to change because they've been cemented in by so many generations of data and evidence and everybody assuming that this is correct. Well, I have a feeling the same type of thing has happened not just a long time ago, but it's happening right now, currently. You fast forward to modern physics, and we had a time where we were very confident that we were very good at measuring time and measuring space. We had, the ability to measure stuff down to the nanometer, microns, right? And we had the ability to measure time down to an accuracy of a millisecond over hundreds of years with these incredibly accurate timepieces. And then this guy comes along, Einstein, and says, I know you guys are good at measuring space, and I know you're good at measuring time, but I'm here to tell you that those two things are not separate things. It's one continuous fabric. It's called space-time. And there's a dash in between there. And people at the time, and even today, are going, what are you talking about? I can't even conceptualize that. How do I even visualize what you're talking about? This sounds pretty out there and bizarre. And when Einstein first wrote his papers that outlined these ideas, his theory of relativity, he was not very well known, and he certainly wasn't very well respected. He barely graduated college. When he was in college, he wasn't doing very well. He's actually very dyslexic, and his teachers weren't that supportive of him. He was asking very difficult questions and stuff like this. When he finally graduated from school, he tried to get a gig and being a teacher or a research fellow, and no one would hire him. The only gig he could get was being a patent clerk in Bern, Switzerland, because at the time they needed physicists to be people that would review patents, because electricity had just been discovered and was starting to be put into technological devices, and they needed somebody who understood the physics of electricity to be able to review these patents. And so in the process of him thinking about all these patents, some of which had to do with space or time, he came up with his ideas of space-time and general relativity, published papers that didn't get a lot of traction until years later. Other physicists started pointing to his papers and saying, this guy might be onto something. And now, of course, fast forward to today, you've got people like Time Magazine that do the Person of the Year award. Well, in 2000, they decided, well, we should do the Person of the Century. Who's the most important person of the last 100 years? It's this guy who started saying something that was absolutely completely different than the standard model of physics at the time, turned out to be considered the most important person in the last 100 years by Time Magazine, and largely regarded as the most influential and probably the most famous physicist in the history of physics. Physics is something that has not been around for very long and is a process of observing the universe and trying to quantify things that you observe, like forces and matter, and put it into a very specific language, the language that you see on this blackboard. It's the only language that every kid in the planet has to learn in school. We have people here on this stream from all over the world, and every one of us had to learn this language in school. It's called mathematics. It's the foundational language of the universe. You could think of geometry and mathematics as being the most foundational original language that we had and we still have today. And everybody can look at math and geometry, and it says the same thing in all languages and all cultures and all races. It doesn't matter what your orientation is. It's got the same meaning. And so physicists are taking ideas, writing them into mathematical equations, and in some cases now, the math has gotten so incredibly complex and so difficult to understand, you practically need a degree in mathematics just to understand what physicists are saying. And so people like Einstein and even Nassim Haramein need help sometimes from mathematicians to do their work, because math is the language of physics. And it's a very deep discipline. Obviously, people get PhDs just in mathematics. Well, Nassim starts looking at the problems of the standard model, and he breaks it down by saying, maybe we made some fundamental errors in the beginning of our process of building a unified field theory. And at the very base of the idea of physics is the idea that we live in the third dimension. And everybody kind of assumes that that's correct. But Nassim, if we go back to his line of thinking, starting when he was a young child, and we're going to build forward through his life's work, he's looking at the very foundations of the standard model. Because if we make a very slight error at the base of a model that's trying to include every single thing in the entire universe, if the base of your model is not 100% correct, you're going to have a hard time being able to fit all of your observations into this model. And so Nassim starts with some very basic concepts that he got when he was a young child. You guys probably remember this lesson that we're looking at here from geometry class. And this is probably, I don't know what, in fifth grade or sixth grade, junior high school or something like this. The teacher gets in front of the class and says to Nassim and his classmates, "Welcome, kids, to the first day of school." And mind you, Nassim has gotten kicked out of every school that was closer to his house until he had to get bused about an hour and a half in each direction. He had been kicked out of multiple schools for not paying attention and being bored, and same kind of problems that Einstein probably had, right? He's a little bit hyper, maybe attention problems and stuff, just like mind was racing and teachers were talking about boring stuff that he got. And then all of a sudden the teacher says, "We're going to talk about the dimensions." And he got excited because finally some teacher is going to talk about something interesting in school. And they put a dot on the blackboard. You can see the dot with a yellow circle around it. If the teacher puts a dot on the blackboard and proceeds to tell you, this is an imaginary dimension. It has no width, no depth, no height, no mass, and no volume. It doesn't exist. It's an imaginary dimension, and so that's why we call it 0D. Man, you should instantly be shaking your head, because physics is supposed to be making actual observations of actual stuff. The standard model of physics should be building upon observations of the universe, not making up something that doesn't exist and giving a name to it and calling it the absolute base of your model. This is what we were all told, is that 0D doesn't exist. We just have to imagine it as an infinitely small point in space, a singularity. And then the teacher goes along and says, put a bunch of these dots together in a row and you make a line, and we call this 1D. And again, Nassim's looking up at the teacher, all confused, like, wait a minute, I don't think that's correct. Isn't that amazing? Nassim at age 7, you would think that when society hires a teacher to be in front of kids to tell them the most foundational thing that we know about reality, that the kid would be like, okay, obviously that's probably correct. But Nassim said, no, I don't think that's correct, because how can I see this 0 dimension on the board if it doesn't exist? Very cheeky little bugger, this Nassim at age 7 or 9. But this is kind of the way that Nassim has been going about his line of inquiry ever since. He does not take anything for granted. He's questioning reality from base one, from day one, from the very first slide that the teacher puts up in junior high school. He's saying, I don't agree with our standard model of physics, because you could take non-existent points, put them together and make a non-existent line, and then take 3 or 4 of these lines, right, and make a triangle or a square, and you have a 2-dimensional plane. And then you say, okay, what is that? That's an infinitely thin plane in space. Wait, I don't see the universe making infinitely thin planes in space. Again, is this a real thing, or is this something we're just giving a name to and making up? We don't see infinitely thin flat planes in space. I mean, you can look at a book or a computer screen or anything that you think is as flat as it can be. With an electron microscope, it's not going to look flat at all. Even atoms have topology. They have thickness. There's no such thing as infinitely thin. I'll give you an infinite number of infinitely thin, non-existent planes. You're not going to create reality out of it yet. That's basically what our model does. You could take 4 planes, right, and make a tetrahedron, or you could take 6 planes and make a cube. Oh, now you've enclosed space. I see. Now you have width, depth, height, mass, volume. All that stuff does exist now that you've taken infinitely thin, non-existent things and put them together like this. I don't think that's maybe correct. If that's not 100% correct, and if it's completely wrong, no wonder we have such a problem right now trying to unify everything, because our idea of the dimensions, kind of the base level of our pyramid of knowledge that we're trying to build, has got some serious foundational problems. Maybe our idea of the dimensions is totally wrong. Nassim thought, oh man, I am in big trouble because I have to go home to my mom now on the bus, and she's going to say, hey, Nassim, how was your first day at a new school? And he's going to have to say, it was okay, except I think they're totally wrong about everything they told me about the foundation of reality. She was going to shake her head, and Nassim has said that he's the one force in the universe that he's yet to feel like he's figured out is the wrath of an Italian mother. This is a serious force to be reckoned with. He didn't want to deal with the wrath of his mom, who's Italian, and his dad is Iranian, hence his name haramein. He actually was born in Geneva, Switzerland, and moved to Montreal when he was 2. And so he grew up speaking English and French, hence his accent. and went on to live in British Columbia. Now he's in Hawaii and California. So, but back to Nassim at age 7, on the way home from school, he has to say, oh, well, I better come up with an alternative theory of the dimensions before I get home from school, so that when I get home, my mom, if she's upset, well, at least I can give her an alternate theory as to what is correct if I'm going to say that the dimensions are incorrect. And so on his way home from school, you may remember this from stuff like his Connected Universe video, where he describes this process of being in the bus, closing his eyes, and in his mind's eye, zooming up into the sky, Google Earth style. Of course, this is way before Google Earth was even invented. So the fact that Nassim could visualize like this says something about him as a kid. But you can imagine if you went up into the sky, farther and farther up, eventually the entire city you're in with this bus driving down the road would look like a dot. And so Nassim looked down and the bus looked like a dot, and he kept zooming out until Montreal looked like a dot, and he kept zooming out until North America looked like a dot. You keep zooming out, then the Earth looks like a dot, and it recedes into the distance so you can't even see it anymore. And then finally the sun and all the planets, the whole solar system recedes into a little dot, and you have to go back really far to get to the point where the whole galaxy gets smaller and smaller and becomes a little dot and zooms. And then you keep zooming out, and the cluster of galaxies becomes a dot, and then the super cluster becomes a dot, and then large scale structure of all these super clusters together becomes a dot. Eventually you could zoom so far out that maybe the entire known universe looks like a dot. And so if you zoom all the way back through all those resolutions back into yourself again, Nassim thought to himself, oh, I see. It's like these bigger and bigger dots, bigger and bigger boundaries, bigger and bigger structures that are nesting and getting bigger and bigger to infinity. Maybe it just goes forever. And then he thought, well, wait, what about the other way? And he looked at his hand, and in his mind's eye zooms into his hand until he's down to this very small scale compared to his entire body, realizes, wait a minute, my entire body is made of these little dots, these little boundary conditions. And man, when we found these boundary conditions, we thought, oh, this is it. We found the building blocks of everything in the universe. There was a period of time in the history of science where we collectively, when I say we, I'm talking about, the standard model of university system of Western culture, we believed that everything was made of cells. We gave them the name cells, and we said, aha, we can explain everything. Plants, animals, and maybe even other types of matter, we thought, were made of these things called cells. So we started looking into cells and into smaller and smaller structures, and when we invented the technology to be able to see smaller and smaller things and bigger things, telescopes and microscopes, right? We realized that cells are made of much smaller dots. First, we found the nucleus in the center of the cell, which is way smaller than the cell itself. And if you go into any structure within the cell, billions of times smaller than cells, we found these little dots. And we said, aha, this is the smallest thing that the universe does. This is the building blocks of all other things. And we called them atoms. And now we know everything's made of atoms. And for a period of time, it was probably a shorter period of time than even when we thought cells were the smallest thing. We thought that these atoms were the smallest thing the universe did, until we realized, again, there's a little dot inside that dot. It's called the nucleus of the atom. It's like 1 billion times smaller than the atom. And then we realized inside that dot, there are smaller dots, and we called them protons and we called them neutrons. And then we looked even smaller than that. We're now going billions of times smaller than an atom into the quantum world. We discovered that there's 3 quarks in every proton, and now we're splitting subatomic particles to make smaller dots, because what are we looking for? The smallest possible little dot, the smallest little bit that makes up all of the other things. And so Nassim thought, oh, well, wait, you could probably just keep chopping stuff down and making smaller and smaller bits to infinity, in which case it's this continuum of scale from infinitely large boundary conditions all the way down smaller and smaller and smaller, like Russian dolls nested inside of each other to infinity, smaller and smaller structures and larger structures. And so his idea for the dimensions is basically 180 degrees, completely opposite of what we're teaching kids in school right now. We teach them 0D is a dot, 1D is a line, 2D is a plane, and you put planes together and you make the third dimension. That's where we are now. That does exist. That's our existence. But the other dimensions don't exist. Those are imaginary dimensions, which doesn't make very much sense. It's so interesting to me that We could get this far in physics and have this basic assumption that no one's questioned super hard, to my knowledge, until folks like Nassim really pulling the rug out here on slide 1 of his presentation. He thinks that our model of the third dimension is basically non-existence multiplied to the fourth. Mathematically, that's what we're doing. And so he thinks it's totally opposite. The third dimension doesn't exist. Second dimension doesn't exist. First dimension doesn't exist. The only dimension that does exist is the dot, is the point, is the singularity. But there's an infinite number of them. There's an infinite number of scalar dimensions. That's what Nassim would say about dimensions. Scalar dimensions of singularity, scalar dimensions of dot. Now, of course, as soon as I say the word singularity, you've got to start defining stuff. Part of the reason I do this talk, you guys, maybe some of you are really familiar with this information. I have a feeling that there are people here that are scientists that have seen every one of Nassim's videos, that know his theory very well. And then there are, for sure, other people on this call that have no idea about this, that somebody said, you've got to go check this out. This is an incredible new theory, and it's hard for me to explain, but there's this guy who can explain it. Check out this thing. So I'm speaking in a way as if you have never even heard about this at all. And so even for the people that are familiar with it, what I found is when I see Nassim say the same kind of presentation over and over many times, he's always saying it a little bit differently. There's always another way of bringing the material and tying it together. And so I'm trying to explain this stuff in a way that helps you not only to understand it, but to explain it to other people. Because really what we need to do collectively as a society is to learn the most correct, most resonant information that there is, so that we can align our thoughts and our feelings and our actions and our technology to be in resonance, in harmony, in collaboration with the universe, and not doing some of the things that we're doing right now, which we'll get into, which are not most constructive, most smart things to be doing. For example, blowing stuff up to make energy, especially when we dig into the ground and grab it and put it into the atmosphere in the process of blowing it up. We need to align our technology and our process of making energy with the universe. And by understanding the universe and understanding how it works and being able to share that information and spread that new discoveries in science that are coming out every day, we will hopefully be able to evolve faster and more efficiently towards a sustainable, fun future and have less problems and difficulties and pain and suffering and stuff like this. So in the big picture, describing the nature of reality and the physics in a way that is easy to understand for you guys, and then hopefully have an example of a way that you could try to present this to other people, will help this whole process. So I thank you from the beginning here, early on in the talk, for absorbing this information and being interested. And I hope that you will share and spread the information into the future, because as we're going to see here, there's some very powerful concepts that can come out of this. Right now, this slide right here is describing for you about the nature of infinity, because I was talking about infinite dimensions. How can you have an infinite number of smaller dimensions inside of something that's finite? If you have a finite boundary, how can you have infinity inside of something that's not infinite? That seems to be contradictory, yet these are actually complementary concepts. And so Nassim presents this by drawing a circle. And you can say inside of a circle, you've got a certain set of information. You've got information on the inside of your circle and information on the outside of your circle. If you want to enclose the most space you can possibly enclose with a single line, you would use a circle. And if you want to enclose the smallest amount of space with a single line, you would use a triangle. And so if you put a triangle into a circle, you subdivided the space. You've created a smaller unit of space, and there's data coming out of there, like the center point of the triangle and stuff like this. You could polarize that and put another triangle in there and make a Star of David, star tetrahedron inside of a sphere. And you've created a series of smaller circles. And then you could start putting circles around those triangles that you've made, and then put more circles and more triangles until you get this fractal pattern going. And you could chop it down in any way, right? It doesn't have to be circles and triangles. You could subdivide any space inside of any finite boundary any way you want and get more information, like the data points of the center points of your structures. And then take that and chop it down and zoom in, and then chop it down and zoom in and chop it down. I could tell my computer to zoom in on the top circle there where it's all dense, another fractal iteration of chopping the space down, and then have it zoom in and chop down that space. And it could do that multiple times per second for trillions of years. As long as you have power running to your computer will cut the space down, getting more information out of your finite boundary forever, to infinity. So that means that inside of any finite boundary, it doesn't matter if your circle is a quark or a galaxy, you can divide the space and get more information, and you will never ever exceed the original boundary you set for yourself, the original circle. I hope you guys are following this. Usually I'm in a room and I can say, are you following this? Are you guys following this? How about type it into the chat? Okay. Hopefully you're following me, because if you follow this idea that inside of any finite boundary is an infinite amount of information, good, because guess what? That means you're an infinite being. And I'm not saying you're an infinite being in any sort of spiritual, philosophical way, although it is. I'm saying it in physics. I'm saying it in scientific method, that you can conceptualize mathematically and geometrically how it's possible and why it's possible that you are literally, not figuratively, an infinite being. And man, when Nassim first laid this out for me, I thought that's pretty cool, because I've had all kinds of people try to tell me in various ways that I'm an infinite being and that I can do all these things and I'm tapped in and have faith and all this stuff. And I tried my best, and I'd say, okay, sometimes I feel like that's probably true, and sometimes I don't feel like that's true. And man, I wish I had a way of accessing that information that's a little bit more literal, something that I can sink my teeth into. And so here's an actual physical example that you can see on a screen, or you can, take models and look at dividing structures smaller and smaller, and you can imagine these infinite fractal dimensions. And so that means we have a relationship to infinity right now from our current scale. There's obviously structures and dimensions that are larger than our dimension or our scale, and there's many dimensions that are smaller than us as well. And if you can imagine all of those, you're embedded in this infinite fractal series. The universe is one giant infinite thing. It's chopped up in an infinite number of different little ways, and you're one of those things, that you have a relationship to the entire whole, and no matter what you do, you're going to have an influence on all scales all at the same time, because all the scales have to keep their coherency and talk to each other and have a network of information and communication for the universe to keep its coherency. We know the universe is highly coherent, right? We're observing it getting more and more organized as time goes along, not less organized. And so how is that happening? Nassim would say it's infinite fractal dimensions, infinite scalar dimensions of singularity, infinite scalar dimensions of dot. And now when you say singularity, that has a very specific meaning. Singularity is this point that is in the center of something that we've all heard of called a black hole. And so if you're going to start talking about black holes and singularities, then you have to start reviewing with people about Einstein and the theory of relativity and about gravity. And this picture right here is one that we've all seen before, where you try to describe the nature of our reality by saying that there are these fields of energy. We know them, we know they exist. There's the electromagnetic spectrum with all these different frequencies in it. And then there's gravity, which is a different force, supposedly, in the standard model, which, by the way, is not fully integrated into the standard model. The standard model has some serious issues right now. There's some great books out there like The Trouble of Physics you can check out, Trouble with Physics. If you want to take notes, I'd suggest figuring out a way of taking notes, because I'm going to rattle off in the next 3.5 hours a bunch of books, films, people, papers, and ideas, and you might want to jot down some of these folks. But The Trouble with Physics is a cool book because it talks about the history of physics and where people ran into problems and we had to change the model and all this stuff. Well, right now in the standard model of physics, we have two sets of math. We have math for big stuff and we have math for small stuff. And that's a big issue. Right now, Einstein's relativistic field equations correctly describes cosmological sized objects and the orbits of planets and things like this. But when you apply Einstein's theory of relativity and the motion of bodies on a cosmological scale to objects that are smaller than the atom, to quantum sized objects, that physics doesn't work out at all. They had to come up with a whole nother set of math to describe mathematically what's going on in the quantum world, and that is quantum field theory. And so quantum field theory and cosmology of Einstein's relativistic field equations do not perfectly talk to each other. These are totally different sets of math, and the idea is to try to unify both sets of math into one theory that describes all of the fields, gravity and electromagnetism, as being unified. That's why this is called a unified field theory, is that Nassim is unifying the math of the big and the math of the small. So right now we're looking at an example that we show to kids in school to give them an idea how to visualize the gravitational field. That gravity is like a continuous fabric, and that mass is going to curve space-time. Space-time is curved as the result of this mass. So we have the example of the Earth making a gravity well, kind of a dimple in the trampoline of gravity, because we kind of describe it like that. Take a trampoline, put a ball in the trampoline, it's going to make it dip, and then the moon is kind of falling into this hole that's being created. And because of the centrifugal forces that are kind of pushing the moon out as it spins, balancing with the gravity of the Earth, pulling it inwards, the moon sits in this thing called an orbit, thank goodness, otherwise the moon would come crashing into us. And that is being described here by this illustration. But notice this problem here. Notice that in this example that we've all been shown, that we're probably, unfortunately, still showing kids, gravity is flat. And we know for a fact that gravity is not flat. We just talked about how there's not any such thing as a flat plane in space, and yet we're representing this field that's everywhere by a flat plane. But in any case, that's kind of a dumbing down of the concept. I always remember thinking, okay, so when they talked about black holes being a place where space-time curves to infinity, that means it goes smaller and smaller and smaller down this giant funnel all the way to this dot called a singularity. And so in my mind, when I was in grade school, and probably even in high school, and even into college, I was visualizing this kind of being a black hole, a funnel that goes straight down to a dot. And it's this big black thing in space, and you can't see it. That's why they call it black, highly technical term. And it sucks in everything that gets too close to it. If you get too close to the singularity of a black hole, you're going to end up having to cross what's called the event horizon of the black hole, which is this threshold around the singularity. It's a spherical threshold beyond which, if you pass, there's no getting out. Even the electromagnetic spectrum, light, heat, sound, X-rays, gamma rays, all those frequencies get sucked in and disappear and go into another dimension or something like this. This is what I was told when I was in school back, a while back. And now we have much different explanations for black holes. Nassim actually comes along and totally redefines what a black hole is and the description of a black hole. So you have to keep in mind here, we're talking about somebody who's coming up with a unified field theory that is very different than the standard model of physics. So different that on slide 1, he's pulling the rug out on the dimensions, redefines what a dimension is, and then right away redefines what a black hole is. Instead of thinking of a black hole as this hole that's cosmological size that sucks everything in, Nassim has redefined a black hole. He actually calls it a black/white hole, WHOLE, because it's not just sucking information in, information is coming out of black holes as well. This is probably one of the biggest contributions that Nassim has made to the physics, is he has taken Einstein's work and modified it and added to it. So it's not that Nassim is against everything in the standard model. There's a bunch in the standard model that he thinks is perfectly correct and resonant. And then there's some things that he thinks that are possibly incorrect. And then there's some things that he just think is missing. And one of the things that he discovered was missing in Einstein's description of space-time was about the spin of space-time, because we observe everything in the entire universe spinning. We don't see anything that's not spinning. And it might seem like things are not spinning, but anything that to you seems like it's sitting still is actually made of atoms that are spinning incredibly fast. So just the basic level of reality of the kind of the quanta of energy that makes up your body, these things called atoms, they're all spinning very quickly. So when Nassim added the mathematical effects of spin into Einstein's field equations, and this was not an easy process to do, he needed help with this math, so he worked with Elizabeth Rauscher, who's a award-winning physicist who worked at NASA and worked at Stanford University. And he incorporated torque and Coriolis forces into Einstein's field equations. And when he ran the math, the topology of a black hole changed. Instead of it being a funnel in the sky, he added this torque component and talked about space-time actually curling like water going down the drain. When you pull the plug out of your bathtub, water doesn't just vortex straight down, it spins as it goes. And it's an equal and opposite thing happening where the water is going down and the air is going up. There's a change of density. The water is denser than the air, and so the water wants to go down, the air wants to go up, and there's this crossing of the vortexes and forming striations, and all of these little water molecules are acting in concert together to form this whirlpool structure that is not separate from the water. You can't take a whirlpool out of water, and you can't take a vortex out of space-time. It's made of the medium that is being transferred. So in this case, it's water and air, and that same thing is happening in the structure of space with black holes. Curling towards stillness, and then energy goes into the black hole, and then it comes back out, and then it goes back in, and then it comes back out, and it goes back in, and that structure is described topologically as a dual torus. This is the structure of all black holes on all scales according to Nassim's work, and you can imagine that the information is getting sucked in and spins as it goes down to the stillness in the center of the object, and then it comes back out most concentratedly along the equator. It comes out in every direction, but it much more concentratedly comes out along the equator of the object, and then it gets sucked into the gravitational field of that singularity, and then it gets pulled back down to stillness, and then it comes back out and it goes back in. And so it's happening in one direction in the northern hemisphere and the other direction in the southern hemisphere. Equal and opposite spin, curling towards stillness, equal and opposite. So it's not just a funnel with no opposite. For every action, there's an equal and opposite reaction. It's the most known thing in physics. The most tested and proven idea in all of physics is that whenever we observe something happening, there has to be something equal and opposite to that happening at the same time. So this would be a dual torus structure, or a donut and a donut, because a donut and a torus is the same thing. And it's forming an overall torus. Sometimes there's a confusion or questions about the dual torus versus the single torus. And the way I think of it is that it's really one complete toroidal field. However, there's different dynamics in each hemisphere. And we're going to see how that works in other structures. But basically, Nassim is saying that he thinks that everything in the universe is centered by singularity, and therefore everything in the universe is dual torus structure black hole. And you should be very confused right now because you're saying, what? Everything's a black hole? How is that possible? If you are adhering to what you learned in school about black holes being this giant funnel in space, then how could a planet or me or a cell or an atom be a black hole? Exactly. That's why Nassim is redefining what a black hole is, because when he runs the physics on this, he's realizing that at the center of every toroidal dynamic, there is stillness and a singularity, and information is coming out. So he has a paper that you can check out called the Schwarzschild proton. You'll see in this slide here at the bottom that an atom, he thinks, has a singularity in the center of it, making atoms black holes. Specifically, the proton, Nassim Haramein considers to be a black hole, having a very small scale singularity in its center. And there's a paper called the Schwarzschild proton. If you want to read any of Nassim's papers, you can go to his website, and that would be resonance.is. And then you can click on publications, and there's PDFs for all of his papers, including the Schwarzschild proton. This was a paper from about 2012 or something like that, or I think it was, no, that was 2010, I believe. And in this paper, he writes the math and outlines the fact that protons are actually miniature black holes. And so he would say basically that all of these objects, planets, stars, galaxies, are all centered by a black hole. So he would say the sun is a black hole. 20 years ago, he went into a physics conference and declared that he thought every single galaxy in the entire universe is centered by a supermassive black hole. And it didn't go over very well. They actually kicked him out of the physics conference because at the time, 20-something years ago, we didn't have the data that we do now. Now we've looked, every single galaxy we've ever observed is centered by a supermassive black hole. And they're getting more and more confused because they're starting to find black holes in the center of galaxies that are way bigger than what would be predicted by the standard model. The amount of holes that are starting to pop into this bubble of knowledge that we call the standard model is increasing. And we're having to put mathematical patches on there to fix these issues that have been kind of cemented into the model. And it's been patch upon patch upon patch for a really long time, to the point where we have such a complex standard model of physics that we can barely understand the math. Things like string theory, for example, attempts to unify the math of the big with the math of the small by saying, oh yeah, all we have to do is add in extra spatial dimensions. And then I'm thinking, oh great, I don't even understand the third dimension or the fourth dimension, which might be time maybe. What's the fifth dimension? How are these six-dimensional beings differ from the seventh-dimensional beings that I've heard about? And all this stuff. String theory started out saying, yeah, there's 7 dimensions, and they're all curled up so tightly into every point in space, you can't actually see them. And then they changed their model and said, actually, no, there's 10 dimensions plus time, making a total of 11 dimensions. And it's very hard to understand when you're talking about something that's imaginary. Again, we are building a model that's not based on observation. It's a very beautiful, elegant mathematical model that currently has an infinite number of solutions. They're trying to narrow it down from something infinite to something finite, which could take forever, and we don't have forever. We need to figure out how the universe actually works now so we can change the way that we're doing business on this planet. And so if you're looking at it from this broader perspective here, and you redefine what a dimension is, and you redefine what a black hole is, and you kind of look at it from a fresh perspective, it starts to fit together in the sense that all these structures are toroidal. The planet is spherical and it has a torus-shaped magnetic field. And we see this prominently in other planets like Saturn, where the rings are forming where the two toroids are shearing against each other. And you see evidence of it being much hotter on the equator of all these objects. Like the sun is hotter on the equator, the earth is hotter on the equator. Galaxies have way more stars coming out along their equator, along what's called the accretion disk. And so all these structures are actually self-similar in their dynamics of information going in and coming back out and going in, crossing the event horizon in both directions, an exchange of information going in and out, the only two directions in the entire universe, right? There's no up and down or north or south or right or left in the universe. There's only in and out. And the torus is the topological structure that exhibits both of those directions. Just looking at the scale of the planets, you get a sense of how major the scales are. It's, I think, hard to get somebody to visualize infinity in general. The whole nature of infinity is that it's not really comprehensible. You can think of the biggest thing that you can possibly think of and then double it and double it and double it forever, and you're still not to infinity. So I like to show a series of slides that gives people a sense of scale, because these are dimensions, really. If you're going by what Nassim says, scalar dimensions. The Earth is kind of cute and small compared to Jupiter and Saturn. Pluto looks pretty small compared to the Earth, right? You could maybe drive your car around Pluto in a couple of days or something. And so you start thinking of scale here. Pluto looks really small compared to Jupiter, but Jupiter is very small compared to the sun. The sun is 99.98% of all the mass of our solar system in that one object. And yet the sun is not very big. It's kind of a normal, average, maybe smallish size star, especially compared to these other stars that we found in our galaxy. Now the sun is so small, it's only a pixel big. It's kind of like those scalar dimensions we were visualizing with nassim in the school bus, zooming off into distance. And now these other stars that we thought of massive compared to the sun are now looking tiny compared to Betelgeuse and Antares and all this stuff. And so these stars keep getting bigger and bigger until they're billions of stars larger than the sun. And these are individual dots, right, inside of this larger structure that we call the Milky Way galaxy. So the sun is absolutely tiny inside the galaxy, and the galaxy is absolutely tiny inside of the local group. And the local group is tiny inside of the local supercluster, which is tiny inside of the large scale structure. These are the technical terms for these scalar dimensions. And this is kind of the view that we have of the universe just being massive, getting bigger and bigger. All the stars that you can see with your naked eye at night, except for maybe the Andromeda galaxy on a really dark night, almost every single star you see is inside that yellow circle inside of our galaxy. So just us being on this sphere and looking out into the universe, we really have not explored very far. And even our telescopes and our radio telescopes have not been able to go exploring very far beyond our local area within the galaxy. It's actually rather difficult to see outside of our galaxy, especially along the accretion disk, because there's so much dust and asteroids and stars and particulate that's blocking our view. Now we have a new image, a new view of where we are. I remember having a t-shirt a long time ago with a galaxy on it, and it said, "You are here." And that was kind of the big thing. Oh my gosh, we're now not just thinking globally, act locally and think globally. Ooh, we're thinking on a whole nother dimension. That's so old now. Now we're thinking more galactically, and now even thinking galactically is getting to be old. Now we should think intergalactically. We should think multiversally, as far as I can tell, because now we know the "You Are Here" shirt should maybe just have a dot for the entire galaxy. The Milky Way galaxy is represented by this blue dot in this picture, and these white lines represent the pathways along which galaxies are traveling. So they're mapping the supercluster that our galaxy is a part of, and they've called it Laniakea, which means immeasurable heaven in Hawaiian. We now know that our galaxy is moving in coordination with a lot of other galaxies toward this area of the universe that they're calling the Great Attractor, which I love. That to me, it sounds like the giant black hole that's sucking all the tiny little bitty black holes in the center of galaxies towards it. We're talking a whole nother scale of dimension, a whole nother scale of black hole embedded. So basically, Nassim has come up with theories in some cases that are now 20 to 25 years old. And it's taken that long for other people's physics and other people's science, other people's observations and data to be collected to now support some of the hypotheses that Nassim put forward a long time ago. Because Nassim is an independent researcher. Nassim is not part of a big university and doesn't have a whole bunch of doctoral students working for him or a grant from the US government or something like this. He's an independent researcher who actually does not have a PhD in physics. He's been independently looking at this stuff for a long time. And so you can imagine, as an independent physicist without a PhD, when he writes a paper and he wants to get this published in a peer-reviewed journal, it's rather challenging because the people that make the peer-reviewed journals also decide who gets to be in the peer-reviewed journals. And part of the rules are that A, you have to have your paper reviewed by somebody who's in your field, and how many people are actually working on unified field theory out of all the scientists on the planet? Not very many. And of those people, they have to be published themselves in the last 3 months. And then they have to read your paper. And then if they think you're correct, and it turns out that it's maybe going to say something totally different than the physics that you already accept and built your own work on, you might not be too quick to be like, check this out, we got to publish this new theory, because these folks that are entrenched now in the standard model and using these massive devices like the particle accelerator at CERN, they need billions of dollars. And if there's a theory that goes against the theory that they're building on, they might lose funding. And so it's actually very complex. It's not as simple as, oh, this is a new scientific theory and it's probably more correct and resonant on these certain things. And so it's going to quickly get accepted and put out there, and it'll make it into kids' textbooks and will change what we thought really quickly. That is taking a lot longer than we thought. In some cases, material takes years to get from being proven correct to actually making it into a textbook, to actually making it into practice where people are, using that physics to alter the way that they do business or they do their experiments and things like this. So Nassim has kind of had to swim upstream against the stream of the standard model, in the sense that a lot of the stuff that we assume to be correct has been cemented into our textbooks and our consciousness for such a long time. It's hard to go back and change something that has influenced everything that has come after it, because it really changes the entire model. We've got all kinds of problems happening in the standard model, which we're going to get into, about the proton being the different size than they thought, and black holes maybe coming before the galaxy formed instead of after, and all these observations that they thought they had figured out are turning out to be more complex than we thought. We're looking at the universe. We're also looking at ourselves, looking back on ourselves and self-informing our own experience. If you turn the Voyager probe around, thank you, Carl Sagan, back in the 70s or 80s or something, turned the Voyager probe around, took this picture of Earth, that little tiny dot. Every single drama that ever happened on this planet, all the wars, all the babies that were born and died, all happened on that little dot. Gives you a different perspective on things, right? So now we fast forward to Nassim's experience going to Georgia Tech with this book called Gravitation. And on page 719 of Gravitation, which is kind of the Einstein's Bible of Einstein's physics, it's Wheeler, Thorne, and Meisner wrote this back in the 70s. They give you a model of the known universe, which is a guy blowing up a balloon with pennies glued to it. And as the balloon is expanding and the galaxies are moving farther apart from each other, this guy's lungs are contracting. But yet, in this book, Nassim asked these guys at this conference, and can you imagine, Paul Serac was there, the guy who started string theory, and Nassim says, what I want to know is, who is this guy that's blowing up the balloon? Because if your theory says that the universe started as a singularity and then it quickly blew up in a giant explosion that we gave this highly technical term, the Big Bang, and space was created and it's been expanding ever faster and faster, accelerating as time goes forward, then there's got to be a hell of a thing contracting to make that expansion happen. And we've all heard about the Big Bang, starting with this infinitely small point in space that blew up, and that space is getting bigger, faster and faster. It's called inflation, literally. Somebody won the Nobel Prize in Physics about 3 years ago for proving that inflation actually is happening. And Nassim is pointing out, what about the big contraction? And they didn't really have the equation for the big contraction. Seems to be a huge omission. In other words, Nassim is saying to these guys that the standard model is doing a good job at describing everything that's going out, the explosion of the universe, but we know that for every action there has to be an equal and opposite reaction. So if the universe is accelerating in an expansion and inflating faster and faster, there's got to be an incredible hell of a thing that's contracting more and more to create that expansion. And so when Nassim was saying, I want to come up with a unified field theory, he knew he had to include not just the expansion of the universe, but the contraction as well. And he's not talking about God. He's not saying that there's an actual guy blowing up the balloon. He's talking about the physics of who's the guy, what's the physics that's causing the contraction to cause the expansion. And this seems to be missing in the standard model. He also busts them even further, where he talks about all the observations that they made to get to this model. To come to the model of the Big Bang, people like Edward Hubble observed galaxies moving farther and farther away from his telescope, thanks to the redshift of the light, and figured out that all galaxies are moving away from us. And so it seems like, from our observations, we might be in the center of the universe. I guarantee that we're not, or that all points in the universe are the center. And so it's going to seem like you're in the center no matter where you are. But in any case, what he's saying is all this information that they gathered to kind of collect their data is based off of what? Like, how are you even able to make observations in the first place? If there was no matter in the universe, you'd have nothing to make observations of. In other words, if there were no planets or stars, where would light come from, or where would light bounce off of so that it can hit your telescope? When you look at a planet, you're seeing light that hits that planet, bounces off the planet, and then hits your telescope. And the only way you're able to make that measurement is because there's matter out there, mass, to measure. And so you can ask the question, well, what is mass? And we don't exactly know the answer to that question, but we do know that all matter that we've ever observed is made of atoms. We haven't found any matter not made of atoms. And so then you can ask the question, well, what is an atom? And again, we have an idea what an atom is, but we're still a little bit fuzzy on the specifics and exactly how to model it. But we're pretty sure we understand that all atoms that we've ever found out of all the elements, they're all made of 99.9999999% space. And they're made of 0.000001% stuff, like protons, neutrons, and electrons. And these things are not necessarily exactly solid in themselves. And so what are we actually looking at here? I mean, if you're coming up with a unified field theory that describes the entire universe from infinitely large to infinitely small, you might want to pay a little bit of attention to the 99.999999% part, maybe a little bit less to the 0.00001% part. All the light, heat, sound, X-rays, gamma rays, cosmic rays that you're able to measure thanks to the fact that there's matter out there to measure, but yet matter is mostly made of this thing that we call space. So shouldn't we be paying most of our attention to the space since that's what's mostly there? That's certainly the line of reasoning that Nassim put forward to these guys at Georgia Tech, whatever it was, 20 years ago, with Foster Gamble there as his sponsor. Luckily for Nassim that he met this guy Foster Gamble, because Nassim was ready to give up. He was doing lectures to relatively small groups of people 20 years ago. And he literally had said to himself, this is my last lecture. I give up. I'm not really getting traction. People are not really following me or believing in what I'm talking about. He was literally ready to give up. And he did a lecture at which Foster Gamble was attending. And he said, hey, kid, I think you're onto something, right? Because Nassim was probably in his 20s at this time. And said, hey, I'm doing this symposium for physicists in Santa Cruz Mountains, and you should come speak. And so he spoke at the Redwood Symposium that Foster Gamble had organized. And then, of course, later on, Foster Gamble went on to do many other projects, including that movie called Thrive. If you've not seen the movie Thrive, highly recommend, especially because it starts out with Nassim and his physics at the beginning of the movie, and then it moves on and on. It goes into all kinds of places down the rabbit hole. But Foster put amazing work into putting that movie Thrive together. He was also Nassim Haramein's first funder in terms of giving him a per diem just so he could afford to eat and stay in the United States doing his research. Prior to this, Nassim was teaching skiing in Whistler, British Columbia. At one point, he was one of the best ski instructors in Canada, and he would travel down in a van to California and do research at UCLA and Stanford physics libraries until he ran out of money. He'd have to go back to BC and teach skiing and sell some equipment and stuff like that, and then he could come back down. And Foster enabled him to stay down in the States in his van and do his research. A bunch of Nassim's greatest breakthroughs early on in his work were made while he was living in a van with very little money, just kind of staying up late at night trying to figure out the mysteries of the universe. And so thanks to Foster Gamble bringing him to Georgia Tech, he was able to get these ideas in front of some of these guys who I have a feeling were pretty annoyed because he was calling them out pretty big time, saying, you're great at describing the expansion of the universe, but where's the contraction? And all this data that you're gathering based on all this matter is a very small fraction of what's actually going on. If you look at the universe, what really is happening is there's a bunch of space and there's very little stuff. And so let's find out every single thing there is to know about space. Is there a structure to the space? Is there a dynamic to the space? Is there an energy density to the space? And if so, what are those things? These are the questions that Nassim was trying to answer. And so he set about his investigations from that point, trying to figure out everything that there was about space. Now, Nassim is not the first guy by any means to look at space and figure out that empty space is not empty. Everybody kind of thinks of space as being, oh yeah, that's where there's no stuff, right? If you're in the middle of space out in between galaxies, there's no atmosphere, right? So there's no air, so there's no molecules. So is there anything there, or is there stuff to it? I know if I move my hand really quickly, I can feel the air passing through my hand. And if I put my hand into water, I can feel that there's even more density there. But what if I'm floating between galaxies where there's no atmosphere and I move my hand? Is there any viscosity to that at all? Or is it just totally empty? And the answer, as we know, is that it's not totally empty. It's actually full of energy. And you can see, excuse me, these physicists throughout history have been saying the same thing, Wheeler, Bohm, Einstein, that the space that we think of as totally empty is actually completely filled with energy. And that's got to be one of the biggest anomalies and hardest things to describe in the history of physics. What do you mean space is totally full? I can be floating in between galaxies in the middle of space, move my hand, I don't feel anything. To me, space seems completely empty, yet physics is proven to us beyond a reasonable doubt that that space is actually infinitely full with energy. What a crazy anomaly. How does the Standard Model explain that? If you go and look at the Standard Model and try to figure out what it says about space, you're not going to find out a lot. You're going to find out that they actually kind of swept the whole thing under the rug like it wasn't important. This guy, Henry Casimir, back in 1947, came up with this idea that maybe space is full. Maybe there's a viscosity to space. Maybe there's some stuff in there. How do we even measure it, though, he thought? We'd have to isolate a sliver of the vacuum of space with no electromagnetic spectrum in there. We want no heat, no light, no sound, no cosmic rays, no microwaves. So we need a vacuum chamber. We need to get two plates so incredibly smooth that they get only a micron apart from each other, so no frequency of the electromagnetic spectrum can fit between these plates. And then we'll measure if there's any pressure from the fabric of the vacuum pushing on these plates, a differential, if you will. And so this is a short explanation of a very complex set of experiments that has been replicated many times in universities around the planet. It actually took until 1990 at Seattle University to do this experiment for the first time. But now we know beyond a reasonable doubt that space is not empty, it's filled with energy, and it's not just a little bit full, it's basically nearly infinitely full. And so this is really baffling when they took the measurements and said, oh, I see, here's how much energy density there is in the space, and they got a number for it, and they stuck that number into all the field equations, then all their equations came out to infinity. And then they said, now what are we going to do? We can't go and make a big announcement. Oh, we figured out how the universe works. It turns out it's one giant infinite thing. People are going to look at them and say, what are you, a mystic? I thought you were doing physics. And so what did they do? They said, well, we'll just round it off. We'll say that the energy density in the fabric of the vacuum is really, 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 really full, but it's not infinite. We're going to just round it off. And if you're talking about rounding off infinity, that's an infinite fudge factor. And you don't necessarily want to put an infinite fudge factor into your unified field theory if you're actually trying to actually describe what's actually going on in the actual universe. And yet, it took Nassim a long time to find this quote in that book, Gravitation, but he eventually found it. Present day quantum field theory gets rid by a renormalization process, boy, that sounds fancy, of an energy density in the vacuum that would formally be, notice this word, infinite, if not removed by this renormalization. In other words, we know in our current theories that the energy density of the fabric of the vacuum is nearly infinite. But when we stick that number into our equations, everything comes out to infinity. So we're just going to say it's really full, but we're going to round it off and just say, okay, that's full enough. And this process that I just described is called renormalization. And so they tell you that they're doing it in one sentence, in one book, and then they just move on as if this wasn't important. And this got cemented into our line of reasoning. This is the moment when the energy that exists in space was taken out by physicists. It used to be called the ether. Remember this? It used to be called the ether, and then everything started coming out of the ether. Everything was based off the ether, and it just started sounding way too metaphysical, way too magical. And physicists don't want to be magical or metaphysical. They want physics. They want finite numbers. They don't want to talk about infinity times infinity is infinity, because that's not, scientific enough in physics terms. And so they did this renormalization trick, a rounding off of an incredibly large number and making it smaller, down to this point where they say that there's this energy in the vacuum, but we're not going to pay attention to it. We're going to sweep it under the rug. You can do an experiment and get an infinitely small number, and maybe you could get away with sweeping it under the rug as if it wasn't important in your unified field theory. But if you come up with an experiment that gives you an infinitely large number, you can't just sweep it under the rug and pretend like it's not important. Yet, here it is in gravitation, Wheeler, Thorne, and Meissner, staying straight up that renormalization is going to get rid of an infinite density of the fabric of the vacuum. And so Nassim points to this as probably the greatest mistake in the history of physics in terms of ignoring a result. They used to call it the ether, and they used to call it the plenum, and then they started calling it things like, the 0-point field, the quantum foam, the source field, the vacuum, space, God. You can call it whatever you want. We are made of and bathing in a nearly infinitely dense superfluid medium that we call commonly space. Notice I said superfluid medium. So Nassim wanted to look at the nature of space and figure out everything there is to figure it out. So how did they even figure out what the energy density of space is, right? Density is how much stuff is there per unit of volume. And we're talking about energy in space. So when we talk about the density of space, this is a tricky thing to visualize, I think. You have to remember that mass and energy are the same thing. So when I say that the energy is totally full in space, I'm not talking about it's dense like lead, that it's filled with matter. It's filled with vacuum fluctuations, these tiny little vibrations in the electromagnetic spectrum. There's all kinds of vibrations in the electromagnetic spectrum, and our eyes and our ears combined can only perceive less than 1% of it. And so at a very small scale, the smallest possible vibration of the fabric of the vacuum is this tiny little distance, this tiny little waveform called the Planck's distance. And it was thought of by Max Planck, discovered by Max Planck. That's why it's called Planck's distance. And it's what is described as the smallest possible measurable distance in math and science. Man, when I first saw this, I raised my hand. Nassim, what do you mean? You just told me you can divide things to infinity. Why don't you just say that the smallest distance is 1.616 times 10 to the negative 66 centimeters instead of 10 to the negative 33 centimeters? That's a decimal point with 33 zeros after it, 1616 centimeters. That is such an incredibly small distance. And I was like, well, how is that the smallest possible distance? Why couldn't you just keep going smaller? The only thing that Nassim explained to me that really made it land for me is the example of, well, if you want to measure the size of something, you have to be able to see the thing that you're measuring, which makes sense to me, right? How are you going to measure it if you can't see it? And how are you seeing anything at all? The only reason you can see things is because photons, which are quanta of energy in light, bounce off of objects and then hit your eye or hit your telescope or your microscope. So you can shrink something down all the way until it's the size of a photon of light. And if you make something smaller than a photon of light, there's no way for light to hit it and bounce off of it to hit your eye. So this is actually a physical boundary condition in the universe. It's not to say that there's nothing smaller than the Planck's distance. It's saying that from our perspective at this time on this planet, with our perceptions and all of the technologies available to us right now, we have no way of accessing any information that's smaller than this scale. the Planck's distance, 1.616 times 10 to the negative 33 centimeters. So it's the foundational quanta of energy of the universe. These things are so incredibly small, it's really difficult to even perceive how small a Planck's distance vibration is. Nassim describes them correctly as a waveform, and we're not talking about a flat waveform, right? Flat waveforms are on the surface of oscilloscopes, a two-dimensional waveform. We know there's no such thing as a two-dimensional waveform. All waveforms are actually 3D vortices traveling through space, or maybe you perceive them as traveling, but it could just be a standing wave in the structure of the space itself. In any case, Nassim describes these little Planck's distance waveforms as spherical. So it's a Planck spherical unit, a PSU. So this is, the description that Nassim is using to quantize the fabric of the vacuum, which means that the structure of space itself can be broken down into little bits, quanta of energy, right? A photon is a quanta of light. Einstein was the one who coined this term. And so the quanta that makes up space is these tiny little Planck spherical units, the smallest little vibration that the fabric of the vacuum does. And Nassim says that inside of a single proton, which is incredibly small, there's 10 to the 60 of these little Planck's distance spheres. And this is how they got to this renormalization, is they figured out how many of these tiny 10 to the negative 33 centimeter cubes can we fit into a cubic centimeter. Then we can get a measurement of the energy density of the fabric of the vacuum. This is the number that they quote unquote renormalized and got rid of and pretended like wasn't important. 10 to the 93 grams in a cubic centimeter. Yeah, that's a 1 with 93 zeros after it, grams. When you put another zero onto a number, you're making it an exponentially larger number, right? It's 10 times more. So if you say, I'm going to start adding zeros onto your bank account, you might say, great, how many? Because in only a few zeros, I'm a multimillionaire. When you have 10 to the 92 grams in a cubic centimeter and you put one more zero on there, that's 10 times more. So if you're trying to estimate, for example, how many particles are there in the universe? And you say, actually, I think there's 10 to the 79. No, there's 10 to the 80. That one more zero means you're talking 10 universes. So if you're even within a single order of magnitude in an estimate on a number in cosmological terms, you're in the ballpark, even though you might be 9 times 900% off. 900% off is actually in the ballpark when you're talking cosmological. But we're talking 10 to the 93 grams in a cubic centimeter. That seems like it's really big. It's so big, you can't even perceive it. If you took all the stars and all the galaxies and all the gas that exist in the universe and you put them into a giant trash compactor and you made the universe this big, all the atoms in the universe that big, that would be really dense. Yet the estimate on the actual mass of the universe is 10 to the 55th grams. Now this should be super duper confusing to you, right? Because I'm sitting here telling you that empty space has the equivalent energy density that's 39 orders of magnitude denser than if you squash the whole universe into a cubic centimeter. Wait, how is that possible? I'm moving my hand, I don't feel anything. You're telling me the space is denser than if I squash the whole universe into a cube this big? That doesn't make any sense. That has got to be the biggest anomaly ever in the history of physics. Yeah, I'll say. So Nassim's like, we got to figure out how that's possible. What would my hypothesis be to be able to explain that? And here's the crux move of the entire explanation of this unified field theory. It has to do with how it is that space is infinitely full with energy, but we perceive it as totally empty. It comes down to the structure of the space itself. And so Nassim said, well, let's look at the universe and make actual observations of actual stuff, not just string theory saying, oh, we're going to add imaginary dimensions into these already imaginary dimensions, like the second dimension that we already came up with. He's going to observe actual things in the universe. And if you said to a physicist, what is the universe doing exactly? You can only tell me one thing. What's the most foundational thing? What is the universe doing? They might say the universe is making spinning spheres. Everywhere we look, we see boundary conditions that tend to form the dual torus, or spherical, or variations thereof, like there's spiral galaxies, but there's the halo of the galaxy, right? So it's actually spherical. It's planets, stars, atoms, superclusters, quarks. And so let's observe all these various scale spheres, and we'll measure a couple of things that is easy to measure. Things like, how big is the sphere, or what's the vibrational rate or the frequency that this sphere is vibrating at. So he wrote a paper with Elizabeth Rauscher. At the bottom, you can see in a collaboration with E.A. Rauscher, Robert Gray and Mike Coyle. These guys put together Fundamental Dynamics of Black Hole Physics. This is back in 2002, so it's a good 13 years ago now. And they observed all of these various objects at different scales. On the left-hand side, you'll see a graph that is showing you hertz on the vertical axes there, and then radius along the bottom. It's a graph showing you the frequency versus the radius of all these different objects. From the infinitely large, the largest thing that we can observe right now is the thing that we call the observable universe. We can't see any farther than the edge of our universe. Right now, you may have heard that the universe is 13.7 billion years old, or 13.75 billion years old. It was actually recently upgraded a few months ago. We're now up to 13.82 billion years old, because we've observed galaxies even farther off to the edge of the universe. Actually, just yesterday or the day before, I saw some photos posted from Hubble. If you go to the Hubble Facebook page or Hubble website, they released new deep field pictures. So we keep getting pictures of older and older galaxies. Maybe it's even older than 13.82 right now. I haven't read the articles yet, but if you're over 65 years old right now, when you were in school, in grade school, you were told that the universe is 3 billion years old. So the universe keeps getting older and older as we're able to observe farther and farther away galaxies. I'm not sure how far that's going to go. I have a feeling the universe will probably get older as we go along, maybe not forever old. And then, of course, you can ask, well, what happened before that? And those are the big questions, right? You could have the Pope and Stephen Hawking sitting here right now and ask them what happened before the Big Bang. And I have a feeling there's probably equal weight in their answers right now. Neither of them know for sure. They'll say that they are pretty sure, and this is what I think, and this is what my tradition says. But the reality is that the answer to almost every single question that there is we don't know. And we're trying to figure out what we do know to the best of our ability. So Nassim's looking at the biggest thing that he can find, the known universe, the observable universe, and then plots it on the graph. It's got a very large radius, but a very low level of background radiation. And then the next data point farther up the line there is G2, and that's the average size of a large galaxy. And the next data point is G1, that's the average size of a small galaxy. The next data point is labeled S, that's solar size, or the average size of an average star. And then the next data point down there, you'll see one says A for atoms, and then right next to that it says a little data point that's slightly off the line for microtubules. Those are the structures in your cells that are vibrating very quickly. And so he's mapping these structures all the way down to the Planck's distance in the upper left corner. You can see it's a very small radius and a very high frequency. And notice, of course, that all of these dots line up in a linear fashion, so that there's a logarithmic scale, perfect linear relationship between the frequency and the radius of all these objects on all these scales. And you'll notice here it says Schwarzschild condition. Nassim is pointing out that all of these objects obey what is called the Schwarzschild condition of a black hole. Carl Schwarzschild was the first physicist to solve Einstein's field equations. Einstein wrote his theory, and he couldn't actually solve his own equations. He needed somebody else to solve them. So he wrote his equations, published them, and 2 weeks later, while fighting on the front in World War I, Carl Schwarzschild, I always picture him in a foxhole, ducking bullets with Einstein's field equations, like, oh, I can figure this out, and trying to not get killed. So he solves Einstein's field equations, mails it back to him. Einstein is astounded that somebody figured this out within his lifetime, and he publishes the results. And then unfortunately, Carl was killed in World War I only a couple months later, so he never got to work with Einstein. And it took until many years later for somebody to do a more advanced solution. In any case, Schwarzschild was the first guy to solve Einstein's field equations. This is why Nassim Haramein called his black hole proton paper the Schwarzschild proton. He wanted to call it the black hole proton, but man, he's already getting enough flack from the mainstream community for saying stuff that's so different than the standard model. He didn't really want to push any more buttons by calling it a black hole proton, so he called it a Schwarzschild proton. It's kind of encoded information. But basically, all these objects observe the Schwarzschild condition of a black hole. The Planck's distance, an atom, a star, a galaxy, and the universe itself could be described as a black hole. So Nassim would say, do you realize that you live inside of a black hole right now? Isn't it bizarre when you go out at night and you look into the sky, it's black? I mean, we know there's billions and billions of galaxies with billions and billions of stars in every galaxy. Why isn't the sky completely white with light? Because there's so many stars out there. And the short answer for Nassim is that light cannot escape the boundary condition of a black hole. That thanks to Einstein, we know that if you take a laser, shine it into space, it's going to go up until it gets close to a gravitational field like a star, and that's going to slightly bend the light. Thank you, Einstein, for figuring that out. And then the light's going to go get close to another gravitational field like another star and bend, and then it's going to bend and bend and bend, and eventually that light's going to curve right back into the universe, because the universe is a dual torus black hole structure. It's probably going to turn out that we are in one hemisphere of a gigantic dual torus. Maybe we can't even see the other hemisphere that is the universe. We're just starting to barely be able to see our local environment. We found, for example, 2,000 planets now that are orbiting stars. For a long time, we thought we might be the only solar system in the universe with planets. We just barely even can perceive the fact that there's other planets out there. So it's safe to say we're in the early stages of understanding our environment. Nassim is mapping out here very fundamental relationships about the universe on all scales. The universe has to have a structure to it. It has to have an organization, or else you wouldn't get this linear relationship of frequency versus radius of all these spheres at all these scales all at the same time. If you look at the right-hand side of this graph, you'll see that when you compare data points, like the distance between the Planck's distance and the atom and a star, it comes out to either phi or close to phi, or the inverse of phi or close to the inverse of phi. So if you're getting phi and the inverse of phi coming out of your data set and your observations, you're probably onto something. It's probably not random, right? Because phi, 1.618, that ratio of size or scale is embedded fractally into everything that we observe in the universe, especially into ourselves, right? Like this part of your finger to these two parts of your finger is phi, and your finger to your hand is phi, and your hand to your forearm is phi, and your arm to your body is phi. And we find it in trees and in leaves and in root systems and in cardiovascular systems and in neural networks. We've even found phi at the quantum scale. So we know we're onto something if we're getting phi in our data set. So now check this out. This is the only slide I'm going to show you in this version of this talk where I'm going to go into all these equations. If Nassim was here to explain his entire theory to you, like when he teaches the emissaries to do these programs, he'll talk for 100 hours and then run out of time. And I've done talks where I've done weekend-long programs called the Delegate Program, where I talk for 20 hours, and I'm doing a 4-hour talk. So it's the Reader's Digest version of the Cliff Notes version of the Reader's Digest version of this set of information. So I'm not going to go deep into all the equations, but I do want to show you this one very important slide from the Schwarzschild proton black hole paper presentation, where he takes the energy density that exists in the fabric of the vacuum, which exists at a rate of 10 to the 93 grams per cubic centimeter. That's a volume this big. And then he says, well, how much energy density exists inside the volume of a proton? Uh-oh. Can you still hear me? I just got a message saying.
Yes, you can.
Okay, sorry. Thanks. I had a message saying that it was slow connection. So at the rate of 10 to the 93 grams per cubic centimeter, at this very high energy rate, how much energy density is available inside the volume of a proton? And so a proton is very small, but it has
Go back to your browser.
Can't hear me?
Yeah, sorry about that. Go for it.
Sorry, there was a moment you guys couldn't hear me, so I'm going to repeat. Inside of the volume of a proton, how much energy density is available at the rate of 10 to the 93 grams per cubic centimeter. So nassim calculates the volume of a spherical area, the spherical area of a proton, at the rate of 10 to the 93 grams per cubic centimeter. How many vacuum fluctuations are available inside there? The answer is 10 to the 55th grams. 10 to the 55th grams is the equivalent mass of the entire universe. So this is the equation that Nassim has written basically to show that everything is connected, that all protons are entangled, because inside the mass of a proton, inside the volume of a proton, is all of the information of the entire universe holographically encoded inside of there. So now we have to review what a hologram is. Holograms are structures where inside of this boundary is all of the information being mapped onto the surface event of that boundary. So it's an encoding of information, kind of like if you have a CD of an orchestra playing, the orchestra itself and all those people and all those instruments are not on the CD, but their performance has been holographically encoded in there. And so this equation is showing that inside the volume of a proton, there's the equivalent mass energy of all of the other protons of the entire universe talking to that one proton. That there's a relationship of the information on the inside of the proton to all the information on the outside of the proton. And this is the equation that gets you that. He built it off of a bunch of other equations that I don't have time to go into technically, because I want to get to a bunch of stuff, including ancient cultures in this talk. So I'm just skimming the surface. Hopefully this is going to make you want to go deeper into one of these ideas by going to the actual papers themselves and reading some of the other materials that exist on resonance.is and in the Resonance Academy, which I will explain in detail in a little bit. But basically, there's an entire online program to go through all of this stuff in great detail instead of just me talking about it briefly for 4 hours. But I want to give you the overall picture of how we got to this theory. Nassim looks at the protons as little black holes spinning around each other at the speed of light. This is a very different way of looking at protons. When they first discovered the nuclei of atoms, they were very confused because have you ever taken two positively charged magnets that are powerful and tried to get them to touch each other? They're not going to go together. They have a lot of resistance. It's called the Coulomb force. And it happens when any two objects that are of the same polarity try to come together. So when you look inside the nuclei of the atoms, of all the atoms in the entire universe, they're made of protons and neutrons. There's no electrons in there. The electrons are in what's called, quote unquote, the electron cloud. And inside there are positively charged protons and neutrons, which have no charge, which means that nuclei of atoms are these incredibly tightly packed together structures with positively charged particles, which should be repelling against each other due to the Coulomb force. And so they said, this is very strange. There's got to be something incredibly strong holding this stuff together. And so what did they do? This drives Nassim insane. They did what he likes to call physics as you go. Oh, there's some force holding this all together, but we don't know what it is. So we'll just make up a new force. We'll call it the strong force since it's so incredibly strong. We'll make it exactly as strong as we need to make it do the job we need it to do so our equations come out. And then they throw it into the model and they say, okay, great. We've got this new force called the strong force. But they don't tell you where it comes from or how it got to be that strong. They just throw it in. And that's not the way you should do physics. You should be observing stuff and coming up with stuff based on a source of where it comes from and not just making it up. And it got worse, of course, when they discovered that there's 3 quarks in every proton and those are also all the same charge. And they said, oh, great, now what are we going to do? We're going to have to come up with another force that's even stronger. What are we going to call it? The strong force? No, they got all artistic on us and called it the color force. I love that one. Look that up in Wikipedia. They'll say somewhere in there that the color force is an infinitely strong force. Oh, great. You guys just threw in an infinitely strong force into the standard model. And where does this infinitely strong force come from? What's the source of this? This doesn't get explained. There's a bunch of stuff in the standard model that we take for granted, but it actually is stuff that we haven't been able to define. Even E equals mc squared is like that. Energy equals mass times the speed of light squared. Energy, we don't know exactly what it is or how to describe it, but we know its relationship to these other things. Mass, which we also don't exactly know what it is, times the speed of light, which we don't know why it's that speed, squared. So E equals mc squared is something we don't know equals something we don't know times something that we don't know squared. That's basically where we're at now. We've got equivalences, and Nassim has written a new equivalence in his new paper called Quantum Gravity and the Holographic Mass, which I'll get into, but we really have not gone too far into defining where certain things come from, like charge and all these other forces and stuff. So this is how we got to this idea of the strong force. There's 4 forces in the standard model right now. There's the strong force, the weak force, which is nuclear decay, and then you've got electromagnetism and gravity. And gravity is the weakest of the 4 forces, and the strong force is the strongest, and they just called it the strong force and threw it in there. But Nassim boils this down and makes it a lot more simple. And here's how he does this, is if you think about the strong force, when they were looking at how much force holds the nuclei of the atom together, well, we know that if gravity equals 1, the strong force is 10 to the 38 to 10 to the 39 times stronger. Way, way stronger than gravity, which is why they thought that there's no way that the strong force could actually be gravity. But that's because they weren't considering that the proton is a black hole. If you take the energy density of the fabric of the vacuum out of space, then the proton is very, very light, has very little energy, and how could there be this incredibly strong force holding these things together? But if you don't take the energy out of the fabric of the vacuum, you do not renormalize the energy density of the fabric of the vacuum, then the proton becomes a black hole. And if you start calculating, if there's 2 little black holes the size of a proton spinning around each other at the speed of light, how strong would the gravitational field have to be between them at that scale? It comes out to very, very accurately the strong force as measured in the laboratory. In other words, Nassim is defining the strong force as being gravity acting at the quantum scale, quantum gravity. And the reason it's so much faster is that when you spin something incredibly fast at the speed of light, there's a thing called mass dilation that happens where the mass goes up and the forces go exponential very quickly. As soon as you move even 1 Planck's distance off of the surface event horizon of a spinning proton, the force drops off really quickly, which is another reason why they thought the strong force couldn't be gravity, because gravity drops off at the square of the distance and the strong force drops off much more quickly. And that's because they hadn't incorporated the physics of spinning at the speed of light, causing mass dilation and creating an event horizon. And it means that those are 2 little black holes spinning around each other. And that's a very different way of looking at it and calculating it. When you take all these objects like Nassim did earlier with frequency versus radius, except this time you're doing mass versus radius, you look at the universe, galaxy, quasar, sun, Earth, pulsar. There's the Schwarzschild proton, the proton being a black hole, all the way down to the Planck's mass. And you'll notice right below the Schwarzschild proton, there's the standard model proton. The one where you've taken all the energy density out of it due to renormalization. Notice it doesn't fall on this line. Man, even when the detractors of Nassim's work go after him for some of his physics, no one really goes after this. This is pretty solid. This is very much verifiable by experiments in the laboratory. I think this is pretty solid that the Schwarzschild proton falls in perfect alignment with all these other bodies that obey the Schwarzschild condition. Yet the standard model proton, with its incredibly low mass due to the fabric of the vacuum having no energy in it anymore, thanks to renormalization, falls way below the line. Now, how are we going to get from talking about the mass versus radius of black holes on all scales to Chichen Itza? Good question. This is the point where we move now into the hypothesis of how is it possible that all these objects on all these scales are actually filled with energy, because the space is infinitely full of vacuum fluctuations, even though we perceive it as completely empty. And so here's the crux hypothesis of Nassim's unified field theory. Maybe it is that the structure of the space itself is so perfect, so equal and opposite in every possible way, that no matter where a force comes from in the structure of space-time, there's an equal and opposite structure in the space itself to counterbalance that force so that it equals zero. So all forces from all directions counterbalance and equal nothing, so that we perceive infinite amount of energy to be in perfectly balanced state that we call space, where it seems to us to be empty. So let me reiterate that again. Maybe the structure of the space, and wait a minute, what's the study of structure in space called? Oh, right, geometry. Geometry is the study of structure in space. So the question is, what is the geometry of the fabric of the vacuum of the universe that would account for the fact that space is full, even though we perceive it as totally empty? It's got to be a geometry that is scalar, right? Because space is everywhere you go, from those infinitely large boundary conditions down to the infinitely small ones. So it's got to be a scalar fractal geometry. It's got to be a self-similar geometry, because it's going to have to be the same geometry on all scales to be able to maintain the coherency across all those scalar dimensions. And it's got to be able to get radially, fractally, infinitely bigger and infinitely smaller. So he said, well, I'm going to start looking for an infinitely perfect, balanced geometry, where it's balanced no matter which way I look at it. And it was around this time that Nassim was starting to get tired of teaching his skiing all winter. He would go teach skiing all winter in British Columbia. Then he would get freezing cold and make it through a season. And then right as it started to warm up in BC, he would go to Australia and then teach skiing for their entire winter. And he did about few seasons or years in a row where it was continuous winter, until he said, okay, I'm done with freezing my butt off. I'm going to go to Mexico and go on vacation. And it was around this time, when he was coming up with these theories, that he came across Chichen Itza. And man, whoever built this object right here knew some geometry, right? You didn't just go out there and make a perfect step pyramid like this with all the steps in each staircase, plus the one on the top, adds up to 365 steps. So it's not only a calendar in itself, but on the equinox, when the sun is setting at 5:41 p.m., the sun hits the edge of the pyramid and it casts a shadow on the staircase to make it look like a snake. And there's even a snake head at the bottom. Now, you can't just build this thing and then say, oh, today's the equinox. Everybody come out from the rainforest and we're going to rotate it 2 feet to the left. No, right there. That's it. You have to know from stone one how to build that so it'll do that on the equinox. In order to know that, you have to know some serious geometry. You probably have to know that you live on a sphere, for example. You have to know that you're going around the sun, the angle of the sun. You probably have to know about the seasons and precession, maybe even. These are highly complex geometrical problems to solve. So Nassim thought, I'm trying to come up with the geometry for the fabric of the vacuum that would account for the fact that space is full, even though we perceive it as empty. Maybe, just maybe, there's a clue by looking at the geometry of ancient civilizations' architecture. Okay, so that's how Nassim got to starting to look at ancient civilizations in the first place. He went back to the Whistler, British Columbia Library. A book jumped off the shelf at him. He opens it up. It's Peter Tompkins' book about the mystery of the pyramids. And he studied Mexican pyramids for 30 years. And at the end of his career, he concluded that this city here, Teotihuacan, was trying to explain to us a very important geometric relationship. Teotihuacan is about 100 kilometers from Mexico City. It's got the Pyramid of the Sun and the Pyramid of the Moon, and all these structures that are self-similar in their geometry and in their layout. You can actually climb up there on it. And what they were trying to tell us, though, with the building of all these pyramids was about this relationship between a sphere and a tetrahedron. Now, if you look and take a tetrahedron and you put it inside of a sphere and it perfectly fits in there, it's going to intersect your sphere at the poles, depending on which way you're pointing it, and the other 3 points of your tetrahedron will intersect the sphere exactly at 19.47 degrees latitude. And when you've done that, you've bisected your sphere 2/3 below and 1/3 above, exactly. And this is what the Mexicans were trying to tell us. And so Nassim thought, well, that's interesting. Maybe spheres and tetrahedrons have something to do with the fabric of vacuum of the universe. So he checked out Peter Tompkins' book and started thinking about all these other spheres in the solar system. If you put a tetrahedron inside the sphere of the Earth, what's at 19.47 degrees? Well, the biggest mountain on the planet right now is the big island of Hawaii. It's about 35,000 feet from the summit to the seafloor. It's bigger than Everest. And interestingly, that city, Teotihuacan, that was mapping out this relationship is exactly at 19.47 degrees on the sphere that we're on. So yeah, they very much knew that we were on a sphere, and they knew which latitude we were on even. And so this pointed to Nassim, the fact that the ancient cultures, at least in Mexico, and probably all the other pyramid builders around the world, which we're going to look at, knew about the geometry relationship of a sphere and a tetrahedron. So maybe this is foundational. If you start looking at all the other objects around the solar system at 19.47, what do you find? You find things like the big red spot on Jupiter, which we have some really great new high-resolution images of. And interestingly, just last week, they announced that it's actually getting smaller. Here's the most recent picture of Jupiter. Some great animations just came out, the highest definition animations ever released just last week. And look how small the red spot is compared to what it used to be. It's been there since we were able to observe it about 400 years ago when we first got early telescopes powerful enough to see Jupiter. We saw this storm, a vorticular storm that has stayed exactly at 19.47 this entire time. So you see these lines forming in spheres around the universe. Even in the sun, there's increased sunspot activity at 19.47, where you'd have a tetrahedron pointing up or down inside the sun in relationship to its axis of spin. And so you have a hotter band around the equator of where something is spinning, and colder vortices where the information is curling in and then coming out and then going in. And so that's why you have colder poles on the sun, colder poles on the planet Earth. And then you can look at things like the Weil vortices. These are these triangular vortices where anomalies happen on the surface of our planet. The most popular and known one is the Bermuda Triangle, right? Because so many planes go disappearing there. But there's other triangles all across the planet at 19.47 north and south, where these kinds of gravitational anomalies happen. So maybe it's vortices, vortexes going down towards the singularity in the center of the planet, where you have like a little whirlpool in space-time, if you will, like we see in hurricanes. The largest hurricane ever recorded in the Western Hemisphere is happening right now. It was recorded yesterday as being the largest, most powerful storm ever recorded. They said it should be a category 6, even though the scale only goes up to 5. It broke down rather quickly, but you'll notice it's got really powerful right at 19.47, right next to Baja California is where that hurricane was yesterday. And also look off at Australia, to the west of Australia, there's that triangle. Isn't there a plane that they're looking for right there that they haven't been able to find? And they finally found some pieces of it washed up on an island. That's right around where this plane disappeared not very long ago. It's interesting to me that no one's mentioned the Weil vortices in all of the news coverage that I've seen on that. But in any case, 19.47. I throw in this upside down world map just kind of to show that it's totally random the way our map is. We could have made the Earth map like this and it wouldn't make any difference whatsoever, except the Australians and New Zealanders would be stoked because it makes them look way more important. And Hawaii looks more like the center of the world to me there. In any case, perspective is important. As soon as you get into the looking at tetrahedrons, of course, you're going to come across the work of Buckminster Fuller. So Nassim found the work of Buckminster Fuller, who worked a lot with both spheres and tetrahedrons, and designed, for example, the geodesic dome that they made a stamp out of here, out of his head. Bucky was way into geometry and made some incredible models and Nassim is a big fan of Buckminster Fuller's work. I encourage you to look into him and his foundation. He also invented some really cool inventions like the Dymaxion car. And this is the isotropic vector metric. And I apologize, this graphic is not coming out correctly right now. It should not look like this. It's because we had to do a conversion of my presentation from one format to another. But basically what this is supposed to show you is a tetrahedron made of 20 smaller tetrahedrons. And it's called the isotropic vector matrix. It's something that Buckminster Fuller came up with, a very perfectly balanced figure of tetrahedrons. And again, this is not displaying correctly. This one is. Inside the cavities, inside the isotropic vector matrix are octahedral cavities. And so Nassim thought, well, maybe this has something to do with the fabric of the vacuum, but this can't be it by itself because there's no equal and opposite to this structure. So he thought, what if I took two of these isotropic vector matrix and I put them together, as above, so below, equal and opposite. Again, this one's not displaying perfectly correctly, but when you put them together, then you get this balanced geometry called the star tetrahedron. This is a total of 40 tetrahedrons put together, 20 in one isotropic vector matrix, and 20 in the other isotropic vector matrix, forming the star tetrahedron. And on the inside of the star tetrahedron, those cavities join together and they form this very specific geometry in red. This geometry in red is what's called a cube octahedron, what Buckminster Fuller called the vector equilibrium. The reason he calls it the vector equilibrium is because every vector or every line in this geometry is the same length. All the edges are the same length, and all the vectors that go from the center out to the edge are also the same length as all the edges. This is the only 3D geometry that is in a perfect balanced vector equilibrium state. This is the kind of geometry that you would look for to describe the structure of space-time, because every force that would be present in this space is canceled out by an equal and opposite vector. So he was thinking, well, wait, what does that mean? The whole universe is one giant cube octahedron? No, it's got to be a fractal. It's got to be able to get scalar infinitely bigger and infinitely smaller. So if we have one octave that's a cube octahedron, what about these tetrahedrons are on the outside of that? Those are not in there. These red tetrahedrons right now are not part of this perfect vector equilibrium. So to get to the next fractal iteration, let's start stacking more tetrahedrons onto the outside of the 40 that we have already. And if you put 24 more onto the outside, you get to a total of 64 tetrahedrons. And this right here, the 64 tetrahedron grid, is Nassim Haramein's theorized geometry for the fabric of the vacuum of the universe. And I always pause after I say that sentence, because in 2009 in Los Angeles, I got to this slide. Usually it takes about an hour and 45 minutes to get to this slide. It took me 2 hours today to get to this slide, so I'm actually a little bit behind. I'm going to have to speed up my presentation to make it into 4 hours. I'll warn you right now, I'm guessing that we're going to end up going 4 hours and a half. 4 hours and 30 minutes is my estimate for how long it's going to take me this time. But I think it's fine. I think we can go over 4 hours and you guys won't complain, and it's going to be available. And when I get to the break, which we're going to take a break in a little while, roughly halfway through, I'm going to put up some links. I see some people putting some links into the site. I want to read all your comments, but it's hard for me to read and think about what you're saying and keep talking. But I want to put some links in here to some reference material. But basically, when I came to this slide in 2009 in Los Angeles, and I said, this is the geometry of the theorized fabric of the vacuum of the universe, a 4.7 magnitude earthquake hit exactly at that moment. You can go onto YouTube and look up unified field theory earthquake, and you'll see a little video of me going, don't look at me. I didn't make that happen. Somebody's like, how did you do that? And I said, I don't know. I just somehow aligned my talk to the timing of this impending earthquake somehow. I didn't consciously, I don't think, create any earthquakes, but I somehow aligned my talk to this earthquake. Somebody's saying put a link into the field. I will. I don't want to distract myself too much. Okay, fine. I'll find it. All right. You asked for it. I'm going to find the link right now. You guys will end up all watching it while I'm talking, but that's okay. I hope you guys are hanging in there and that you're having a good time watching this. I'm not used to speaking without anybody in the room, but I'll pretend like you guys are all looking at me right now. Okay, here comes the link for the earthquake. Yeah, so an earthquake happened. I thought, I'm probably onto something. This is probably not totally off base. I took it as a nod from the universe. And so I've been going at this full on for a long time. I've been, doing these talks since 2008 formally, and I saw nassim at first in 2002. So it's been a good 13 years since I was exposed to this information, and it's been a good 7 years or something, or 8 years that I've been doing these talks. And incredible synchronicities have happened to me. Nothing was more dramatic, though, than the earthquake coming exactly when I said this is the structure of the vacuum. Now, you have to remember, this is not a two-dimensional thing. We're looking at a two-dimensional, quote-unquote, two-dimensional screen, a flat space, but it's more like you're taking 8 star tetrahedrons and putting them together and then creating this crystalline 64 tetrahedron grid. And I actually, conveniently enough, happen to have a very large model of a 64 tetrahedron grid right here. So this is a tetrahedral array. You could keep stacking more tetrahedrons onto this thing and get increased size and scale and get to the next iteration. It takes 8 tetrahedrons pointing in to a single point to make 12 radial vectors that are all the same length as the edges of all your tetrahedrons. Though that's a cube octahedron. So the cube octahedron is the first octave of this infinite fractal series of geometry that is the fabric of the vacuum of the universe. When you get to 64 tetrahedrons, you have a cube octahedron inside of a cube octahedron. It's a nested vector equilibrium. So you have perfectly balanced geometry inside of perfect balanced geometry. And when you start stacking more tetrahedrons onto this, when you get to 512 tetrahedrons, you'll get to your third octave. And at 1024 tetrahedra, you get to the next octave. And all the computer programmers at home are going, that's how computer memory works. Remember the Commodore 64? It's because that's how you build memory. A kilobyte is not 1,000 bytes, it's 1,024. And that's why. It's because you're doing octavization of the structure of space. So here's another picture of a 64 tetrahedron grid. I also have, well, thankfully, the model, but a lot of times I'm just showing two-dimensional pictures of it. I have a few smaller ones too that I will make available eventually on my website, 3D printed models of 64 tetrahedron grids. It's pretty cool that you can now 3D print any geometry. So, you can get them like this, and then there's other ones that are color-coded that are this size. I have a necklace that I sell. It's a little silver handmade 64 tetrahedron grid, but the 64 tetrahedron grid is the thing. It's even on my shirt, right? That's why the Resonance Project logo is a 64 tetrahedron grid. It's the first fractal iteration of what becomes infinite scalar dimensions of balanced geometry, of nested vector equilibrium, nested cube octahedron. Someday I want to 3D print a model. My partner Leslie and I working on this idea of making a model, and she wants to spin it and put LEDs in there and light them up so you can see the geometries on the inside as they're spinning. Because you have to remember, this geometry is actually not static, and we're basically flattening down and making super simplified models and descriptions of something that's incredibly complex. Somebody once asked me, what are those lines made of in the structure of space? And I thought, man, I'm not describing this well enough. There's no lines. Those lines are imaginary lines. It's like if you look at a nautilus shell and you see this beautiful Fibonacci spiral coming off the shell, you could draw triangles on there, phi triangles that gives rise to this curve, but you don't see any of those lines on the shell. You just see the beautiful curved feminine spiral as the result of the underlying organizational structure, the geometry that gives rise to that curve. In the same way, we don't see lines in space-time anywhere. These are the underlying geometric frameworks around which all of this dynamic happens, of these nested dual torus structures. So you have to think of space-time as being like a superfluid that is spinning in a vortex to stillness in an overall geometric framework that is the geometry of the fabric of the vacuum, an infinite scalar tetrahedral array. And you have to put spheres around all those tetrahedrons. It's spheres and tetrahedrons. It's not just tetrahedrons, because the universe is not making a bunch of tetrahedrons. It's making a bunch of spheres. But if you perfectly pack spheres together, the thing that holds it together, the underlying connective geometry, is a tetrahedral array. So 8 tetrahedrons pointing in gives you the vector equilibrium. 64 gives you the next octave, just like an octave in music is a note, and you go up 8 notes, and then you've got the same frequency that you started before. You have 8, and you multiply it by 7, and then you get to the next octave, and you multiply it by 7, you get to the next octave, and that's how it goes: 8, 64, 512, 1012, or 1024. And so it's just like an analogous pattern happening in the structure of space as we observe happening in the frequencies and vibrations of the electromagnetic spectrum. Octavization of the vacuum geometry, like we see octavization in frequency. And this is a way that ties together the idea of music and the idea of geometry. Being a musician, I'm very interested in this, and I'm working on music to try to describe more, in a sonic way, some of these ideas. And I asked Nassim about this years ago, and he said, well, we're already making music that's in commonly 4/4 time, and 16 bar phrases are very common. The 32 bar song form is absolutely standard. And so we're already organizing our music in 64 and 512 and all these various geometries. And the next step would be to start tuning our instruments to be more in resonance with the universe. That's a whole nother topic that you could spend hours on, about talking about tuning and frequency and vibration, because of course we tune everything with A being 440, but if you go back in time, you'll see that the early composers and everybody was using 432. 432 is more in resonance with the Schumann resonance, which vacillates slightly around 7.3 to 7.8. It's gotten recently a little bit higher, like 8 hertz or something like this. But the octaves of that would come out to making C 1 hertz, I believe, way low down, making A 432, middle A. That's a little bit divergent in where we are right now, but it all fits together. If you're coming up with a unified field theory, everything's got to start fitting in with everything else, or it's not a unified field theory. An infinite tetrahedral array gives you the geometry of expansion and contraction. 8 tetrahedrons pointing in is a cuboctahedron, the vector equilibrium, and 8 tetrahedrons pointing out is a star tetrahedron. So you have the force of going out, that's electromagnetism, and then the force of gravity going in. Those are the only 2 forces. Nassim has boiled down the standard model from 4 fundamental forces to 2, mapping the only 2 directions that there are, in and out. In is gravity, out is electromagnetism. There's an exchange of information between those 2 forces, and that's fundamental. Somebody's saying C is 256. I think it's octaves down from that. I'm not totally sure. I have to bust out my charts on that. But definitely something cool to look into is this idea of 432 tuning. And there's musicians and producers out there that are tuning all their instruments to 432, making it more resonant. And there's websites where you can convert music to 432, but it's not the same as making the music from scratch with those instruments tuned to that structure. I'm waiting to see the science and the physics that comes out. I'd be very interested to hear. Studies have been shown that music has an influence on your consciousness, and would there be a measurable difference between the same piece of music tuned 432 versus 440? I'm not sure. I'm guessing that there would be, but I'd love to see any studies that are out there on there. Now, this slide right here, I will never forget, because the first time I saw Nassim Haramein speak, he got all the way to this point in the presentation. It was all a bunch of material that made total sense to me. It was based on, stuff I had heard about before, but I didn't quite know how to fit it all together, geometry and stuff like this. And then he busted out this picture of a crop circle. And I was pretty confused because I had read a lot of books for the layman about physics, and not one of these guys, Stephen Hawking or Brian Greene or any of these folks, Fritjof Capra, ever mentioned even vaguely anything having to do with crop circles. And I thought, wait a minute, aren't those hoaxes? I thought there were 2 guys called Doug and Dave that went out and made all the crop circles. Remember these guys? BBC put them on TV and they were like, yeah, we're the guys, we make all the crop circles. As if they could go every day to a different country and make a different crop circle and never get busted and never make a mistake and, never practice. Safe to say the jury is still out on crop circles, okay? There's a lot of debate on these things. You've got the skeptics that say every single crop circle is man-made. There's no crop circles that were not made by humans. And then there's other people that are kind of farther on the other end of the spectrum that think that most of the crop circles are made by non-human intelligence and that some of them are obviously faked. I mean, obviously some crop circles are made by people, like the Pac-Man logo and the ones that are not symmetrical, and there's footprints everywhere and there's boards left in the bushes and stuff like this. But the skeptics will say all crop circles are made by people. It's a bunch of kids that are getting drunk and they've got their boards and their ropes and they're holding this rope that goes to each side of the board, and then they shuffle their feet in the crops and they lay them down. And yeah, there's probably groups of people that are doing that for sure. But then there's crop circles like this one that Nassim points to. This one was the first crop circle that showed up after a bunch of kids went into a field and they stomped into the ground letters with their feet into the crops, and they spelled out, what do we need to know? What are you trying to tell us, basically? And the first crop circle that came back was not an E = MC² crop circle. It was this crop circle showing you a very specific geometry with kind of this fractal iteration of itself on its border, which might suggest that this geometry fractally radiates out to infinity. And of course, notice that there's shading going on here, and a shading effect where part of the crop is lighter than other parts of the crop. This is where it starts to become much more difficult to describe how this would be done by conventional means. So you talk to a skeptic who says that this was made by boards and ropes. How would you instruct a group of people to go out and make sure that when tomorrow our friend flies over the crop circle in an airplane and takes a picture of the crop circle, that the light of the sun is going to reflect off the crops differently in one area of the crop circle than it does in the other area to create this shading effect, making it look kind of 3D. Now, I don't think you're going to just shuffle your board in one direction versus another and be able to cause this shading effect. Not to mention the obvious, which is no one's finding footprints leading in or out, and you can say that they walked along the tram lines, those lines in the background, which is from the harvesting machinery, that you could walk along those tram lines and not be, show any footprints. But you have to walk all around the entire formation itself to create the formation with boards. You would at least see stalks that are broken. And that's the thing, is that a lot of these stalks, they're not broken, they're bent. And it looks like it might have grown faster on one side of the stalk than the other. And there's other anomalies, like if you look at the center of the crop circle, it seems like it's been affected by some sort of microwave radiation. And there's more intense microwave radiation effect in the center of the crop circle than there is on the edge. And again, you're not affecting, microwave radiation with a board and a rope. Also, I've heard about studies being done where they take seeds from inside the crop circle and seeds from outside the crop circle and grew them in a lab. And the seeds from the inside were growing stronger and more healthy than the ones on the outside. The crop circle leaves an imprint of itself the following year, et cetera, et cetera. I could do a 2-hour presentation just on crop circles. That's how much information is out on these things. But just showing you some essential ones. This is that first one that showed up, 1997, near Avery, this mound in England. A lot of the crop circles are in England. Not sure exactly why, but there's certainly a long tradition of spiritual sites, megalithic sites, including Stonehenge, in this area of England where a lot of these show up. But they also do show up in places like Germany, Croatia, Brazil, United States, all over the place. This crop circle showed up second after that last one, showing the same geometry radiating out, also radiating in, the geometry of a tetrahedron grid. It could be a coincidence that the inside of this crop circle maps perfectly to a 64 tetrahedron grid. It could be a coincidence that the tree of life, ancient symbol, maps perfectly here. Again, 7 around 1, forming the octave. Anything I say in my presentations could be a coincidence, no doubt. the chance that every single thing that I'm about to lay out for the next few hours are all coincidence, that all point in the same direction to the same set of information, very, very doubtful. Super doubtful. When I first saw Nassim speak, I have to admit, I was skeptical. And I said, I don't know. I've never heard anybody talk about crop circles. This sounds a little bit out there. You're really going to start talking about extraterrestrials? A physicist talking about extraterrestrials? Man, I thought that was science fiction. This is science and this is fiction, and you don't mix the two if you want to be taken seriously as a scientist. And Sim is one of these rare individuals, you guys, that writes the math of unified field theory. Not many people on this planet write physics to try to unify the math of the big and the math of the small. It's a very small subset of the Earth's population. And of those people, how many of them are going on YouTube openly talking about extraterrestrials and ancient artifacts and, standard model physics that's incorrect and all these things? There's very few people. It might just be Nassim. I really don't know of another physicist that writes these types of equations who's nearly as open about talking about their ideas and even their personal experience having to do with extraterrestrial beings. So this kind of, made some red flags go off in my head, like, wait a minute, I don't know about this. But then the next thing I know, and the more I'm looking into this, the more it all made sense. And the more the dots connected and the deeper I looked into it, the more verification I got, to the point where I thought, at the very least, nassim haramein is closer to correct, in my opinion, in my non-physicist layman's perspective. From all the information I've read, his material makes more sense than the standard model, especially when I read about all the problems with the standard model and where there are gaping holes. For example, they can't unify gravity into their theory. I thought at least Nassim is a little bit closer to truth and correctness than some of the things that I've discovered in reading all this about the standard model. And so I've been on a mission to, investigate further and explain it to other people. And in the process of doing this, I've had a lot of feedback from people around the world who have discovered related things. And I've gotten to meet with some incredible thinkers that have, supported this work through their own tangential, if not directly related, investigations, including crop circle researchers and sacred geometry people, physicists, people that study ancient cultures. And we're going to get into all this stuff in the second half of the talk. But the geometry of crop circles is very specific. It's not just, a random picture of a kid running through a field with a balloon or something. It's geometry. It's this geometry and related geometries. Hexagonal geometries, because the hexagon is fundamental to the vector equilibrium. It's a bunch of hexagons put together. And tetrahedral geometries, and also the idea of cyclical processes, time cycles. Here's a cuboctahedron crop circle with the vector equilibrium and a singularity in the center with a boundary condition. And so the crop circles are showing us very specific information. Maybe we should listen more closely to the information we're getting from the crop circles. This crop circle looks like it could be a spinning vortex. Maybe there's some motion involved here, like a spinning vector equilibrium. Maybe we should learn how to spin some geometry. Notice how this one is right next to these power lines. Are they trying to tell us something? Like, if you learn how to spin stuff that's in a specific geometry at a specific resonant frequency, you might be able to get power out of it. Imagine us running out into a field in the dark. We can't make any sound, no headlamps. We've got boards and ropes and maybe a string to measure distances. But how are you going to make each one of those crescent moons exactly the same at the exact right angle? No mistakes were made. No one had to prop up any crops that were already laid down. The mystery of the crop circles is so profound. It's amazing to me that you don't hear more about it. Obviously, there are genius crop circle makers out there that make incredible art, and I give mad props to those guys that can do really good hoaxes. But then there's other ones like this one that showed up in 45 minutes in the middle of broad daylight across the street from Stonehenge, and no one saw anybody run in or out of this field. It's not like that car on the road there has a bunch of kids on their way to class like, finish your beers, boys. We got to get out there and make a perfect Julia set fractal of 96 circles. Don't leave any footprints. Of course, they're in England. They don't have that accent, but I don't dare try my English accent with people from all over the British colonies, from all over the world. Hi, I'm American. I don't do an English accent. But it's just amazing to me that this thing shows up in the middle of a field, in the middle of broad daylight, and no one saw anybody. It's across the street from Stonehenge. It's not on the front page of the news, but I think it will be soon. I mean, they're getting more and more complex, more ornate, more ridiculous, harder to hoax, I would say. I love this one because it looks like it's popping right out of the ground. It's got this 3D effect. Of course, it is 3D, but it looks flat from the sky. This one, you can see there's a dual torus kind of spinning vortex going on here with kind of symbols around the outside. A lot of these are up for interpretation. You can check out cropcircleconnector.com. That's a pretty good website that catalogs a lot of these things. Just go to Google and do an image search on crop circle, and it's amazing. This is 2 football fields long. It's not any small feat to make these things. To think that somebody's just going to do this during a short England summertime evening. The nights, it's only dark for 6 or 7 hours or something. So you don't have a lot of time to make these. There's a straight up 64 tetrahedron grid crop circle with spheres around each one of them. It's very specific. This one's pi crop circle, encoding for you 3.1459. Here's the decoding of it. You can see that it's like a radial arrangement with a decimal point. And then on the outside, you'll see that there are these 3 circles, and it kind of looks like it's saying ... like it goes on forever to infinity. So it's showing you mathematical and geometric relationships in these crop circles. A lot of times there's tetrahedrons involved. There's energy fields, toroidal, magnetic fields, magnetic field around a tetrahedron perhaps here. The intersection of spherical waveforms forming these little vesica Pisces shapes, pinwheels spinning, time cycles, lunar cycles, eclipses are sometimes predicted by crop circles. Sometimes it's showing you the position of planets on a specific date, like 2012, December 21st. Notice how small these people are on the inside here, and how big a job it would be to create this and make it perfect and symmetrical like this. And look at the weaving pattern on the outside. It's not just flattened down, it's woven together, and none of the crops are broken. Highly organized patterns. Like, you guys better not drink too much tonight. We got a lot of work to do. Can you imagine making this one? Oh, you messed it up. Now we're going to have to prop up some crops that we already laid down. They'll know it's a hoax. It's just amazing, some of these formations. So, look into them because they keep getting more crazy. This one I love because it looks so outside the box, so different than the rest of them. It's almost like graffiti, something you would see, on the side of a subway or something like this. And I think it's funny. My personal thought on this is kind of that whoever is in charge of making the crop circles, let's say they are made by some intelligence from somewhere else. Maybe it's not the greatest job in the world to have to be the crop circle person. Like, oh, I have to go down there and make these. It's so hard to be down there. And sometimes there's bad vibes. I need to protect myself. Not to mention, if you're a craft of some kind, let's say, and you're trying to fly down to the surface of the earth, if you go into USA airspace, what does my government do? First thing they do is they launch a bunch of F-16 fighters. Yeah, planes with guns on it, chasing craft. And so they take off and disappear and probably don't like to come down here. It's pain in the neck. Whereas the Mexicans, they know where the crafts are, and they tell their military to fly around and avoid the airspace where these ships are flying. You can Google the Mexican Air Force footage of extraterrestrial objects flying through the sky, and you'll see that video has been released by the military of a first world industrialized military complex nation, basically saying, check out these lights, these orbs that we don't know what they are, and we're avoiding them, and they're filming them and releasing it. So When I first started doing these talks about almost 10 years ago, when I started talking extraterrestrials, I got way more weird looks than I do now. Now, of course, you've got Ancient Aliens on television, basic cable, an entire show that's in its like fifth or sixth season now, which means that major corporations, advertisers, are wanting to pay money to advertise during a show that basically outlines the fact that not only are there extraterrestrials, but there's many of them, and they've been observing us for a very long time. And we're going to get into this more in detail. But I wanted to show you the crop circles as a kind of introduction to this, because this is what Nassim showed me in my first presentation I saw him do in 2002. And, I was astounded by the phenomenon because I really didn't know that much about it. Now, having researched it a bunch, it's still astounding. You'll see that even the crop circle that looks like it's outside the box and was kind of a graffiti mark of sorts that seems so different than the rest of them, this one is actually in accordance with hexagonal geometries. And all the crop circles are very specific in their geometric information. This one showed up on 8/8/2008. It's the 8808 crop circle. Some kids went in there and added these little bits on the bottom. You can see that they're not symmetrical, but the circles themselves showed up in this perfect arrangement. Now this is showing you that the crop circles are starting to get more complex and have these weaving patterns in them, and that the crops are spun and folded over each other. Sometimes the farmers don't want people to go into their fields, and so they'll say you're not allowed to go check out this crop circle. And so thanks to some ingenious people, they've learned to fly drones over the field and get some great video footage. So you can actually now go onto YouTube and search crop circle and see some cool drone footage of recent crop circles that is in some ways better than any of the photographs prior, because you can really, see it from fine detail to wide angle in one continuous shot. This is one of my favorite ones with this kind of basket weaving pattern. Again, boards and ropes, kids drinking beer. I don't think so. Sometimes a crop circle shows stunning three-dimensional geometry in perspective, like this cube that showed up in 2012. You can look at the fine detail on the right, how difficult it would be to make this perspective look correct when you're running around in the dark looking at what's over here on the side. And again, with this three-dimensional geometry cube perspective, these cubes are laid out in the same arrangement as the spheres are of Metatron's cube, which we'll get into the geometry of spheres radiating out, 13 of them around 12 around 1. So again, it's sacred geometry that's showing up in crop circles, not random shapes. It's very thematic, if you will, and a lot of it has to do with the very foundational geometry of the fabric of the vacuum or the spin dynamics of the fabric of the vacuum. Like this one is fractal spin. You can see it's got smaller and smaller spheres trailing off of each other. Looks like the whole thing is spinning. This is another one, one of the biggest crop circles ever recorded. This one showed up in the middle of the night when it was raining, pouring rain all night. So the media at the time put this on the news because they figured this one probably can't be a hoax. How would they make this without leaving any footprints? The whole entire field was nothing but mud. So Nassim understands the importance of spin. He added spin into Einstein's field equations, adding torque and Coriolis forces. And then he also went on to make a animation, which unfortunately, I apologize, is not going to play in this format. On the break, I will put a link in so that you can see this animation of the solar system that instead of showing the sun in the middle and you tell a kid the earth is over here and it goes in one giant circle all the way around the earth, and when it gets back to where it started, that's a year. And I always remember picturing, oh, I see, I'm 10 years old, so I've gone around the sun 10 times in a circle. And that is dumbing it down, really, frankly. It's flattening a concept that's not flat. In other words, the sun is not sitting still. The sun is moving incredibly quickly through the galaxy. So if you imagine the sun moving as the Earth is going around the sun, it's not making a circle. The Earth is making a giant helix because it's moving with the sun, rotating around the equator of the sun as the sun is moving rapidly through the galaxy. And I will put links to Nassim's early animation that he had to have made about 12 years ago when animation was in its kind of early phases. It's a very rough, approximation of this motion, because in Nassim's animation, the sun is moving and the planets are going around at a 90-degree angle to the motion of the sun, which is incorrect. It's actually a 60-degree plane that the planets are going around as the sun is moving. And then the sun, of course, itself is going in a giant spiral, but it's a very large, very gradual spiral that you wouldn't see at the scale of looking at the planets spinning around the sun. I would love to see an animation that's much more accurate. Some of them have been made. There's a guy, DJ Sadhu, who's made an animation that's more accurate than the one Nassim made, that's partly inspired by Nassim, because his early rendition of it shows a little clip of Nassim's animation that he then builds off of to make it more accurate. And even that one is not 100% accurate. And if you go find that on YouTube, I think it's called The Sun's Vortex Through Space or something like that. If you search sun spiral vortex through space-time, you'll find these animations from DJ Sadhu. There's a new one, a 2.0 that came out. But man, the trolls, the YouTube trolls come out in force and talk about everything that's wrong with that animation. I think we're still working on trying to figure out the relative spin inside of spin inside of spin that goes on in our universe. All these planets have different orbits, and in Nassim's animation, they all have similar orbits. I mean, Saturn takes almost 30 years to go once around the sun, so it has a very large spiral compared to some of the other smaller planets, smaller spirals. And so sometime we should have an animation that's perfectly accurate to the motion of the sun and the motion of the planets. If you say, how fast are we moving, or like, how fast is my hand moving right now, the only way to answer that question is to put a box around my hand, like the screen right now, right? How fast did my hand move across that screen? 3 kilometers an hour compared to the screen. But if you take the box away, because there are no boxes in the universe, thinking outside the box is kind of redundant, because there's no boxes. The universe does not have boxes. It might have boundary conditions. Think outside the boundary condition. Be more like think outside the sphere. Outside of each boundary condition is another boundary condition. It's unbounded. We're in a boundless sea of energy. So if you think about, well, how fast is my hand moving? I'm about halfway between the pole and the equator. If I'm on the equator, then I would just rotate in place 1 revolution in 24 hours. But if you walk to the equator, by the time you're on the equator, you're going something like 1,000 kilometers per hour just from the rotation of the Earth. Then you've got the Earth going around the sun. So it's a spin plus the spin of the sun as it's spiraling out from the center of the galaxy. And the galaxy itself is rotating and moving through space in relation to the background stars. And so there's no real background that you can have as a stationary thing to reference your speed on. It's relative spin inside of relative spin inside of relative spin. When you add up all those spins, we're all moving incredibly fast, close to the speed of light perhaps, but we don't see it that way because we're all moving at the same speed relative to each other, which is how you could be in an airplane and walk down the aisle and like drink a glass of liquid or something like that, and you're moving really fast, but it doesn't seem like you're moving. Same thing is happening with the Earth and the atmosphere with the Earth. We're all moving together, but we're a spiral inside of spiral inside of spiral. So fractal spin animations are great, and I post those quite a bit. This is a GIF image that shows you a little clip, still from the DJ Sadhu vortex video, where it shows you the planets having different orbits and stuff like that. It's slightly more accurate than the Sims. Again, I'll post the links for these things in the chat on the side there when we get to the break, which I assume is coming fairly soon. We're doing half the slides, and it takes me longer to do the first half of the slides than the second half. So the break might come a little bit after the halfway point, which it already is. Leonardo da Vinci is one of these folks that was looking at the universe in a broad sense. He wasn't just working on one discipline. Nassim is doing a similar thing. He's working on physics, but he's willing to look at, geometry and cosmology and quantum mechanics. And then he goes into psychology and sociology and anthropology and looks at even things like crop circles and esoteric information, spiritual information and traditions that physicists don't normally look at. Kepler was able to derive the orbitals of all the planets based on the Platonic solids, based on geometries. He got the resonance of frequency that the planets are vibrating at. They're in a specific geometric series of where they sit in orbit in relation to the sun. This is another GIF image that won't play. I'm sorry. I will post a link to this one as well. This is showing you the relationship, the geometric relationship of the dance between Earth and Venus over an 8-year period. If you follow their relationship, it'll map out a beautiful rose petal kind of geometry. A lot of these things you can find in the Little Book of Coincidences, and I will again post a link to this animation on the break. Here we have Isaac Newton, first guy to start thinking about gravity, and he described gravity as something that was coming from an object, being produced by objects themselves. It wasn't until Karl Schwarzschild here on the left helped to solve Einstein's field equations that we got a more accurate picture of gravity. And again, we've been kind of dumbing it down, I think, by showing kids a picture of a flat surface being dimpled like a trampoline by a ball. Really, we should be trying to convey the fact that gravity is more like something that comes from all sides, that it's not just a flat surface, that we should stop flattening our descriptions of things in general. For a long time, everything was described in terms of spin, and we used things called quaternions. You've probably heard, of course, about linear Cartesian flat space. We all learned in geometry class and stuff about the X, the Y, and the Z axis, and you can map everything in 3D space based on X, Y, and Z. But before we flattened everything, we were using quaternions, which was represented by I, J, and K, and those are the 3 axes of rotation. And you can map these 3 axes with your own hand. If you take your arm and you put it out like this would be I, this kind of rotation. This would be J, and then this would be K, the 3 angles of rotation. And there's even a Middle Eastern dance where usually it's, I think, a woman, but it could be a man too, puts a glass of wine on their hand, and then they have to dance like this and do this 720 degrees of rotation to keep the glass upright and not fall over and spin. You didn't think I would dance in this presentation, did you? Anyway, with that little dance, I think we're at halfway because I'm hitting next slide and it's not going, and we've gone to 122 slides, but I'm not sure. But perhaps we should take a, yes, this is it. We've reached halfway. And so we're going to take a brief break. How long should we break for, Neil? 10 minutes? All right, everybody, we're going to take 10 so you can refresh yourselves, and we will be back and dig into the next phase where we get through the rest of this physics and chemistry and stuff like this and biology, and then we're going to move into ancient cultures and talk about pyramids and stuff like that, which is really fun. So thank you guys for joining. A reminder that you will be able to watch this in the future. We're recording it right now, and you could access this at any point, and the people that weren't able to make this live are going to tune in later. But that is to remind you, to remind others that they can tune in to this talk. I've been going around for years, flying sometimes to the other side of the planet and doing talks in places like Indonesia, India, New Zealand, Egypt, Australia, Portugal, Spain, Canada. And it's fun. It's awesome. I love physically going and talking to people in rooms around the world, but I'm burning fossil fuels as I do it. And hopefully with this, I can now turn a lot of people onto this information by sending them a link, and they stay at home and they don't get into a car or an airplane to go meet me where I flew in an airplane burning fossil fuels. So I appreciate you guys being here, and thank you. So spread the word and take a break. I'm going to put in some links to some of the animations that I was just describing. My apologies for them not playing, we're still working with 2015 technology. Well, hello. Hello, mysterious group of people that I can't see that are all over the world in different time zones. It's pretty awesome. I must say, I'm appreciating this process to be able to do this. It's a great honor for me to be entrusted by Nassim Haramein to deliver his life's work uh, and be given this opportunity to connect with all you folks from around the world. I'd like to remind you guys that if you want to go deeper into this set of material and learn more about uh, the Resonance Project and Nassim Haramein's work, Nassim and I both have spent a lot of time traveling around the world. Like I was saying, physically going to speak to people, and there's nothing like that. It's amazing when you get a bunch of people that are interested in this into a room. Those people are all amazing people, and they meet each other. And in some cases, when I was in Australia, like in Sydney and in Melbourne, at the end of each of those talks, the group was so interested in staying together that we created a Facebook group just for the people that were in that unified field theory talk. You guys are having technical issues? How's it going? Can you see me? Oh, okay, we're good. And so people have been staying in touch. And so, you can keep in touch with people and kind of join a global rising understanding in the nature of physics through a community and an educational platform that was developed by the Resonance Project. And Nassim, when he first started teaching people to do these talks, he taught a group of 12 of us in 2008 in Hawaii, and it was called the Emissary Program. And they learned through doing that it was a good idea to do an incremental step. In other words, do kind of a summary overview weekend program before giving the 10-day full download, learn how to do the presentations thing. And so that was called the Delegate Program. And those were weekend-long workshops that Nassim would teach for a few years until he decided to stay more in the lab. And I took over doing the weekend workshops, Delegate Program. I did about a dozen of them in 2012 and 2013, including places like Barcelona, Vancouver, Portland, Byron Bay, Australia, Bali, all over the place. And then after years of work, this weekend-long program has now been formatted into a full-on online course called the Resonance Academy. And the very first program to come out is called Delegate Level 1. It's, basically a, 6-module based around 10 plus weeks of meeting every time, and they did a pilot program last year, and they're currently running the Delegate Level 1 right now. It's link is in the chat. I just put it in there. You can register for the academy if you want to join. I think it's about a couple of thousand people or something that are in there right now. And every month there's a call with Nassim, similar to this Google kind of chat room situation where you can ask Nassim questions. And each one of these modules is flushing out all of the information that I'm, just kind of skimming the surface of in this presentation, with links to outside incredible materials. Looks like somebody's in the Delegate Program right now. So yeah, it's cool. We've got some delegates that are in there. And like I was saying before, even if you know this information fairly well and you've seen all the videos and you've done the Delegate Program, just to watch anybody describe this, it's their take, it's their interpretation, it's another perspective on this incredibly ornate, multifaceted set of information that literally connects everything to everything else. And so you could spend an infinite amount of time talking about it in an infinite number of ways. And so rehearsing it and reviewing it and getting various people to describe it in different ways helps to cement the ideas. At least it does for me. Every time I see Nassim speak, even though I've seen him so many times, he always says something slightly differently or totally different information I've never heard him say before. So I encourage you to go deeper into this in the Resonance Academy. It's a level of depth of information that is so far beyond what I can say verbally in 4 hours. I can just allude to stuff that there's an entire, pages worth of stuff with links to reference materials and reading and videos. And I created a timeline of physics with Marco, another emissary from Barcelona, where you can look at the last 3,000 years like this, or you can zoom in until you get to 1 decade and you're like, oh, Nikola Tesla was born right there, and this theory of magnetism came around here, and this person's lifetime overlapped with this lifetime. And it's an interactive zooming tool of the history of physics that was really fun to put together. That's in there. And then there's bonus materials, all kinds of videos that were shot by Nassim that aren't available on YouTube, that are only in the Academy. Took a lot of time and effort and energy to put this whole thing together. And so I like to think of it as, the equivalent information you would get from a full-on college course that you might have to, spend a lot of time and energy, money to go do. Instead, you can do this on your own pace. It's a self-study system for months, and you have access to it just like this recording into the future. So it's nice to see these folks over here saying, like, Steve and Jose and Eric, and these folks are in the delegate program. So maybe after this call, we could create a group. You guys could chat or, stay in touch with each other. There's a delegate program group that once you're in the delegate program, you can access that on Facebook. I appreciate everybody, sharing the information on Facebook. I created the Facebook pages a long time ago. When Facebook was first starting to get going, I kind of went to the Resonance Project and said, do you guys have a Facebook page? They said, no, what's that? I said, well, MySpace is going down. There's this new site. And so it's been amazing to watch the information being shared so widely. It really makes me happy because I know that by coming into more resonance with ourselves, then we can apply that to everything that we do. And so it's not just, oh, let's learn about the physics of the universe because it's interesting. It's let's learn about the physics of the universe because it'll affect the way I think and the way I feel about myself and the way I act in relation to other people and the way that I make technologies to, interact people and connect them together. And through doing this and building on the work of people like Buckminster Fuller and Nassim and all these other inventors, we're now getting more coherency, more getting along, hopefully less fighting, and hopefully a different understanding about our place in the universe. And it kind of starts with, properly describing the basic fundamentals of our reality, which is that we live in this thing called the universe. And the one thing that connects all things to all other things is this thing that we commonly call space, which is not empty. It's infinitely filled with energy. And there's a very specific pattern that the energy forms, nesting inside of itself, toroidal dynamics at all scales. And we have these fields of energy that we are made of and bathing in right now, a super fluid medium we call space. And when we describe gravity as a flat surface with a ball making a dimple in a trampoline, that is doing a disservice to the person we're describing it to. And too often that person is a young person that's just starting to learn about gravity. And you're going to confuse them greatly if you say, oh yeah, gravity is this fabric, and they're imagining a flat thing with a ball dipping a dip like you see on this. It's like, no, gravity's pulling from all sides. So at the very least, show them a sphere with a cube around it that's being dimpled on all sides so they can tell that the force isn't pulling just one way, because it's not really even like that at all either. I had William Brown make this slide. William Brown is one of the physicists or researchers at the Resonance Project. The Resonance Project is a foundation that was started, gosh, I don't even know how old it is. It's probably at least 10 plus years old. And it was originally on the Big Island of Hawaii. It got moved to Kauai several years ago. And now there's other researchers working at the project with Nassim on experiments and papers, including William Brown, who made this slide. He's a specialist in biology, quantum biology, and has worked on a paper with an astrophysicist from England named Amira Val Baker, who is also at the project. And Amira and William and Nassim have written a new paper that is, my understanding is it's on consciousness and how biology interacts with the quantum vacuum. And I have not yet seen or read this paper. I do not know when it's getting published. I know that William presented it in Portugal in August, and that's about all I know of that paper, but I'm very much looking forward to that coming out. William Brown put together this slide at the bottom showing gravity a little bit more accurately as this folding in on itself vortex of plasma dynamics. Einstein once said, if I could just describe to you exactly mathematically how my cream disperses in my coffee in the morning, I could describe the whole universe, because that's plasma dynamics. That's really what's going on in the universe. There's way more plasma than there is anything else. Remember I said the sun is 99.98% of the mass of the solar system? Well, the sun's made of plasma. It's highly energized, ionized gas, right? There's solid, liquid, gas, and plasma. And plasma is by far the most common type of matter out there. So if you understand plasma dynamics and you understand space and the structure and dynamics of space, then you really are getting on your way to being able to come up with a unified field theory that describes everything in the universe being connected to everything else. So instead of showing the Earth on a trampoline, maybe you could at least kind of ease people into this by showing them the Earth with a tensegrity grid that's being pulled in to the gravity well that the Earth is forming. At least that would be closer than the descriptions we have now. Nassim takes that a step further, and he describes the spin of the gravitational field. In other words, space-time is not just curving to singularity, it's curling like water going down the drain. And other people have tried to incorporate spin into Einstein's field equations, like Kerr and Newman, who made this example here, but they kind of fudged the accounting for spin part of it. In other words, they attached the observer of the spin to the metric that's spinning, counted how many times it was spinning, and said, see, we accounted for spin. And Nassim is like, wait, that's not how that works. If something's spinning at the speed of light over here, and I'm right next to it, I might be affected by that thing spinning at the speed of light. I'm not spinning at the speed of light. I'm standing still relative to this thing that's spinning at the speed of light. And so that's not properly accounting for spin. Kerr and Newman won the Nobel Prize for this work, where they sort of started to approximate this spin. But Nassim takes it a step further, and he had help here from Elizabeth Rauscher over here on the right. And on the left is Dr. Michael Hyson. He's another researcher that has co-authored papers with Nassim. This photograph, I believe, is probably from around 2009, I'm guessing, at a conference at the Resonance Project when it was on the Big Island. It's since been moved to Kauai. And so the Resonance Project is moving more into a research educational foundation, creating this Resonance Academy that I left a link over there in the chat for teaching all this unified field theory material, and as well doing research papers and publishing results of theoretical physics. And so it's an exciting time to be working with these guys because breakthroughs keep happening. It's a long process. It's taken Nassim a lifetime of work to get to this point. And his biggest jump in understanding happened only a couple of years ago when he published and wrote this paper called Quantum Gravity and the Holographic Mass, where he looks at the structure of the vacuum and of the proton specifically, and describes the dynamics and the structure of the little tiny quanta that make up the proton, the Planck spherical units that are inside there. This model here shows the overall structure of black holes in one slide, with space-time curling and curving, torque and Coriolis forces, spinning, curling like water going down the drain to singularity, forming a black hole, and it's got an event horizon around the ergosphere there, and gravity waves coming out. The torus being the structure that is foundational to all black holes on all scales. So toroidal dynamics would describe the atom itself. A lot of us, I was told that an atom is like a little solar system, with the nucleus kind of like being like the sun, and the electrons being orbitals that go in circles around the nucleus? No. That was, again, a very serious dumbing down, if you will, of the concept. The electron cloud is just that. It's a cloud. It's not like the electron is a little planet that has a point that you can track. It's more of an amorphous field of energy, and the electron goes in to the singularity in the center of the atom and then back out into the cloud, and then it goes in and then out. It's constantly crossing the event horizon of the singularity of those protons in the center of the atom, and it's a toroidal field. And this is the same toroidal field dynamics that would describe the Earth, the sun, the galaxy, stillness in the center with vortex going in and out at the same time. Some great toroidal images out there. Some of them are a little bit more accurate than others. This one looks like it's spinning thanks to the shading. And it is spinning. That's the thing, is that the field is always spinning. It's fractal spin inside of fractal spin to infinity. I'm getting a question. Let me see what this is. Quantum gravity and what? Oh, Quantum Gravity and the Holographic Mass is the name of Nassim's paper. You can go on to resonance.is and hit research and then papers and find the PDF for that paper. It's, of course, a physics paper, and so there's a bunch of math in there. There's also a layman's version of that paper that I believe is also on the website. If not, I can send you a link to the layman's description of the paper, because just unless you're a mathematician, it's hard to know what these equations are saying and their significance. And as a matter of fact, Nassim has said that, he's shown his paper to many physicists that he's talked to that are, PhD physicists, have read his paper and then not understood how incredibly significant these results are, because some of it is just so obvious, so right in front, that it's hard to see past it. I think physics has gotten so incredibly complex that sometimes the ramifications of a very simple equivalence can escape people. He's had astrophysicists be baffled by stuff until he explained it, and then they say, oh, no way, that says this and this is equivalent to this. You mean stars are actually black holes already, and when the star quote unquote dies, that's what we say when a star dies, because they have a life cycle, and they shed all their plasma, then a black hole is formed? And Nassim is saying, no, the star was already a black hole. You just couldn't see the vortex in the center because it's being, covered by this ball of plasma that's radiating all kinds of information: heat, light, sound, x-rays. All this information is coming out of the sun, and yet it's absorbing information. The sunspots are not surface events. They're vortices that are sucking information in and putting it in and putting it out, crossing the event horizon in both directions. And it's curling as it goes, like water going down the drain, a spin. We observe this on the galactic scale, in the planetary scale, even in our own energy field. This is a great GIF that's supposed to move, and I wish it would. I'll post more links at the end to some of the GIFs that I have that are awesome moving GIFs. This one's another one. So is this one. Toroidal fields spinning. You look inside your own body. The energy field that comes out of your body that's stronger than any other field is not your brain, it's your heart. Your heart has a much higher resonance and electromagnetic activity than your brain. More information goes from your brain to your heart than the other direction. And the blood that your heart is circulating is made of little quantas of energy called red blood cells, and red blood cells are toroidal. So you have little toroids flowing through your body. You have a toroidal energy field to the resonance of your heart. You're on a sphere with a toroidal field, magnetic field, that's spinning around your local singularity, a black hole that we call the sun, which is spiraling away from the event horizon around a supermassive black hole in the center of the galaxy, which is traveling along these lines with all the other local galaxies in our supercluster towards the great attractor, which is perhaps a gigantic black hole. So it's scalar dynamics of dual torus, scalar dynamics of black hole. Isn't that interesting that, we are the universe learning about itself, that we are the same dynamic and same structure as all these things on all scales? It seems beyond coincidence to me that we would see this. Perhaps this is a good time to remind you of structures that you've seen people forming. For a long time, people said, oh yeah, if you want to tap into infinite space-time and get enlightenment, then what you need to do is you need to sit like this, and then you sit with your legs crossed. Here, I'll move back a little. You sit with your legs crossed like this, right? And then you put your hands on your knees like this. You've seen people sitting like this in Hindu traditions, Buddhist traditions, and then often they close their eyes, force all of their attention into the stillness in the center of their heart. What shape am I making my body into when I sit like this? I'm a tetrahedron. If you want to gain information directly from the structure of space-time, maybe it would make sense to make your body into the geometry of the foundational structure of the space that you're in, a tetrahedral array. So if you sit like that with your hands, you're making your body physically into a tetrahedron, and then you act like black holes on all scale, where you have information crossing your event horizon going in, and then information crossing your event horizon going out. So you would be doing something like, and breathing. And so by breathing in and out, and sitting like that as a tetrahedron, you're doing the structure and the dynamics of space-time at the same time. That is also known as meditation. So, maybe it makes sense to meditate now. Now, instead of just having faith that I should try this meditation thing, now I can visualize the physics of why it would make sense to do that. Because now I'm pointing all my attention in to the stillness in the center of my existence, what the Hindus and the Buddhists would call the Bindu point, right? You ever seen a picture of Buddha? It's got a vortex going through his crown chakra. It gets smaller and smaller until it gets to a point in the middle. Oh, there's my cat. You get to a point in the center of your heart. That's your Bindu point in the center of your heart. Nassim would describe that as the singularity in the center of your black hole. He would say you basically have your own personal black hole, a singularity in the center of your existence right now. And remember when I was saying that inside of every proton is the energy and the information in the form of vacuum fluctuations that encodes all of the rest of the universe? That means inside of every singularity is all of the information of all the other singularities in the entire universe, which means that you literally have all of the information of the entire universe inside you right now. You do not need to go anywhere. You do not need to look outside yourself. We are the universe learning about itself, teaching itself more about itself so that it can talk about itself more and become more coherent and more organized and create more structures. And it's been evolving and getting more and more awesome and more complex ever since. And so when we tap in to how the universe is doing that, we're tapping into the source of creation. We're tapping into the source of all this information, the source of mass, the source of all these fields, of all these forces. And we're literally learning how to go with the flow and encounter less resistance. You know people who have been able to figure this out. The ascent masters of the world and people that have really, managed to tune themselves in to the structure of space-time have been able to, encode this information and process it and put it out and really help a lot of people to evolve their consciousness forward towards more coherency and less death and pain and suffering. And really that's one of the main goals of why I do this in the first place, is that I really want to create more fun. I want to have more fun and less not fun. And by understanding how the universe works and really cranking torque into the spin of change, then you can really start to steer the ship in the direction that you want to go. I'm a big proponent of putting my attention to where I want things to happen and not putting my attention very much to where I don't want it to go. So I'll mention things throughout talks that aren't maybe the most resonant, greatest things, but I don't dwell upon them, and I don't go into conspiracy theory land and go down the rabbit hole of, the evil people, and all the way down to reptilian extraterrestrials coming to kidnap you and all this stuff. I point towards the most resonant foundational information, the very fabric of the structure that we're in. And so when you look and see what the universe is doing on all scales, and then you can see it happening all over. You look at the Earth's weather systems, for example, you see the Coriolis effect of the spin of the Earth causing storms in the northern hemisphere to spin counterclockwise, forming hurricanes, and clockwise in the southern hemisphere, forming typhoons and cyclones. And this is the way it manifests on our sphere, but it happens all across the universe on all scales. Here we're looking at a structure that's hundreds of kilometers across off the coast of Florida. It's called a hurricane. Then you've got a structure that's tens of thousands of light years across, so many exponentially times bigger than a hurricane, with the same exact structure, with the same Fibonacci ratio, compression ratio, going towards stillness and spinning out in the same way that you see in a carbon particle. This is microns across in the bottom part of the frame. So on all these scales, we're seeing the same dynamic. And of course, nature is mimicking this by spinning in towards stillness. And so maybe we should learn from nature and do what we're already meant to do, which is to be able to go in towards the singularity in the center of our existence. And I like to say that any practice that makes you more self-aware of yourself is something that will help literally center you. If you can learn to center yourself, literally go to the eye of the storm that is you, the singularity in your existence, then you can learn, just how spun out you got last night, literally. If you spin out too far, it's hard to hold it together. And if you learn how to center yourself, then you can hold it together and you can spin faster and get more energy to go out. So if you really want to go out and you want to put out a lot of energy, you don't run on the outside of the wheel and go faster and faster. If you're an ice skater and you want to spin faster, what do? You bring your hands in and you make your center of gravity as small as you can and you spin faster and faster. So maybe that's why meditation is so good at helping you to maintain your vital life force energy. And you might not need to sleep as much because you're able to do some of that neurochemical cleansing that happens during sleep, during states of resonance in your neocortex due to meditation, so that you need to sleep a little bit less. As long as you're sleeping, dreaming, eating, and drinking, biology just seems to do the rest, which is amazing, right? And the funny thing is they call that the unconscious mind that does that stuff. Isn't that funny? The unconscious mind is the one that takes care of your digestion and your breathing and your cardiovascular and the billions of chemical reactions that happen inside your body every second. And consciousness is the one that goes, wait, how come she didn't call me back? Where am I? What's going on? Does she like me? I don't know. I'm so confused. That's consciousness, us being like, what is going on? It seems like we've got that completely backwards. Consciousness is the fact that biology knows very well what it's supposed to do. All you need to do is take care of your biology by eating, sleeping, drinking, and dreaming. Most importantly, dreaming, because you'll die faster by not dreaming than you will from not eating or drinking. People can go on hunger strikes for months and be fine, but if you wake somebody up every time they hit REM sleep, they're not going to last more than a couple of weeks, I think. You really have to cleanse the toxins in your neurochemicals by sleeping to keep yourself alive. And so we're still just barely scratching the surface. We don't understand what sleep is. We don't understand why we need to sleep or what dreams are. And is that reality or not? And, it goes way back into the dream time from the Aborigines all the way to modern sleep research. We're still trying to figure it out. I have a feeling that we're in what I like to call the dawn ages. We just barely came out of the dark ages, as far as I can tell. We're still doing some very strange things. We're not getting along very well. We're fighting against each other. There's still a lot of violence and negative vibes out there in the world, to put it lightly. And I think we can make it a lot better. And part of making it a lot better is to very closely observe, what is the universe doing? How did the universe get here? How do we tap into these fundamental dynamics that we see in the universe and align our thoughts, behaviors, technologies to this fundamental dynamic. Here's an interesting shot, you guys. This is a picture that was taken 3 days ago off the coast of Ibiza, which is an island off the coast of Spain. 2 different people sent me 2 different photographs of this phenomenon that happened in the sea off the coast of Ibiza. And I'm not 100% sure the origin. I think what I've heard is that this is plankton. And then why it's got a vortex right there, I'm not totally sure. But fascinating, because we're seeing the same spiral shape, obviously, same as the galaxy and the hurricanes and everything. Here's the other picture that somebody sent me. I've been asking them to research into it more. There's not a lot online about this because it just happened, but they said the local Ibiza press has been talking about this. Pretty interesting. So we are basically the universe curling towards stillness, and same patterning that you see in a galaxy is happening on a much smaller scale within the biology of your own body. So things that look like are biological organisms can look like cosmological organisms, and vice versa. This image is an old image that Nassim had in his slideshow with this funnel drawn in to show you how stars spiral out along these arms of galaxies. Usually it's 2 arms, but not always. But there's definitely a patterning of an accretion disk forming in a galaxy where there's many more stars. They spiral out, they go up into the halo of the galaxy, and then they come back down and spin back out again. There's a great clip from that movie Thrive with Nassim describing this process. I'll put a link in there at the end. This is a GIF that was made from that animation from Thrive showing the galactic accretion disk with stars going out, going up into the halo, and coming back down. The toroidal dynamics of the galaxy, of course, mapping the same as the toroidal dynamics around your heart, around the earth, around the sun, around the atom. This is the old picture of the galaxy. I say the old picture because I'm about to show you an updated one. But apparently the sun is moving between the Orion spur and the Sagittarius arm, and it's not exactly moving along with the arm. It's going slightly against the grain. You'll notice the sun is about phi away between the center of the galaxy and the edge of the galaxy, which is interesting. So maybe, does that have something to do with this giant shift that we're supposed to be experiencing around this 2012 date? Maybe. Maybe there's a resonance that happens when you're phi away from the center of your galaxy. Your sun gets hit by a lot more gamma radiation, energizes the sun, and causes it to change. There's global warming happening in all of the planets at the same time throughout the solar system. So I don't think it's just human activity that's causing our global warming. I definitely believe in climate change, and I also believe that the sun is got its own agenda, if you will. And perhaps the sun is alive. So a theory that I like to think of is that the universe itself is alive and conscious, and that the sun is conscious, that the earth is conscious. Obviously, the theory of Gaia has been around for a long time, that the earth is a sentient being, which would hold true. If that's true, then the sun is sentient, and so is the galaxy, and so is the universe. And if you're sentient and you're part of the universe is sentient. Maybe all matter is sentient. I think we're still trying to figure it out. We're in the dawn ages. We thought it was a good idea to do human sacrifice not very long ago. It's a drought. Get the virgin, put her on the top of the hill, rip her heart out, and hold it up to the gods, right? I mean, we would do that not that long ago. Then we realized, maybe human sacrifice isn't such a good idea. And then slowly but surely, we've been getting more resonance and treating each other better and better. Hopefully we're going to stop things like discrimination and racism, which doesn't make a lot of sense when you think about the fact that if the multiverse is truly an infinite multiverse, that means that your heart is the center of one of those infinite universes. And so don't forget, of course, that so is everybody else. Because if you go into a party with the vibe of, hey, and you're like the center of the universe, people are looking at you like, who does this guy think he is, the center of the universe? But if you walk into a party and you recognize, hey, what's up, all you other centers of universes, let's party. Then all of a sudden, It's way more fun, and everybody is equally as important. Because, I mean, what are you going to do? Discriminate against the center of the universe? If everybody's the center of the universe, everybody's equally as awesome and important. And things like racism and discrimination don't make any sense at all in terms of the physics. And so we should probably just let go of that. We're all the same species. We have different colors skin because we got different levels of light, and our skin pigmentation depended on what latitude we were on the sphere. It's not that we're different, it's we're different colors of the same species. Can you imagine if at some point in the future we really are directly, commonly interacting with other species from around the galaxy? They're going to look at us and be like, isn't that cute? You guys used to discriminate against different colors of the same species. I mean, when there's blue people and green people, are we going to have different bathrooms for those guys? I don't think so. I don't think we're segregating against the people from the other side of the galaxy. So we should probably learn to get along with ourselves first, then maybe they'll come down and actually hang out with us instead of staying, far away, watching us from far. And, there's a lot of theories on this, but basically we're barely figuring out what's going on around here. Just 2-3 years ago, NASA posted this photo, and I said, no way. NASA is using the same color for their giant 50,000 light year dual torus of gamma and X-ray emissions coming out of the central black hole of the galaxy as Nassim used for his dual torus animation that he put into his Connected Universe, or his Crossing the Event Horizon DVD set 10 years ago. It's literally the same kind of pinkish purple. So I, of course, published this right away. Isn't this awesome? We all thought, oh yeah, the Milky Way is this 100,000 light years across, and it's got this disk. And then we realized, wait, there's a structure that's 50,000 light years, 25,000 in each direction, coming off the central black hole that we didn't know about until we were able to measure it with our more advanced technologies. And it's a gigantic dual torus. And by the way, the galaxy is not 100,000 light years across anymore. That number too changed recently. It's now 50% bigger. It's 150,000 light years because they were able to see that these rings on the outside of the galaxy are not separate structures. They're actually part of the galaxy because we couldn't see through the dust very well until we got more advanced technology. Now we know that the galaxy is 50% larger than we thought. All kinds of information that we thought was true, that people answered correctly on their exams and got their PhDs in cosmology, are now realizing those answers were incorrect. For example, how many stars are there in the universe? They used to say, oh yes, there's 2 sextillion stars. And then they've modified it because then they realized, oh, we're now able to measure dwarf stars better thanks to our new telescopes. So now the average number of stars in a galaxy goes up. So now we think there's 6 sextillion stars, which is a change of 300%. So in other words, we're probably at least 300% wrong about just about everything in the entire universe right now. And if we just went about our business assuming that we're 300% wrong, maybe we would get closer to correct faster than just taking it for granted that everything we've figured out is correct. I remember being told, we're probably the only life in the entire universe because you have to have liquid water, and water isn't very common in the universe. And it has to be close enough to the star that it's not frozen, and it has to be farther enough away from the star so that it's not all evaporated. And so there's probably hardly any planets like that anywhere. Now we're finding Earth-like planets on a regular basis. We know water is on the moon. We know water is on Mars. We know water flows as a liquid on Mars, thanks to information released about 2 weeks ago. We know that there's liquid oceans under moons off of Saturn, that stars are born in clouds of water, that water comes out of the sun. In other words, there's no way we're the only life in the universe. And in one lifetime, in my own experience, I was told, you're lucky to be alive because this is the only place in the universe with life on it. And I just remember thinking, really? Now we know for a fact that has got to be incorrect. Now, we haven't, quote unquote, found life on other planets, according to NASA, but they've been buttering us up, giving us these little crumbs. It's like they're just getting us ready for the fact that, yeah, actually, we've been in touch with these guys for a long time, but we couldn't just come out and say there's extraterrestrials because, boy, there's going to be some upset people, especially the fundamentalists of the world, are not going to be that psyched to hear that their book and the story that they believed in 100% might not be the way that it was. Right now, that's the story, is we've got many different traditions on this planet saying different things in different ways, all pointing to the same seed set of information. And it's going to turn out, I think, that they're all correct, that all of these beings, all of these traditions are all connected, obviously, and we're just telling the story in different ways. Check out the galaxy, check out your baby picture. Yeah, we were all spheres, right? Until our mother's egg was fertilized, and then boom, we were a dual torus. So all of us were a dual torus, literally, physically, in our beingness when we first were born. And then our cells start to divide, and they don't divide randomly. They divide in accordance with the geometry of the fabric of the vacuum. So when you're 4 cells old, you have a tetrahedral bond between your cells. And when you're 8 cells old, you are the vector equilibrium. It's 8 spheres around one. So it's 12 around one. Vector equilibrium is 8 tetrahedrons pointing in, and if you have a sphere around each tetrahedron, they will overlap and form these petal structures called the vesica Pisces. Now, obviously, these are not flat. They have to be 3D. And there's a guy, Michael Evans, who has a great theory that I like, that the vesica Pisces in 3D is a type of platonic solid. Even though the lines are curved, it's a 3-sided object. Perhaps even more fundamental than a tetrahedron, which is 4-sided. And it's the 3D petal structure that happens when you have spherical waveforms overlapping each other. This is key to Nassim Haramein's new paper, Quantum Gravity and the Holographic Mass. You'll notice this slide says 300 trillion cells. I've heard wildly different estimations as to how many cells there are in the human body. I've heard everything from 50 trillion to 300 trillion. I think the number that rests most is about 100 trillion cells. So just imagine this. We are made of 100 trillion cells. Each one of those cells is made of something like 100 trillion atoms. And all of those atoms are little black holes spinning at the speed of light, working in perfect coordination with each other to maintain the kind of coherency that we are maintaining right now. That is a miracle. It's an unbelievable amount of coordination. The fact that every part of your body is communicating with every other part of your body and keeping this coherency is perhaps evidence that information can travel faster than the speed of light. So if you look at, for example, the DNA inside of our body and the way that we divide here and how this maps with the dividing of sphere packing, you can see that we are evolving in alignment with the structure of the fabric of the vacuum. Each one of our cells contains 6 feet of DNA. Sorry, I'm an American, so I'm using feet and inches. But it's basically 2 meters worth of DNA when you stretch out the DNA inside of each one of your cells. So 2 meters times 100 trillion means that you could take the DNA out of your body, stretch it end to end, and go from Pluto around the sun, around Pluto, around the sun, around Pluto, around the sun, multiple times. All that information is compactified inside your finite structure to give you this thing that we call the human body, which is literally billions and billions of chemical reactions happening every second. That is an intelligent, connected universe producing that. Life did not just randomly evolve from the primordial soup. Remember this story? There's the primordial soup, and then a lightning bolt hit the surface of the earth, and it energized the soup. And lucky for us, RNA and DNA formed, and a single-celled organism was born. And then evolution happened over a long period of time, and that evolved into multicellular organisms and multi-organ organisms, and eventually fish and amphibians and mammals and dinosaurs and Homo sapiens. Here we are. That's the story. And I don't think so. I'm sorry. I don't think that life just formed by chance. At the very least, life arrived here on a comet, panspermia style. That's a great theory that I think is a way more plausible than the primordial soup happening to have amino acids in it and it got energized by a lightning bolt, which again is what I got told as a kid. The difference between what I was told when I was in grade school and what I know now is unbelievable. How much stuff that I was told was completely wrong. According to what we know now, they would say that most of the stuff that I was taught when I was a kid is incorrect, as far as I can tell. It just seems to me that, you take anything that we think is true now, go 180 degrees backwards to that, it might be closer to the correct than what we're saying right now. And it's kind of frustrating, because the information is out there and it just isn't getting propagated quite as quickly as it could be. And I think thanks to people like you, it will be. And so I would just like to reflect back onto you guys. Anybody that's on this stream right now, anybody that's watching this in the future, I personally consider you to be a very important seed human being on the surface of the planet right now. We need more people that are asking questions and investigating this stuff for themselves, and then collaborating, comparing notes, and spreading the information virtually, like wildfire through social networks. This is how we've caused some massive change in a small amount of time. In some cases, an individual human can press a button, release a bunch of information that was supposed to be a secret, and change a whole bunch of people's opinion about something that happened. And then they get all onto Twitter and say, let's meet in the square. And they take down a government, and then they take down another government. And then this whole wave of change has been happening across the planet. And it's not just a social, economic, political thing. I think that the same thing needs to happen in our understanding of the structure of our reality and in physics. If you could get people to see the connections, connect the dots, literally, then I think we would increase the coherency of all these various peoples across the planet, and it would just amplify their ability to coordinate and collaborate and get to this next level of consciousness. And it comes down fundamentally understanding the geometry of the reality that we're in, that our biology is made of. If you understand the spheres and the tetrahedrons and how they overlap, the fundamental structures the universe is making, then you can understand the dynamics and the evolution of consciousness and how all this stuff is connected, the mechanics of it, not just spiritually understanding that things are connected, the physical reality of the mechanics of how it's connected. Check out these phi spirals that are spinning in opposite directions. Where they overlap, you get the nodal points of a star tetrahedron. And this will exist infinitely, fractally, smaller and bigger, just nested star tetrahedron. And so this is the foundation of the structure of the reality, is this tetrahedral array. And now when you look back to ancient cultures, you'll see that this has been encoded into all these various traditions. Again, it's about the spheres and the tetrahedrons, both, and the way that they connect. If you take these little spherical units that are the smallest little vibrations of the electromagnetic spectrum at the Planck's length, Planck spherical units, and you pack them all together, the spheres will overlap. They won't be tangential to each other. If you have a bunch of spheres that are tangential to each other, then they leave a gap in between. And we're talking about space being filled by this energy. The spheres have to overlap so that there's no gaps. And when you do that, you get those 3D Vesica Pisces shapes, what Michael Evans calls the trion ray, which is perhaps a curved, three-sided platonic solid, even though it doesn't have a straight line. It's not technically a platonic solid, but it's a three-sided solid. And it is the shape of the Vesica Pisces overlapping waveforms. He says that that's probably the geometry of light. And it would make sense that light has a geometry to it, that it's not just an amorphous thing. You've always heard, is light a particle or is it a wave? And I've learned from Nassim, whenever there's a doubt about something being one thing or another, it's always both. It's not a light or a particle. It's not a particle or a wave. It's both. Like if you look at somebody jumping rope, right, and they're spinning it around, you've got one person jumping in there, they can get it going just right, so it creates a node in the middle, and you can have two people jumping in the same rope. If you're looking at it from the side, it might look like a wave, like, oh, I see, it's like an oscilloscope, there's a waveform. But if you're looking from the perspective of the person spinning it, it looks like a ball and a ball with a nodal point in between. So it kind of looks like two particles from this perspective, and when you look at it from the side, it looks like a wave, which is why light can look like a particle and a wave at the same time. There's actually some great new imagery that came out from a study where they took a picture of light somehow, and they've proven that light is a particle and a wave at the same time. You can Google that one. I don't have the link on me right now, but it's pretty fascinating. We're actually able to image and take photographs of individual atoms now And we know that they're toroidal and that they've got hexagonal features, the bonds between the atoms and stuff like this. So these are great images to give you a sense of this three-dimensional structure, because of course we're dealing with two-dimensional images, but three-dimensional sphere packing is the foundational kind of geometry of the quantum vacuum. Planck spherical units perfectly locking together, forming a three-dimensional structure that if you shined a light onto it and put it onto a flat 2D surface, you've all heard about it and seen it a million times, right? The flower of life symbol. The flower of life symbol is not a two-dimensional thing. It's a two-dimensional symbol that represents a three-dimensional fractal structure. And it's a 64 tetrahedron grid with spheres around each one of these tetrahedrons. You get a three-dimensional flower of life. I would love to find somebody who can fabricate something at this scale where you see all these lines and then around all the tetrahedrons is a lucite, clear, plastic sphere where it overlaps with the other spheres. It's slightly more opaque. So you can see the petal structures and the spheres and the tetrahedrons all at the same time. Anybody know anybody who can do that 3D printing style? Right now, I know that you can 3D print one or the other. Whether or not you can interlace both different materials and 3D print it, I'm not sure, but I hope that's coming soon. This image right here was made by Marshall Lefferts. Marshall Lefferts is the president of the board of the Resonance Project Foundation. He has a great website called cosmometry.net. So check out Marshall Lefferts' website. He makes some great graphics. This is one of his graphics. It shows a dual torus with the vector equilibrium and the accretion disk coming off of the singularity in the center. So it's got a bunch of stuff going on. It's got the toroidal lines. This one doesn't look like it's curling. It looks like it's just vortexing down. So this could be modified to show curling of the vortex, but it's got the phi field patterning coming out from the central singularity, much like the accretion disk of a galaxy. And then you can see these straight lines are the straight lines of 8 tetrahedrons pointing in, forming the cube octahedron, which is the only 3D geometry in a perfect vector equilibrium. Biology is the feedback mechanism for the universe to learn more about itself. And again, Marshall Lefferts made this great image. And, you know, I never thought about it. It didn't hit me until I saw this image that trees are a dual torus, that you only see half of the dual torus because the other half is under the ground. And the bark, when you look at bark, a lot of times the striations of the lines of the bark mimic what you see in the field patterning of things like pineapples and aloe vera and pine cones, a phi braiding of the bark. So biology is really mimicking and acting in accordance with the geometry of space-time. Here you've got the DNA molecule. How many codons do we have in our DNA to make all these amino acids? 64 codons. It could be a coincidence that we have 64 codons, but I doubt it. It seems like our genetic code is tapped into the very foundational structure of our reality. DNA is the best information packing mechanism we've ever seen. Talk about mapping information into a hard drive. Basically, our bodies are an incredibly powerful hard drive. Every single cell of our body has all the genetic information to make the rest of our body. So we are holographic. Nassim is saying that the structure of our reality is a hologram and a fractal and has a geometry to it. So he coined this term holofractographic. He's saying that his theory is holofractographic theory of reality, and we are that. The fact that every one of our cells can be coaxed to become a stem cell that can then be coaxed to become any kind of cell in our body. We are close to being able to clone an entire human from a single cell. Whether or not that's a good idea morally, ethically, or scientifically is another story. But the fact is that we are a perfect living example of a connected holofractographic network. And we're embedded inside of another boundary condition and another and another and another. And we're infinitely embedded in this infinite holofractographic structure that we call space-time. And I think it's going to turn out that our universe is this tiny little itty bitty little dot inside of a much more giant structure. Recently at Lightning in a Bottle Festival, Nassim said a really interesting way of describing our universe, actually, which I hadn't heard him say quite in this way prior, which is that he thinks our universe is a proton that escaped the event horizon of another universe. And the change in density was so great between the universe we were in and when we popped out into this other universe that the little proton had to inflate really quickly so that it would become in equilibrium with the greater universe, multiverse that it had popped into. And that would be the Big Bang. It's not that there was nothing and then there was the Big Bang. It was that we popped out of the event horizon of a much bigger universe and then inflated rapidly to become in equilibrium with the multiverse that we popped into. I love that idea. Whether or not that's proven, we don't have that yet, but it would make sense that according to Nassim's calculations about this specific geometry that's scalar, that you can then estimate how big the universe is that our universe is in and how many there are and how big the next universe would be and how much smaller and the shape and the way the relationship goes smaller than the Planck's distance. It's a hologram and a fractal. And the way that Nassim was able to calculate information about the proton was not from looking at a proton, it was from looking at a black hole at the cosmological scale, measuring relationships about that information and just scaling it all the way down to the size of a proton. And saying, based on the size of this galaxy, knowing that this geometry is scalar fractal and it's self-similar on all scales, I'm just going to take this information and scale it down to the size of a proton and then say, I think a proton is exactly this big down to the 100,000th place. And then, as we're going to see here in a minute, when the facts came out about the proton, it turned out that this new muonic measurement of the proton, which is measuring the proton more accurately than it has ever been measured before, it turned out that it was 4% different than the standard model of physics was saying. And 4% might not sound like very much, but man, 4% different in quantum field theory throws off major chunks of particle physics in the standard model of physics. People were pulling their hair out and said, oh, that's probably wrong. It's an anomaly. We're not going to change the CoData website. This is the website where all the physicists go to get the absolute precise measurements for all these various constants. They didn't change the charge radius of the proton in the CoData website when they first came out with this muonic measurement because they thought it's got to be a mistake, because if it's correct, then a whole bunch of all this physics that we thought was correct is going to be thrown off. And so they didn't do anything. And then Nassim did his calculations, and he predicted a value that was closer to this muonic measurement than the original measurement. Also around 4% off, but it wasn't exactly that muonic measurement. So then he published his paper, December 2012. This is the Quantum Gravity in the Holographic Mass paper, in which he predicted the radius of the proton down to like the 100,000th place. And then, not 1 month later, there was a new muonic measurement that came out of CERN, and they said, this measurement's even more accurate than our last muonic measurement. And yeah, it's again about 4% off, but it's a little bit different. And they gave that new measurement, and guess what? That new measurement was 0.00000036 of a percent off of Nassim's prediction. And you know, good physics is when you make a prediction that hasn't been measured yet, and then it's measured after you make this prediction. That's exactly what happened. Nassim predicted the exact radius of the proton based on a geometric relationship of a cosmological sized black hole, scaling it down to the proton, and nails it. Remember I was talking about you're within one order of magnitude, you're in the ballpark? Nassim was in the 100,000th place of ballpark. We're talking such an incredibly accurate prediction. The chance of it being a coincidence or him being lucky or it being insignificant is very little. In other words, Nassim was able to totally predict something that he had no direct way of measuring because Nassim doesn't own a particle accelerator personally, and other people's physics verified a prediction that he had made. And it's unfortunate that this is not more publicized, let's say. And again, it's because Stephen Hawking can just be like, there's a problem with black holes, and I think I figured it out. And then it's headline news. I went onto my news apps one day, and the top story on CNN was Stephen Hawking figured out the issues with black holes. And I'm like, oh, great. I can't wait to read this paper. Not one equation. Not one equation. Stephen Hawking can be like, oh, do you see that headline about a year or two ago? He says, there are no black holes, says Stephen Hawking. First of all, that's not what he said. First, he said, I think that we have an issue with black holes and that we should relook at them because, Hawking was the first guy to suggest. Prior to Hawking, everybody just assumed that only information goes into black holes. And then, Nassim has been saying this for a long time, but it's not easy for Nassim to get his word out. But the second Hawking says, oh, now I think that we should call black holes gray holes because information goes in and comes out. I'm thinking, wait a minute. Nassim has been calling them black/white WHOLE holes for like 10 years. Did you just read Nassim's paper or something? And it's funny because Nassim has all the equations to describe this, and Hawking can say it with no paper, with no equations, and it makes the headlines. So it's frustrating to me, you can tell, that Nassim is not getting the recognition for making such a powerful prediction like the radius of a proton. Never mind the fact that he predicted about these black holes in the center of galaxies, that black holes radiate information. Hawking said, oh yeah, black holes radiate information, but it was particles that are entangled. One's on the inside of the event horizon and one's on the outside, so one half of this entangled particle can escape, and that became Hawking radiation. And then just a few weeks ago at the Hawking radiation conference, Hawking then says, oh, now I figured out this problem with the firewall, and get this. You ready for this? Hawking's big announcement, his last one, I figured it out. Information doesn't just disappear when it falls into a black hole. It's holographically encoded onto the surface event horizon of the black hole. I'm like, what? This is what Nassim's paper just said in 2012. Did you read this paper and then announce this without crediting Nassim? I have no idea. But it's kind of frustrating that he can just say something like that, and it's #1 headline on all the science news sites, and there's not one equation, there's not one paper. He's just saying it. It's like, where's the math? That's how you do physics. Look at this. And you can put Nassim's equations in front of any physicist. Don't tell him who wrote it. Don't tell him who wrote it. You don't know if it's a boy or a girl. You don't know if they're young or old. You don't know if they're black, white, red, yellow. Doesn't matter. It's just equations. It's numbers. Forget if the guy has a PhD, if he has long hair, if he talks about extraterrestrials. Just read the equation. Does this math work out? Yes, it works out. If Nassim's math was wrong, within 24 hours of him putting it up on the web, there'd be somebody saying, look, see this equation? That's an incorrect math. Your math is wrong. Math is straight up. Math is math. Nassim's paper can be verified. And so I am waiting patiently for hopefully this to be, vetted by other people's work, because right now it's in the realm of theory, because Nassim doesn't have, a team of doctoral students and a gigantic particle accelerator to do experiments. But mark my words, you guys, I have a feeling that Nassim hopefully will be credited as discovering some stuff that is super foundational that has now been, adapted into other people's work, let's say. Nassim has been looking very closely at nature and ancient cultures and physics all at the same time, looking at the entire pie instead of going deep down into the world of physics and trying to add a little bubble under the edge of our human knowledge. He's looking at all the slices of the pie at the same time and trying to see how they're all connected. And so he's not afraid to look at crop circles or extraterrestrials or spiritual information or dreams or things that are considered paranormal or metaphysical. I mean, Nassim is known for saying that anything that's spiritual, metaphysical, or paranormal, all this kind of stuff, is merely just the physics that we don't understand yet, the physics that we can't explain. If I showed up back in time with an iPhone and I said, hold on a second, I started talking to my mom on FaceTime, People would think it's magic. They'd probably want to burn me at the stake and all this stuff, but that's not possible. And then you're like, no, here's how the physics works on that. You've got frequencies of the electromagnetic spectrum. It bounces off of a satellite. It goes to my mom and all this stuff. And so there's ways to describe, and I have a feeling once we understand the quantum vacuum and we understand how the proton is communicating to all the other protons so that they're all interconnected, then things like telekinesis and remote viewing and all these things that are considered totally out there, impossible things will become possible because we understand the physics to describe those things. We see ourselves looking like the universe on a large scale. Our brain cell neural network looks like the early universe, which looks like a rhododendron root system, which looks like the internet, which looks like a mycelial network. The birth of a cell looks like the death of a star. Our eyes look like the nebulas that created the atoms that built our eyes that we're using to look at the things that created us. It's just infinitely embedded. We are stardust is a literal correct statement. Thank you very much, Joni Mitchell. All of the atoms that came out of your left hand could have come from a different star than the atoms in your right hand, because all atoms were created in the centers of stars. So saying we are stardust, saying we are galactic beings is a literal correct statement. So I like to put that forth and remind people of how we are embedded in a field. People are always looking for consciousness and how this all connects. Looking for consciousness in the brain is like looking inside of the radio for the announcer, says Nassim, which is similar to what a lot of other people have said in a different way. But basically to say that consciousness is not in the brain, we have a bio-oscillating crystal in our head. If we can just get our hands on the dial and learn how to tune that in, then we'll be able to really resonate with the fundamental frequencies of the universe. And so it's learning about our own internal mechanism that we use to tap into this infinite field of energy to be able to come to a greater understanding. And if the brain is a radio and it's tuning in the frequencies, then Nassim would say that the heart is the dial that you use to tune yourself to the frequency of your choice. Emotions are a choice, and the way we look and feel about the universe is a choice. And if we can tune ourselves and our resonance to the fundamental resonating frequencies of the environment that we're in, then we could really learn how to tap in and, be in harmony, literally, frequency-wise, with the universe. And so that's where it comes back down to maybe changing your tuning to 432 and all this stuff. But heart resonance is something that is real. You should check out Heart Math Institute. Heart Math has done a lot of research on the heart, the resonances of the heart. I don't have time to go into all this. I'm trying to keep it going because I'm quickly running out of time, even though that's relative. Mathematics is the language with which God has written the universe. And so we see the evidence of that in the self-similar geometries everywhere we look. For example, water, when it freezes, reveals to you the underlying hexagonal geometry of the fabric of the vacuum. All snowflakes are hexagonal in their nature. And then you see this happening in things like flowers and dandelions, in seeds, in sunflowers, Romanesque broccoli. It's a great fractal food. I wonder what would happen if you ate nothing but Romanesque broccoli. You've got pineapples, aloe vera plant. Here's that Fibonacci spiral, phi triangles giving you that curved feminine shape. You don't see those triangles drawn on the shell, but that's the underlying geometry that gives rise to this curve. In the same way, you don't see the 64 tetrahedron grid or a tetrahedral array in space, but it's the underlying geometry of sphere packing. And it's the spheres that are at the Planck scale that make up the proton that is really the foundation of our reality. The more little Plancks you can get to work together, the bigger of a structure you can get. Like when you pull the plug out of your bath and the water's curling down, you can say, oh yeah, that's one continuous fluid. But no, it's not. It's quantized. It's made of these little quanta of energy called water molecules. And all these molecules have to work together to create that larger structure. And even the water molecules are quantized. They're made of atoms. They're not a continuous thing either. And even the atoms are quantized. It has protons and neutrons and electrons. And even the protons are quantized. They're made of quarks. And inside of the proton, Nassim would say there's 10 to the 60 Planck spherical units. A 1 with 60 zeros after it. That is so incredibly big. If you took each one of those Planck spherical units, 10 to the 60 of them that are inside of a proton, and you made them the size of a grain of sand instead of the Planck's distance, your proton would be from here to Alpha Centauri. That's how big your proton would be. That gives you a sense of how big 10 to the 60 anything is. 10 to the 60 grains of sand is a proton with a diameter of 4 light years. So that's a lot of information. So it's really about the Planck spherical units. The more of those guys you can get to coordinate together, the more structure you have. And so that's what builds everything. The first multi-organ animal that evolved on this planet was a jellyfish, which is a torus. So we started out this whole process of evolving from simpler organisms, evolving through being a torus. Nassim is a big surfer. He also has done a lot of rock climbing and skiing and stuff. So I threw this Fibonacci ratio wave surfer image in here. So we are the universe learning about itself. We kind of unfurl in the womb. We're like all coiled up and our spine unfurls like a flower. And we have a very specific geometry. Phi is expressed in various ways in the universe. You've got spirals, you've got phi branching, you've got the phi ratios in the bones of your hand and in the rest of your skeleton. And then you've got the phi scaling angle. When you put circles that are phi bigger than each other next to each other, it forms this 27.5 degree scaling angle. So the idea is fractality and holographic information networking. We see it all over. Even the birds, when they fly in formation, are at phi. And that's not because they're confused and they're following the guy in the front. It's because the guy in the front's making a wave, and they're all riding that wave like bikers in a bike race drafting off of each other. They're using that wave and torquing off of it. Birds are smarter than we thought, imagine. So phi and Fibonacci, everywhere we look, zooming in on itself, curling towards singularity. Every single thing in the universe is a vibration in the structure of the medium that gives rise to all of it. It's the vacuum. It's the energy of the Planck spheres, the quantum vacuum, known as the quantum foam in quantum field theory, known as the plenum, the ether, space, the vacuum, the source field, the 0 point field. Call it whatever you want. Everything is a vibration in the structure of space-time. And there's a thing called cymatics, where you can take water or particulate like sand and vibrate it with different frequencies, and spontaneously various geometries will arise in that particulate. You can check out cymatics.org is a great source of this. Here's a series of notes of a piano scale. I doubt this is tuned to 432, but I don't know. Here's a human female vowel being sung, O. Here's I, E, A. Here's some great cymaglyphs. That's a individual picture of a cymoscope's output. Cymaglyphs for the fundamental frequencies of the traditional 9 planets. I'm counting Pluto as a planet. I guess actually it's not all the planets. It's got the sun in there too, but those are interesting. Dolphins are making vibrations in the structure of the medium that they're in. It's basically, if we can understand the vibration that they're creating, maybe we would understand dolphin language a little bit better. I have a feeling dolphins are way smarter than humans. Just the fact that they have 3 lobes to their brain and they can triangulate their thoughts might be a clue. Our brains are straight up dual torus, right? You've got a torus, and the corpus callosum is kind of like the shearing between the toroids, like the rings of Saturn, if you will. But dolphins can triangulate their thoughts, and half their brain can be asleep while the other half is awake, and they can look inside your body and see if a woman's pregnant, and they're all interested in pregnant women, and they're doing dolphin births and all this stuff. So check that out, cymatics.org. This is a humpback whale cymaglyph, the sound of a humpback whale. If we can just learn how nature is organizing itself, how nature is structured in its geometry, maybe we could then organize our own thoughts and our own technologies to that same geometry. And we're starting to do that. We've got these solar arrays that point all these mirrors towards this one tower, and it's arranged in a flower of life kind of phi spiral arrangement, like a sunflower. And so we're starting to get there with these bridge technologies, but the next level is really to develop technologies that are going to get energy right from the structure of space itself. And that's really where we're headed. All of these bridge technologies like wind and solar and getting off fossil fuels, yeah, we're going to get off the fossil fuels, but we don't really even need to build things like windmills and all this stuff. We're going to get energy right from the structure of space. I mean, When you talk about the quantum vacuum being nearly infinitely full of energy, if you could get 1/1,000,000th of 1% of the energy to come right out of the structure of space, you have unlimited energy anywhere you go. And guess what? It's already happening. I can tell you that there's researchers and inventors around the world that have been working on this for a long time. Nassim certainly has been. And it's a very difficult technological problem to overcome and to achieve. And once it does come out, then it's very difficult to get this information out there because there's a lot of forces, let's just say, in society that don't want this information to come out. OPEC maybe being among them, right? The people that make a lot of money off fossil fuels. You've got, people like Keshe Foundation who makes big announcements that they're going to put out this technology. I know that they did a presentation recently and said they're going to give this technology to various ambassadors. I have to say I've heard a lot of conflicting information. I know there's probably campaigns to discredit people like Keshe. There's certainly people out there that are trying to discredit Nassim. If you look up anybody like Nassim or Keshe or anybody else, Tesla for that matter, right, that were working on these kinds of devices, you've got the powers that be, whoever they were at the time. In Tesla's time, they might have been slightly different people than they are now, although it's probably the same core group that's been propagating. They're trying to put a damper on this. They're trying to put an embargo on this type of information, just like they're trying to put an embargo on the extraterrestrial phenomenon. Because if you understand how extraterrestrial ships work and how they propel themselves, then it's probably the same technology that we're talking about here of getting energy directly from the structure of the vacuum. And once you have that, then people stop buying oil. And the dollar and the euro and all these currencies are largely based on oil more than they are gold now, the gold standard and the silver standard. That stuff's been gone for a long time. So it's quickly can get into the world of conspiracy theory, right? I mean, if you've seen Zeitgeist Addendum, Thrive, all this stuff, you can quickly start asking the questions like, why is this happening? Who's doing that? Who are these families? Where do they go back to? Oh, wait, the Rosicrucians? Oh, wait, the Knights Templar? Oh, wait, the Illuminati? Oh, wait, Planet Nibiru? Oh, wait, the reptilians coming from, like I was saying, you can go down the wormhole of conspiracy theory land forever. It's an endless hole. And there might be some truth to a bunch of these things, right? The Pope, sure. The Vatican, all of these guys. The Vatican owns the solar satellites. It goes all the way deep, man, I'll tell you. You can go check it out. We're going to go into the ancient culture here stuff in a minute. It goes super deep into all these things. And you can listen to somebody like David Icke, who, says some cool things, but at the same time, I feel like it's very fear-based, let's say. And Nassim is adamant that there's no such thing as a bad extraterrestrial. And I'll tell you why he says this. But the idea that, we're going to get kidnapped by extraterrestrials that need to take us to a foreign planet to mine gold for them and all this stuff, maybe a misinterpretation of the translations of Sitchin done on the Sumerian tablets, led to this idea that, oh yeah, there's extraterrestrials that are going to kidnap us and they are going to make us get gold for their atmosphere and all this stuff, or they did in the past. I know I'm diverging quite a bit here from where we were, but this is all actually completely interlocked and related, and it's where all this stuff heads to. And Nassim talks like this all the time. That if you have the technology to build a ship and go cruising across the galaxy faster than the speed of light, you do not need to kidnap a human being to do anything for you, period. That is not, it seems like it's fear-based to me that, we have to watch out for these guys, that they're going to vaporize us. If anything, it seems like the evidence points to the fact that we are being protected by people. And I call them people because they're not aliens, right? If we were here after them, that makes us the aliens, really. Any humanoid extraterrestrial should be called a person, okay? This is how it's going to move forward. We're not going to discriminate against other humanoids and call them separate from us. All humanoids are people. And so those people are probably protecting us. The Cold War was probably the Cold War thanks to the Galactic family, not because we were really lucky that nobody ever tried to set off a nuclear weapon. I mean, I have a feeling that everything's going to be fine. And it's going to be a little bit turmoil before it's fine, but we're going to start realizing our connection to all the other beings that are out there. And it's a beautiful universe. It's not doom and gloom. The planet Nibiru is not going to jump out from behind the sun and be like, aha, we're reptilian beings have infiltrated your government. And the whole thing. I don't really buy into that. Nassim doesn't buy into that. He is all about the good ETs and as described in detail how he knows from his own personal experience of interacting with these folks that there's no guns out there in the galactic family. You don't need a gun once you understand how this all works and that we're all connected. Because if you have a technology that is instantly feedbacking the information on you like a little star, you don't want to put bad vibes in there. It's going to cycle right back on you. It's called karma in India, but this is a real physics phenomenon, right? If you continuously put out bad vibes will eventually come back out on you. So Nassim would really say, and he would say this literally, that really the strongest force in the universe is love. And you're going to have a hard time trying to introduce the love-on particle to physicists. And Nassim attempted this a long time ago, and he backed off. He's like, okay, it's a little too early. Nassim's kind of got this perspective that he's a little too early, a little ahead of the curve trying to introduce some of the things that he's been introducing into the world. Because, it wasn't that long ago that I started talking about this stuff, but people would look at me like I was insane if I started talking about extraterrestrials. Now, you poll Americans, at least in my country, more than half of the Americans think that there's extraterrestrials. I think it's pretty much well known among most people in the world that it's probably not the case that we're the only people out there. We're starting to be able to map the bigger picture of things and see that it's definitely all connected, all the way down to the geometries that are an Earth-wide, like this hexagon on the pole of Saturn. There's a great little clip of this on the Black Hole DVD that Nassim put out. You can check that out. There's huge hexagonal features on the poles of Saturn, and there are these rings that are caused by the shearing between the toroids as they spin in opposite directions of the dual torus. This is with the light of the sun casting through the rings. I love these Saturn images. And the sun being our local singularity, with vortices on the outside of the sun going to the center of the sun. Nassim would say, if you want to travel to the other side of the galaxy, you have to go into the sun. And going into the sun, you could go to the center of the black hole in the center of the galaxy and then out to the center of any other star. And it's traveling through scalar dimensions of black holes, scalar dimensions of singularity. And so maybe that's why we see ships and objects that have flown into the sun. There's a little clip in, I believe it's in Black Hole, or it was on YouTube, of these, what they call comets, flying into the sun, and a giant ejecta, cosmic ejection happens, coronal mass ejection. And they say that they're comets flying in there, but those are planet-sized ships. Nassim is pretty, gutsy to be a physicist who's willing to go out there and point to a video like that and say, I think these are planet-sized ships flying into the sun. And no wonder Nassim has faced incredible amounts of trolling and ridicule on the internet, including entire blogs about how he's wrong. And they try to dissect it down all the way into the physics. And then Nassim has gone back and written blogs in response to people that have said that he's wrong and addressed all of these issues. But if you fundamentally just only believe the standard model is correct, then you're not going to buy Nassim's argument, because you're going to say a proton doesn't weigh 50 trillion tons. And it's like, yeah, but you're getting it all confused, because first of all, it's mass energy. It's not weight. It's all very, it's very confusing and frustrating in some ways, including being myself, trying to explain Nassim's work and then getting people that just will butt heads against you no matter what you say. And I've kind of come to this conclusion myself personally, and you guys might face this when you say, oh, I just saw this great presentation about unified field theory and Nassim Haramein, and they're like, oh yeah, that guy, the guy who doesn't have a PhD and thinks protons weigh millions of tons, the guy is totally wrong. I saw this blog that says that he's a fraud and don't buy his DVD or whatever. And man, it's really hard to go up against these very specific kind of charges when you, like I'm doing right now, you have to really break it down from the beginning and go through this whole process of how we got where we are. I think that this is all going to become clearer as more and more evidence is compiled by other people's physics. And Nassim's work is starting to gain more recognition slowly but surely, and he's being published by journals and asked to speak at various conferences and is appearing in various media like movies and stuff like this. So we're seeing the evolution happen, but it's obviously taking a little longer than we would like to see. Time is kind of running out on us. Nassim looks all over. He's not just looking at physics. You look at chemistry. Various elements seem to have a very specific geometry. This is the work of Robert Muir, who's at Chicago University. All these various platonic solids relate to various atomic structures, and he concluded that there must be structure in space. The same thing that Nassim was saying as a physicist, but here we're seeing it happening, being said by a chemist. Platonic solids have been around for a long time. These are 3,000-year-old platonic solids in stone from, I think, Scotland. And the platonic solids, of course, are these basic solids of matter that all the sides are the same and they all have the same angle. And there's 5: tetrahedron, octahedron, cube, icosahedron, and dodecahedron. And if you make a circle and you put tangential circles in a hexagonal arrangement, 2 out from the center, you get a total of 13 circles, 12 around 1. And when you connect the center points of all these circles, you get the platonic solids coming out of it. That's called Metatron's cube. And here's a picture of the first multi-atomic molecule ever taken. This is an IBM photograph. Those are individual atoms, and you can see the hexagonal bonds there. So obviously the bees are onto something with that. Tensor properties is the probability where you're going to find the electron in the electron cloud. And again, it's giving you star tetrahedron probabilities or Vesica Pisces trion ray 3D petal shape probabilities. And even down at the subatomic level, subatomic particles have probability patterns that are geometric, like mesons and baryons. And now we jump into the ancient culture aspect, which is one of my favorite parts of this entire unified field theory. And I was thinking that I might do a whole separate long presentation just on the ancient culture stuff, because this is an entire life's work in itself. Nassim has been researching this and very much into the work of other researchers that kind of go against what I like to call standard model of archaeology. One of these researchers that Nassim has great respect for is Graham Hancock. And Graham Hancock has been writing books about this stuff for a long time. He, wrote The Sign and the Seal about the search for the lost Ark of the Covenant. He's written books about Egypt and the Sphinx with Robert Bauval. He wrote this great book, Fingerprints of the Gods, which outlines a theory about an ancient culture that has been lost to history, that predates all of these cultures that we commonly think of as ancient cultures, like Egyptian culture and Sumerians and stuff. And now he's written a sequel to this book. It's called Magicians of the Gods. It comes out in about 2 weeks in the United States. It's already out in England. I have not gotten to read any of it yet. But after I read that book, and in conjunction with all the slides I'm about to show you, I want to come up with a whole ancient culture presentation, because actually I'm hosting Module 5 of the Resonance Academy in December. We're a little bit back from the original schedule because we took a summer break from the Academy because everybody was on the road in the summer. But on December 10th, in the Resonance Academy, I'm hosting the module on ancient cultures. And so I'm going to pull a bunch of new information about pyramids around the world and all these amazing finds that Graham Hancock is going to be writing about, including Göbekli Tepe in Turkey and a giant pyramid that was found to be so old that it has a forest growing over it in Indonesia. And I may be actually doing a trip myself to go see the Bosnian pyramids next year, but that is still being worked out. But there's evidence around the world, like the best example is the Great Pyramid of Giza, right? 2 million 330,000 stones that are 2 tons each, stacked so perfectly that when they put the top stone up there at the elevation of 481 feet, it was only a centimeter off the axis of the base, even though it's a 13-acre base. That is amazing levels of precision. The building tolerance of the Great Pyramid of Giza is a quarter of an inch or a centimeter divided by 2,330,000. That is laser precision. We could not possibly build another Great Pyramid next to the one that's there. If we tried, what would we do? We'd have to go to the quarry where all these stones were cut, and it's about 100 miles away over desert sands. And they had to get these blocks from the quarry over all this sand or put it on a barge, bring it down the Nile, get it on and off of these boats, move it over to the pyramid, and then start stacking them. Now, let's review, shall we, just the standard model of archaeology that we were told. When I was in 6th grade, my teacher said, kids, today we're going to learn about the Egyptians. And I said, oh, cool, this will be interesting. I'm really into this. And then they proceeded to tell me that the pharaohs were the ones who ruled Egypt and that they wanted to be buried in a tomb. And so they they had 150,000 slaves, or was it 50,000 slaves? The number has been vacillating. But in any case, they had a lot of slaves, and they forced them to get these rocks and bring them to the Great Pyramid and stack them up so that they could be buried in there. Now, first of all, no mummies have ever been found in any pyramids ever. Did you guys know this? It's a misconception. They'll show the pyramids, they'll show the tombs of the mummies, and then you assume that the mummies came out of the pyramids. We know where the pharaohs are buried. They're in the Valley of the Kings. I went there myself in 2012 and saw Tutankhamun sitting there. Khufu is buried in the Valley of the Kings. Khufu did not build this pyramid, you guys. They say Khufu needed to build this. Oh, really? Well, the average pharaoh died at the same age as the average male in Egypt at the time, about age 45. And so if you became pharaoh at age 15 or 20 or something like this, then you've got about 20 years to get your tomb built before you die. So quick, start building your tomb. And Nassim, being a physicist, said, oh, I'll do the calculations. Okay, I'll give you every daylight hour, 365 days a year for 20 years. You got 3 million or 2,330,000 stones. You're laying a stone every 6 minutes. You're not laying a 2,000 ton stone or 4,000 pound stone every 6 minutes, where you can't even put a piece of paper between these things. They're so perfectly aligned, and the base has got to be absolutely perfectly flat. Doesn't add up, you guys. Doesn't add up at all. If you needed to move those stones up a ramp, because you have to get them up to the top of the pyramid, right? In order to get them to the top of the ramp, you'd have to move them up that ramp at 17 kilometers an hour. And then they started saying, oh, wait, we found the tombs where the slaves are buried that built the pyramids. And then they did studies on the mummies and found that they were all in perfect health and they didn't have hunchbacks or broken limbs or anything like this. And so they thought they were well cared for. And so now they've upgraded the slaves to well cared for farmers. So now, if that's true, the farmers are only building the pyramid in their spare time when they're not tending to their fields and harvesting their crops, in which case you're laying a stone every 2 minutes or 3 minutes. It's just not possible. The physics of building this pyramid so that it's this accurate is beyond any technology that we have right now. And then you look at the ancient Egyptians and the fact that they have this symbol called the flower of life, and an ancient Egyptian symbol that happens to perfectly match the geometry of the quantum vacuum fluctuations of the fabric of space-time as theorized by a unified field theorist in 2002 using modern technology only available to us in the last few decades. The chance of those two things being a coincidence just seem like zero to me. And if it is a coincidence, man, that's an epic coincidence, because the flower of life is all over ancient cultures. It's not just the Egyptians. You look up flower of life, you'll see it in countries around the world. So this is where I really started wanting to look deeper into Nassim's work, because I thought the chance that you would come to a specific geometry based on the scientific method and modern technology measurements, like the quantum vacuum fluctuations and the density of the fabric of the vacuum and tensegrity grids, working on the work of Buckminster Fuller and all this stuff. How did the ancient Egyptians know about that? They didn't just draw some pretty circles for the hell of it. There must have been a reason. They were obviously super tapped in if they can build the Great Pyramid of Giza. It used to be totally flat on the outside. There's this alabaster kind of coating where the outer layer was kind of a insulating layer made out of a different type of rock that insulates the pyramid. And so it was totally smooth. It's oriented to within 1 minute of 1 degree of true magnetic north. And, somebody like Graham Hancock is not a big fan of this ancient alien hypothesis where people would say the only way that this pyramid could have been built would be help from extraterrestrial beings. Now, somebody like Graham Hancock would say, well, if they wanted to make it exact and it was made by extraterrestrial beings, then why isn't it perfectly in alignment? Why is it 1 minute of 1 degree off? That's a good question. My initial thought on this is that this structure is so much older than we thought. So much older, like tens of thousands of years older, that in geologic time, the tectonic plate that this thing is on has rotated 1 minute of 1 degree in all that time. I mean, it's on the only tectonic plate that could hold this much weight and wouldn't have crumbled from an earthquake in all this time. And you start looking at the Great Pyramid of Giza, it's at the center of the landmass of the entire planet. And, it goes on and on. Check out the Pyramid Code, you guys. Carmen Boltier made this series called The Pyramid Code. I was honored enough to get to speak in an event called The Great Convergence. Man, this was epic. This guy, Tamer, had this crazy idea. I'm going to throw a festival in Egypt on December 21st, 2012. And sure enough, we did. The Do Lab, the folks that do lightning in a bottle, organized this thing called the Great Convergence, and a whole bunch of us, like 300, mostly Western folks, showed up in Giza on December 19th, and we got to go inside the Great Pyramid, and we did all sorts of amazing rituals and had a party out on the Giza Plateau. And I was able to speak doing an hour version of this talk, and I've already been speaking for 4 hours and 25 minutes. I did an hour version of this. And then right after me was Robert Schoch, the guy who came up with the theory of the Sphinx, which I'm about to show you here, of the Sphinx being much more ancient. And then after that was Hugh Newman from Megalithomania, another great researcher. Check out his work. I think it's megalithomania.something. And Robert Schoch's work, and then Carmen Boltier spoke after that. And that's the Pyramid Code, a great documentary about the pyramids. You can see here on the lower right that opening is where you walk in. That big hole that's there on the side, the first white male Western explorer that found this pyramid did what any good white male would do when they can't find a door to something. You just blow it up. Stick a bunch of dynamite on the side of this thing and blow a hole in the Great Pyramid. Can't believe he did that. And somehow found this chevron, this opening. This is the Grand Gallery, which is this staircase that goes up at 26 degrees, half of the angle of the outside of the pyramid, which is at 54 degrees. And goes up into the King's Chamber. There's 2 chambers, right? King's Chamber and Queen's Chamber. There's nothing to do with a king or a queen. It's totally random that they named it that because there's no hieroglyphs on this thing. You would think that, when you have hieroglyphs all over Egypt describing everything about your society, that somewhere in there you would say, oh yeah, by the way, we built this pyramid over here, the coolest thing ever made. There's no hieroglyphs describing this anywhere. So the theory is that perhaps the Great Pyramid of Giza is much older than the Egyptian culture itself. And boy, does Zahi Hawass and the Egyptology departments of the universities there do not want that theory to be propagated. They're very proud the Egyptians built this, but I think it remains to be seen. The fact that you've got the inclination angles, for example, of the Great Pyramid perfectly matching the angle at which a rainbow forms to your field of view when you're looking through mist, right? When the sun is hitting, the angles are either 42 or 52. And these are the angles of inclination of the Great Pyramid. And in the Pyramid Code, it outlines even more outrageous stats about how accurate the pyramid is describing phi, pi, the speed of light. It goes on and on. I don't even have time. I could do an entire 4 hours just on this one building. any one of these subjects could be an entire presentation. So check it out. The Great Pyramid of Giza is the only large-scale pyramid in the world that's actually 8-sided, and you can't see it unless it's a certain day and certain lighting from the air. So it goes deeper and deeper than we even know. And then you look at the Sphinx, which is just down the hill from the Great Pyramid, and the body is a different level of erosion than the head. And the long story short here is that this probably used to look like a dog or a cat, and a pharaoh came and recarved the head to look more like him and make it more into a pharaoh. Then you've got Robert Schoch, who's a geologist from Boston University, who looked at the Sphinx, and it used to be totally buried in sand. It got dug out. When the first troops came from England, they were hanging out here on it, and then they started digging it out. There's a big stellate there in between the paws, and the erosion on the back of the Sphinx was caused by rainfall. It was not just wind and sand that carved it out. This used to be a hill. It was kind of cut out of the rock, like Mount Rushmore or something like that. It wasn't built out of bricks. And Robert Schoch looked at the erosion on the back of the Sphinx, and he knows this kind of erosion very well from studying geology. And he looked at this area of the world and noted that there's no way that enough rainfall would have fallen to be able to create that kind of erosion in the last 5,500 years. And commonly, the standard model of Egyptology says that the Great Pyramid and the Sphinx are both about 5,500 years. We've got the last batch of slides loading now, and I'm going to speed through it. I thought I would be done by 4:30 by now, but I'll probably take another 30 minutes if that's okay for you guys. You can always watch this later on. If you're fading, no worries. Thanks for hanging this long. We're going to do the final stretch here. This is my favorite picture of the Sphinx from 1887. Can you imagine wandering through the desert and coming across this as a Western explorer? Whoa, who made this, and how did this get here, and why is it here? If you look at Leo and the constellation and where it rose on the horizon, 12,500 years ago, it rose exactly in front of the Sphinx. And we're starting to see through the work of people like Robert Bauval, Graham Hancock, and others that the Sphinx and perhaps all of Egypt's ancient sites are much older than what we were told in school. This is happening left and right. I remember vividly being told in elementary school that human beings started using tools and languaging maybe 10,000, 12,000 years ago, maybe 15,000 years ago. It turns out how incredibly wrong we were. They just recently found a shell that has cross-hatching, etching markings on it that was put there by Homo erectus. We're talking 2 hominids before Homo sapien. So they were only off by like 485,000 years on that one. Yeah, that's how incredibly wrong we've been in the world of archaeology and the stories of early human history. Graham Hancock is about to drop a serious bombshell with this new book. His book is going to outline that a comet broke apart in our solar system 26,800 years ago, I believe. I'm sorry, I'm forgetting the exact date. It's going to be obviously set out in Graham's book. That a comet broke apart and a fragment of this comet or a very large meteorite, one or the other, we're not sure, hit northern North America. And he traveled across North America with a geologist looking at the impact crater edges of this thing. It's so big that it flash melted a bunch of the pole, and all this ice melted, and the sea levels of Earth rose by something like 400 feet in a very short amount of time. We're talking days or weeks or something, or maybe it was months. But fast enough that it submerged all of the advanced civilization that was on the planet at the time. And so what did he do? He learned to scuba dive. And Graham Hancock has been scuba diving around the planet, collecting all this evidence for this cataclysm that happened. And it's been documented very well, by the way, by 300 ancient cultures. It's called the Great Flood. The Great Flood was a rising of the oceans due to a cataclysmic event. Not too dissimilar to the cataclysmic event that took out the dinosaurs, but this is much later. Instead of taking out the dinosaurs, it took out a very advanced civilization. Perhaps the civilization that left the Sphinx, the pyramids, Göbekli Tepe, and these other ancient sites that he's going to lay out in this new book, Magicians of the Gods. Man, I cannot wait. I've already got it pre-ordered. As soon as it comes out, it comes to me, and I read it. And then I compile all the rest of my ancient culture slides to add with these right here, and try to give a condensed presentation on not just Graham's work, but Nassim's thoughts on all this and all these other researchers. Michael Tellinger, Hugh Newman, Carmen Gaultier, all these folks that have been studying this stuff. The elongated skulls and Brian Forrester, all these folks, mad props to all of them. We know that the Sphinx was carved and that there are these blocks that are in front of the Sphinx that are 100 tons. They were cut out of the striated walls back there because they can match the strata on the blocks with the strata on the walls. 100-ton blocks. Why do you come crawling out of your caves 10,000 years ago and start building stuff out of 100-ton boulders? Even Donald Trump and Bill Gates and billionaires and people don't build anything out of 2-ton anything. It's not practical, and there's no reason to do that. And yet we see these megalithic stones, huge statues, the heads on Easter Island all the way down to Göbekli Tepe and pyramids around the world with massive stones. How did they do this? They might have had some help, not maybe even from other races, but maybe they had a technology, at least, that's different than the technology that we know of today that we would use to build this. Here's a picture of the edge of the Sphinx encasement with these striated rain erosion lines. I took this picture myself. I was happy enough to get to finally take a picture that I use in my presentations. Having talked about this for a long time, I was able to take this picture as well of the back of the Sphinx. The bricks there are repairs that were done much later. I'm talking about the erosion on the very back of the Sphinx. There's actually a trap door in the back of the Sphinx and tunnels that go underneath the Sphinx. I would check out the work of Edgar Cayce, and I would check out David Wilcock and all of his work in the source field investigations, because he has a lot to say about ancient cultures as well as galactic civilizations. So when Robert Schoch was asked by his peers to present his work about the Sphinx, it was a setup. And he said, I think the Sphinx might be twice as old as you guys think. I think it could be 10,000 years old. He really wanted to say 30,000 years, but he didn't dare say that because, like Nassim, he was going to stick his neck really far out amongst his peers. And it didn't go over very well. They, ridiculed him and said, oh, really? The Sphinx is, tens of thousands of years old. Show me one shred of evidence of this ancient culture. And of course, there was no evidence beyond the Sphinx at that time because we had not discovered Göbekli Tepe yet. Göbekli Tepe in Turkey is carbon dated to 13,500 years ago. That's 7,000 years older than the supposed age of the Great Pyramid. And these are megalithic, gigantic stones, perfectly carved. It was intentionally buried to be preserved, perhaps, and that's why we still find it in good condition. I took this fisheye of the Sphinx because I love fisheye photography, and so I had to get at least one fisheye in there. This is King Ramses II, an 82-ton statue that when they found, they realized they had to build the museum around the statue rather than moving the statue to the museum because they were going to have to cut it into multiple pieces to be able to move it. We can't move this statue today with land cranes that drive across the sand. How were they able to move this thousands of years ago? Look at the level of symmetry that they were able to achieve. This could not have been done with hand tools. The amount of precision is like laser precision. It's beyond our capabilities. You look at Abydos and the Osiris Temple. This is in the Nile Valley. And look at these stones. These are 100-ton granite boulders that were put down onto other 100-ton granite boulders, tongue and groove. You can see that there are these little grooves in there setting these stones on top. So now we're lowering 100-ton granite boulders before the invention of the pulley? I don't think so. These guys had some crazy technology. Notice how far down below the surface of the sand this thing is. This is such an old temple that geologic time buried it, and then it was dug out, and it happens to be next to an Egyptian temple. So they assume that this temple was built around the same time as the temple that it's near, whereas the evidence really points to this fact that this is way older than the Egyptian temple nearby. And then if you look on this 100-ton boulder that's perfectly cut on the side there, what do you see on there? Look closely. It's the flower of life. the geometry of the quantum vacuum fluctuations, the packing of spherical Planck pixels in the quantum vacuum that makes up protons, that makes up atoms, that makes up molecules, that makes up everything that we see, is in this pattern. Now, did they just happen to put that on there? It's more likely that they knew that this was the fundamental patterning of creation, and it's put onto the side of this rock. Now, if you've seen the trailer for Thrive, you've seen Nassim say that this was laser burned into the rock, okay? Now, this is way up for debate. Shortly after this, the guy who said this originally, that Nassim was quoting, I think it was Greg Braden, who got it from somebody else who did a study on it, and now we can't find the original study. In any case, they say, no, this wasn't laser burned. This is red ochre. And there is red ochre marks on the side that's graffiti that's much more thick, like awkward marking. This is very thin, very accurate markings that have not worn off from sand and wind and erosion for thousands of years. And it looks like it might actually go into the rock. In other words, if it wasn't a laser, then there was some way that this was embedded into the rock. We're not sure exactly how. I'm saying the jury is out. Nassim is more on the tip that this was laser etched. People like Brian Forrester have publicly come out and not mentioned Nassim by name, but I've seen him post about how some people think this is laser. It's not. It's red ochre. Here we are. You can check out his videos of him, showing this. And I asked Nassim about this, and he says, yeah, but these lines are so accurate. It can't just be somebody who's, writing Greek graffiti on there, which is nearby, who's putting this perfectly in here. Notice the corpus callosum, the double line on the outside with the zigzag line. That's because this is encoded. This isn't even the whole flower. The flower of life is encoded because they don't want all of that information revealed. This is a two-dimensional symbol that's really representing a three-dimensional structure, a three-dimensional flower of life, which is sphere packing. It's not circles. We're talking spheres, because the universe is not making circles. It's making spheres. Here it is. The Egyptian symbol matches the geometry of Nassim's theorized geometry for the Planck spherical units that make up the quanta of the fabric of the vacuum that make things like protons, which make atoms, which make everything. The flower of life is the field patterning of our existence. And I've done muscle testing where I've stood and had my balance checked, and then they said, look at the flower of life. And I was looking at this symbol, and then they couldn't knock me over. And man, am I skeptical. I don't like muscle testing. I feel like there's something wacky about this. You're pushing harder this time, I want a machine or something that pushes exactly the same amount every time. But I had him do it over and over and over, and it freaked me out because I literally would get knocked over. And then when I looked at the flower of life, I would be able to hold my balance way better. I don't understand exactly how that works, but I had this experience. And so I'd be curious to see if anybody else has had muscle testing experience of looking at the flower of life versus not. We'll see. But in any case, the flower of life is more like this. This is a computer animation Nassim made to show you this kind of overlapping spheres. I really want to get a 3D printed, clear lucite flower of life made. But it's about the tetrahedrons and the spheres put together that gives you the reality. This is called The Glyph Maker by Charles L. Gilchrist. He's another great sacred geometer, if you want to call it. Man, I have some really big I'm fans of quite a few people out there in the world of art and geometry, and specifically even in the world of Facebook pages. You could check out Cosmic Creations is a great page. There's a guy in Australia, Jane 108 Mathemagics on Facebook. I'll put some of these links in there if you want. You can check out also, when I do all these posts on Facebook, I tag a lot of these pages. So if you just go back through all the Resonance Project and Nassim Haramein Facebook posts, you'll see all these pages. I tag pages related to the thing I'm posting about. And in there, you'll see, a bunch of really great pages from people that make this kind of art and geometry. There's Cosmic Armor, Cosmic Creations, you'll see them all in there. It's about the flower of life and the tetrahedrons coming together. This image on the top gives you an idea. I want a 3D model of that. you guys could figure out how to do that, that would be great. Here's a model of glass, I think, and metal. It's very basic, but here's a cool image that shows you the 64 tetrahedron grid and the flower of life overlaying on top of each other. This is the field patterning of the fabric of our existence. So this would be kind of a very rough estimate of the proton with this flower of life tiling. Now, people have reminded me, and I know Nassim is aware of this, that you can't perfectly tile a sphere with other spheres, that eventually you have to have a hexagon in there to create full patterning. And maybe perhaps where that hexagonal patterning is where you'll get a vorticular action going down towards singularity. And so perhaps that's the Bermuda Triangle, is the hexagonal feature of the larger scale flower of life sphere packing. But I'm not sure. This is just me hypothesizing right now. But there's still work to be done on this, but I think that the underlying principle is that the Planck spherical units pack themselves in this 3D flower of life lattice network. And this is the quantum vacuum fluctuation patterning that causes protons to be formed. And we see it encoded into all these ancient cultures around the world. Things like Stonehenge are laid out in flower of life tiling. And you see pyramids all over the world. And a pyramid is not a tetrahedron. A tetrahedron has a triangular base. It's four sides that are all equilateral triangles. And a pyramid is actually an octahedron, one of the Platonic solids, cut in half. So a stellated octahedron has a square base. And if you look at a tetrahedral array and you check out the faces of any of the sides of a tetrahedral array, these cavities pointing in here, that's a pyramid. So it's a pyramid and a pyramid and a pyramid. There's four pyramid faces going in on this 64 tetrahedron grid. And so a pyramid is the resonating cavity that forms in a tetrahedral array. So the Great Pyramid of Giza and all the other pyramids are actually resonators. So the resonance project, yeah, resonance is key. Resonance is vibrations that are happening that are in harmony or sympathetic to the structure, or sympathetic to the vibrations that those vibrations are happening within. So it creates a specific energetic nodal point in the vibration of the structure of the vacuum. So the pyramids are potentially energy generators or capacitors built to hold energy. There's a great book you could check out called The Giza Power Plant that outlines this theory that the Great Pyramid of Giza was actually built to be an energy device, and it purified water, and they fed the crops of the Nile with it, which is maybe why we find petrified papyrus reeds that are gigantic, 8 feet tall and all this stuff. And this is a pyramid that was found in the interior of China. It wasn't known until much more recently that there are pyramids in China. The ones in Egypt and in Mexico are obvious and have been visited for a long time. But in China, they've been a little bit more hidden, to the point where the government asked the locals to farm on them to help conceal them. But since then, Western people have been able to go in and explore them. They even put really thorny, spiny shrubs on there so that it's difficult to walk on there. Maybe they don't want us to know that these pyramids are way more ancient than we thought. And you can look at the orientation of these pyramids on the surface of the planet in China, and this is the work of Robert Duval and Graham Hancock again. On the left, you have China. The next one to the right, you have the Giza Plateau in Egypt. The next one to the right, you have the Pyramid of the Sun in Teotihuacan. And then off on the far right, you have the stars in the constellation Orion, in Orion's belt. And it was the work of Robert Duval and Graham Hancock that figured out that what the Egyptians especially were trying to do on the ground was map a place in time and space in the sky. And that would correspond to 12,500 years ago. So their theory is that the pyramid is at least 12,500 years ago, not 5,500 years ago. And it points to the fact that there perhaps was one central, gigantic, global, ancient civilization that's been lost to written history that predates all these other cultures. Why else would we find incredible similarities in everything from their symbols to their documents to their monuments? I mean, Cambodia and Guatemala, I never thought of these two countries as being that similar, but look at how similar these structures are. It goes on and on, right? You've got statues as far apart as Turkey, Indonesia, and Easter Island that have the same facial features, the same hand positioning, and they couldn't be farther apart from each other. So it could be a clue that we're missing a very big, important chunk of our early history. And I love the fact that somebody like Nassim Haramein, who's working on field equations, writing equations about the structure of space-time, has also spent a considerable amount of time doing that same rigorous analyzation of all prior knowledge and adding all new knowledge to come to a new understanding in physics. He's doing the same thing in archaeology and in archaeological digs and anthropological information. He sometimes doesn't like to be filmed when he's talking because he doesn't say some stuff that's kind of derogatory towards the archaeologists, because they'll just say crazy stuff like, oh yeah, the pharaoh was buried in there and needed to build it for his tomb. And it was like some guy said this a long time ago and people just stuck with it. You got to go back and re-look at the early origins of humanity, because we see commonality that is beyond reasonable doubt. Like, all these cultures had similar structures, similar symbology, and the pyramids also all over the place. Look at this: Indonesia, Mexico, and Egypt, step pyramids, the triptych of these three doorways being spaced the same proportions, same relative heights. Why would you build it exactly the same? I mean, you'd think you'd see a little bit more variation in these places all over the planet. This is the work of Richard Casero. He's got a book called Written in Stone, which is really cool. He made these images. Not only do we have step pyramids and triptychs and these vaulted ceilings like you find inside the Great Pyramid, you also have the idea of mummification. Mummification is in China and in Egypt. It's all around the world. You've got ancient mummies in China, ancient mummies in Egypt. You've got the Sphinx in China, and you have the Fu Dog in China. The Fu Dog is supposedly guarding the entrance to the Forbidden City, but what's he really guarding? What does he have under his paw? He has a 3D flower of life under his paw. This is the geometry of the Planck spherical units that make up protons underneath the paw of this ancient Fu Dog. And I was very fortunate enough this year, on my way back from a tour that I did in Australia and New Zealand. I actually did a talk in India for the first time this year. I was able to go to Beijing and for the first time make it to the Forbidden City so I could take this picture. Again, just like the Sphinx, I really wanted to go and see this for myself. I unfortunately didn't get to go to Abydos and see the Flower of Life on the side of the Siren Temple because the local government closed the road. And we think it's because they didn't like our group very much. We actually threw a party on the Giza Plateau. And I don't think they were too into our vibe. And so I'm guessing they closed the road so we couldn't go there. But in any case, I did get to the Forbidden City and get this picture. You can see here it's behind a little wall, so I used a selfie stick so I could get the phone up close to it. And the Fu Dog's actually sitting on a square pedestal with a carpet that's turned 90 or 45 degrees, so it forms an 8-pointed star. And the fabric of the carpet that he's sitting on is also tiled with like hexagonal tiling. And so they're just giving you the structure of space-time right here in front of the Forbidden City, who's supposedly the Fu Dog is the protector of the information, or the protection of the knowledge. And so I took a fisheye too of it because, of course, I'm with the fisheye. And then in the garden, in the back of the Forbidden City, there's this statue. My partner pointed it out and said, check this out. And she found here that there's this flower of life patterning underneath the urn. And in the middle there, beyond this dragon, you see a flower of life sphere with 4 bows crossing over each other. And now Nassim would say that this is evidence of a quadrupole. that you've got two poles going in and then two poles spiraling out, and the bows might represent the toroidal dynamics. This is just behind it's actually at the very back of the Forbidden City, right before you go out. So if you go in through the front entrance, the first gigantic courtyard you come to has the food dog, then you go beyond a palace and beyond another palace, and eventually in the back, in the gardens, there's an urn statue, and underneath the urn statue is this. I had to stick my selfie stick in there, pointing down to get this shot. And I've never seen anybody else with these photos. Flower of Life is there as well. And here's another 3D Flower of Life. This one is outside of the palace in Bangkok, Thailand. And so Nassim, looking at ancient Chinese information, you've probably heard of the I Ching, which is made of 64 hexagrams, just by coincidence, 64, right? 64 hexagrams that are either 6 solid lines or 6 broken lines. And Lao Tzu, like I was saying, the Tao of Physics, he's describing these symbols in a poetic, symbolic kind of way. But Nassim is looking at these literally. Okay, if I had 6 sticks, the only thing I can build is a tetrahedron. And if I want to build a 64 tetrahedron grid, I need 8 star tetrahedrons put together, right? And so what do you need to make a star tetrahedron? You need a tetrahedron pointing up and a tetrahedron pointing down. So if you have 6 sticks that come together to make a tetrahedron pointing up, what do you need to make another tetrahedron pointing down? 6 broken sticks so that they'll pass through the vectors of the original ones. Again, this is supposed to be an animation that's not going to play, but I will stick a link here when I finish here in a minute. I'll stick a link in here to the animation of these lines animating. It's also in Nassim Haramein's Black Hole DVD. That is that the I Ching is the most foundational geometric information that you need to create the geometry of space-time. And I don't think it's a coincidence. 64 hexagrams, 64 codons. It goes on and on. They also, of course, figured out the dynamics of the fabric of the vacuum and encoded it into a very simple two-dimensional symbol, commonly known as the yin-yang. So they've encoded the yin-yang dynamics of the vacuum and the I Ching geometry of the vacuum into these ancient symbols that are absolutely encoded into the fabric of their society. This is another animation that I will put a link to at the end that shows an animated 3D yin-yang, showing that yin-yang is actually dual torus dynamics feeding one into the other. The white dot in the black and the black dot in the white is the exchange of the information from one hemisphere to the other, creating this continuous flowing dual torus pattern of space-time. Now we're looking at the Hunab Ku. This is another 3-dimensional or another 2-dimensional ancient symbol encoding for you plasma dynamics. Quadrupole spinning towards singularity. You see those jets coming out on the edges. Looks kind of like those bows that we just saw from the Chinese urn in the back of the Forbidden City. So we've got Mayan and Egyptian and Chinese information all saying the same thing in a different way. The Mayan calendar that we see underneath there is a numerical calendar, and the black squares plus the ones enclosed by black equals 32 on each side, and 32 plus 32 is 64. So there 64 comes out, and then the ascending column has a 1 in the middle, a singularity. Aztecs, same thing. So Mayans, Aztecs, Chinese, Egyptians, all saying similar sets of information. I stuck this here in myself. This is the Sri Yantra. I've actually never heard Nassim talk about the Sri Yantra, but obviously it looks similar to a 64 tetrahedron grid, and I have a feeling that this is somehow connected to the same set of information. Perhaps it's a view of a 64 tetrahedron grid from a certain angle. I'm not totally sure, but I think Sri Yantra has got some powerful knowledge to be gained. I've yet to be able to dig myself further into this, but I have a feeling it's important. So I stuck it in there, even though Nassim doesn't talk about it. There's the Sri Yantra with the Metatron's cube overlaid. So now this is the work of a great page called From Affinity to Infinity and Beyond on Facebook. And this is cymatics, mapping of phi and pi stained glass windows from Catholic cathedrals, DNA molecules looking from the top down, all looking similar in this mandala kind of shape. Now we're jumping to this message that was sent into space by Carl Sagan in 1970s, a message for extraterrestrials in case they were listening to us. And so we sent them binary code, simple ones and zeros, and it basically says we're made of these elements and that we have two-stranded DNA and a small head and a large body, and we live on a single planet out of 8 planets going around a single star. And at the bottom there, they have a picture of the technology that they used to send the message, which was the Arecibo telescope in Puerto Rico. Now, we got a direct message back. It was not a message back as a radio telescope message, or else we would never hear about it. They put it down as a crop circle next to the telescope that was listening to radio waves from space, waiting for a response to this message. So that's pretty classic. So whoever guarded this installation was pretty surprised in the morning when they see this crop circle and there was no evidence of anybody in the field. And yet there's a mugshot of the person who sent it and a perfect response in the same format that we sent, saying basically the same thing, that we are made of the same kind of elements as you. We actually have 3-stranded DNA, large head and small body. We live on 3 planets in our solar system. One of them has 4 moons. And here's a picture at the bottom of the technology we used to send you this message. Now, what is that? That's what I want to know. This is my favorite crop circle to illustrate how difficult it would be to do this if you had boards and ropes and you were running around in the dark. So here's a face. It doesn't look, totally accurately like a face. You might have to squint your eyes or something to get to see that facial feature pop out at you. But just so you know, if you're trying to make this face look like a face from the air, with an aerial photograph the next day, you have to remember you're in the dark. You have no headlamps. You can't make any noise. And you're trying to make this, when on the ground, this is what you're looking at in the dark. I do not think that looking at these little blobs of crop around you, you'd be able to make a face like that. You would need friends that are in a silent, lightless helicopter with 2-way radios and night vision goggles looking down on you like, you're working on the left eye. I think it's a little too big compared to the right eye. Yeah, you're going to have to no, not that one, to your left. Can you imagine? You're getting verbal cues from somebody in a plane telling you how it looks. There's no way you're making this on the ground to get it to look like this. And that's what showed up in a field next to the radio telescope, waiting for the response to this message. And here it is laid out in the same format that we sent it. And a year earlier to the day, they gave us a blow-up of the technology they used to send you this message. What does that look like? That crop circle looks like a singularity with a boundary condition, an ergosphere, and then an event horizon, and then a singularity half inside and half outside the event horizon, fractally dividing to infinity. Scalar dimensions of singularity dividing to infinity. Maybe we should look into that, right? This could be a very important clue. And it's almost like they got frustrated, like they're not getting it. We have to be a little bit more obvious. Back in the 90s or maybe early 2000s, I can't remember when this showed up. They've invented CDs. We'll give them a guy in a portrait frame holding out a CD encoded with ASCII code, which means this disc can be translated into English. You'll find this actually in Daniel Pinchbeck's book, 2012, The Return of Quetzalcoatl. And it says in this encoded disc using Scientific Informational Codec, ASCII, that beware of the bearers of false gifts, their broken promises, much pain but still time, believe there is good out there, we oppose deception, and bell sound. Now, bell sound is kind of like conduit closing or end of transmission. This is obviously up for interpretation. This is English words. Somebody like Daniel Pinchbeck and others might say this is one species of extraterrestrial warning you against other species, that there might be uncool, mean extraterrestrials out there. But Nassim, because this showed up in 2001, he thinks it's more about the Bush administration, actually. And I'm more down with that because it seems more like George Bush saying, I'm going to be a compassionate conservative, and then he gets into office and you see what happened while he was around. I don't think so. It's probably warning us against people of humans, not extraterrestrials, but who knows, right? Much pain, but still time. Like, okay, we're going to have to go through some stuff, but we're going to make it. Believe there's good out there. That's nice to know. And we oppose deception. Some kids ran through the crop circle before they could fully decode it, so they're not sure if those letters are supposed to be capitalized or not, because there's a codec in ASCII code to denote emphasis or capital letters. So it's a very interesting crop circle. You can go look into that more online. In any case, the crop circles have been getting more interesting and more diverse and giving us all kinds of interesting information. Here's Göbekli Tepe. I encourage you to look into that one. Graham Hancock is sure to cover this. He visited it multiple times in the last few years. The German archaeologist who was working on this dig died recently, but I know his team is continuing the work. There's many circles that have yet to be dug out. There's a lot of interesting mysteries to behold there. The sun gods were always talked about in ancient cultures. And I remember being told the stories of, like, isn't it quaint that the ancient cultures didn't know what was going on? They had to invent these stories and myths and legends about the sun gods. And now we're finding that those sun gods were probably real people that were being talked about. Of course, you can go watch every episode of Ancient Aliens, and they're going to outline a lot of this kind of stuff. And Brian Forrester is working right now. I think he's in Peru right now, or Bolivia, working on doing DNA testing on these skulls. A lot of these skulls have been tested. You can check out that film Sirius, where they do genetic testing on a being that's about 6 inches long that looks like a little humanoid. The Stanford researcher says that he's not totally sure, but there's genetic codes in there that don't match anything in our database. In other words, we're finding skulls around the world that are probably from beings that are not Homo sapien, not Homo erectus. They're outside of the standard model of the evolution of hominids. This skull is not a human skull. We don't have a seam going across our skull like this. They've done genetic testing that shows that the paternal DNA of some of these skulls is not humanoid, whereas the maternal DNA is. In other words, a non-human entity may have impregnated a human and was close enough genetically that it could give birth to some of these beings. Here's this skull with two different lobes independently forming the bulbous kind of projections and the seam. This is the Star Child skull. It's probably the most famous of these types of skulls. It was stewarded by Lloyd Pye, who's also died recently, but I believe the skull is still touring around. Again, the maternal DNA looks like it could be from a human, and the paternal DNA, not so much. And Nassim now points back to the earliest known written language that we have. This is the Sumerian tablets as translated by Sitchin, and it's telling the story that we see here of the sun gods, the big creature guy on the right, giving mankind, the three smaller folks over here on the left, this piece of technology sitting on the table called the black sun. The black sun, Nassim theorizes, is a piece of galactic technology. In other words, a star, a little black hole. If you had a black hole that you could keep contained, basically a little sun, it would be very radiant. And this object looked like it's got some serious radiance coming off of it. Looks like it could be like the Hunab Ku or the yin yang or all these other ancient symbols with this radiation coming off of it. And it basically says down on the bottom that the sun gods came down and gave mankind this piece of technology. And maybe that's how they were able to cut these gigantic blocks, like here in Baalbek, Lebanon, where Lebanon is now, and take these from the quarry up to the top of the hill. And then the Romans found these giant stones and said, wow, this is a great foundation for our temples. And they built temples on top of foundations that were much older. 14,000 metric tons. We're talking beyond the ability of any. I'll give you as many slaves with vine ropes as you want. You're not pulling that anywhere. Even with 1 million slaves with vine ropes around that, you're not going to be able to drag that anywhere. So how were you able to move these megalithic structures? Maybe they had a technology that was able to alter the mass and make it less massive, and then you could move it with ease. This is the evidence that's stacking up that is found all over the world. You've got the Baghdad batteries, low level of electric charge. One of the last things Nassim looked at was the tradition of Muslims. He's actually from an Iranian family, and his grandfather was somebody who would do a pilgrimage to Mecca for the people that were too poor to do the pilgrimage themselves. If you're a Muslim, once in your lifetime, you're supposed to go to this object called the Kaaba, which is in Mecca, which is in Saudi Arabia. And you don't just show up. You're supposed to go to this object, which is supposedly containing one of the holiest objects in all of Islam. In the Quran, it's called the Black Stone. And Nassim thinks that the Black Stone is the same piece of galactic technology being described as the Black Sun in the Sumerian tablet, contained in this giant cube in Mecca. And when you go there, you wear white and you circle around it in a circular vortex 7 times. Again, bringing up that 7 around 1, giving you the multiple to get to the octave. And Nassim's grandfather carried the prayers for the people that were too poor to do it themselves. And he himself would go 7 times for every prayer he was carrying. And when he died, he was 120 something years old, one of the oldest living people on the planet. And maybe it was because he was drinking water from a well that's nearby here, the second holiest site in all of Islam. Very interesting stories coming from Nassim's ancestors. So you've got evidence of this ancient technology being described as the Black Stone in the Quran, the Black Sun in the Sumerian tablet, and the last place Nassim really wanted to look was in the Bible, because Nassim actually went to Catholic school when he was a kid, and he was left-handed, and the nuns would hit him over the hand with a ruler because they didn't want him to be left-handed, because that's, I don't know, the handedness of the devil or something. I'm not sure why you can't be left-handed, but in any case, they were hitting him with the hand. He wasn't very, feeling very resonant about Catholic school, I have to say. And he remembers being told in Catholic school that God is a white male living on a cloud with a big beard, looking down on us and waiting for you to make a mistake so he can strike you down, because if you sin, you're going to go to hell or purgatory, which isn't much better. And so he was remembering getting instilled with kind of grief of kind of guilt and fear that God was a white guy waiting to strike you down and all this stuff. And then when he looked into these ancient Bibles, it seems like God is actually a tetrahedron on a throne with radiant energy coming out of it and a boundary condition looking kind of like an event horizon around this powerfully radiating tetrahedron with a sphinx flying in the sky and 7 cups in the heaven. And then when you start reading the text of the Bible with lenses of unified field theory on, then it starts to have a very different meaning. The throne of God was the crystal sea. Could this be a crystal sea, the geometry of space-time, representing the skyim or the living waters in the heavens? Could that be plasma dynamics? I mean, if you don't have the terminology of physics to describe, a ship coming and landing, you might call it a giant boat, like an ark or something like this. And if there was a giant flood and all the waters rose and you want to save all the animals, you might need to take genetic samples from all the species around the planet and then bring it up in a ship so it doesn't get flooded, and then you can bring it down. In other words, Noah's Ark, doubtful it was actually a wooden boat with gazelles and lions standing next to each other on the bow of the boat, with the lions not eating the gazelles. I don't know, but it would make more sense if that was a true story, that the ark was actually a ship. And they used the word that got translated into ark, that got translated into boat, and now we all go around thinking Noah was an actual guy with animals on a boat. You can reinterpret the Bible any way you want. I'm telling you what Nassim has said that he came to in his discovery, having gone to Catholic school, come up with unified field theory, and then revisited the Bible, because now, wait a minute, the Ark of the Covenant of the Lord looks way different to me than it did before. Maybe instead of holding the word of God, meaning they put the 10 commandments in there, even though the commandments were not written on a tombstone-shaped tablet. Check out the little bonus feature in the DVD set, Crossing the Event Horizon. You'll hear about Vendell Jones, right? The guy who Indiana Jones was modeled after in the Temple of Doom and all that stuff. He's an archaeologist who found the 64 things that you need to be able to approach the Ark of the Covenant of the Lord, which is this box, right? This box that Moses was told to build by God. Straight up, this is what it says in the Bible, right? That Moses was told by God, you got to build this box. It's called the Ark of the Covenant. It's going to be made of acacia wood. They told him what kind of wood, told him exactly how big to make it. how many cubits wide and how many cubits tall. Turns out, if you put this ark with those exact dimensions together, it'll fit perfectly inside the sarcophagus of the Great Pyramid of Giza. That could be a coincidence, but I doubt it. It's more like this was the power of Egypt. And it's not the box that's got the power. It's that star that's floating in between the golden angels. It's the little sun that could be the same technology being described as the black stone in the Quran and the black sun in the Sumerian tablet that's hovering in the space between the golden angels. Because we're talking, it was gold on the inside and gold on the outside and very specific geometry. If you built this thing, it would turn out to be, in electronics, a capacitor, something built to hold a charge. And nassim would say that charge is this galactic technology hovering here in between the golden angels. So now everything looks really different. Now the Bible is describing a conscious being that would travel on its own and then just stop. And the Jews would follow it until it stopped. And then they would say, oh, I guess we're setting up camp here. And they'd put a tent, a tabernacle around this thing. And you can see the giant column coming out of it. That's the vortex going down to the black hole, singularity. And if you read in the Bible, they said that it looked like a column of cloud by day and a column of fire by night. And this would be a good description of a black hole if it was traveling on its own. And then they would hang out for up to 2 years at a time until it would move again. And it took 40 years for this thing to go across a desert that you could cross in 6 months, but they didn't. They stayed with the object. And then Moses got the download. If you want to actually move this thing and travel with it yourself, you have to build this capacitor. And they called it the Ark of the Covenant, and they put that in there. And then they were able to actually carry this thing. Moses split out of Egypt, right? Because he was a Jew and he didn't know until he was 40. He was running away from the Egyptians with his parents, and they put him in a little raft when he was a baby and went down the river and was found by Egyptian royalty and brought up in Egyptian society until he realized the power of the ark and the fact that he was actually a Jew and a Hebrew, and they hid it from him. So he said, I'm out of here. And he took the ark with him. And then the Pharaoh chased him. And then he got to the edge of the Jordan River. And Nassim will read right out of the Bible about how the high priest got to the edge of the Jordan River and Moses directed them to carry the ark into the river. This is straight out of the Bible. You can read it, right? And it says in there that the waters stopped and the tribes of Israel were able to cross the Jordan River, even though it was at flood stage, just like they did at the Red Sea. So they had crossed the Red Sea in the same way as described in the crossing of the Jordan River. So it wasn't Moses holding up a staff and the waters parted. It was he had a star. He had a black hole in a can, if you will, a contained piece of technology held in the ark. And if you walk with a star into water, it's got a gravitational field. It's going to move the water. So you can see how things got really confused. And you can also see how this is outrageous, what I'm saying. If you are totally entrenched in any tradition, whether it be Jewish tradition, Christian tradition, Islamic tradition, there's very specific stories that have been laid out and told over generations that have been cemented. And this is the deal. And if you say something very different than this, it can be kind of traumatic. And so I'm not a biblical scholar. I'm not a Christian or a Jew, even though my father was Jewish and my mom Christian. I never, went to temple or church. And so I'm sensitive to these faith-based issues. I'm telling you that this is a possible reinterpretation of information that came out of the Bible. And it sounds kind of crazy until we started finding actual physical evidence. Like we found the copper scrolls among the Dead Sea Scrolls, 300 scrolls, only 100 of which have been released. The other 200, they don't want us to know what's on there. They're hidden somewhere. I don't even know where they are. But in any case, 2 of the scrolls were written on the purest copper ever found on planet Earth. We cannot make any copper purer than this. And it outlines the 64 things that you need to approach the Ark of the Covenant of the Lord. And Vendell Jones went out and found these things, including the temple incense, oil to anoint yourself. Have you heard of people anointing themselves? That's literally putting oil under your skin. If you want to be able to approach the Ark of the Covenant of the Lord, you better be pure of heart. You've heard of that phrase, you have to be pure of heart in the eyes of the Lord. It's because if you weren't pure of heart in the eyes of the Lord and you tried to approach the Ark of the Covenant, it wouldn't work out too well. You would just die. If you had ill will in your heart and you went up to the Ark and said, oh, this thing's powerful, great, I'm going to use this to kill all those armies over there, No, it would not work. You'd go up and try to get close to it, and you'd get zapped. If you wanted to get close to and approach and interact with this arc object, you had to go through a serious initiation process. And so Nassim actually recommends a book by Elizabeth Hike called Initiation, in which this modern German woman is having past life memories and regressions of being brought up in ancient Egypt, and talks about very specific stuff like geometries and, technology, stuff she would have no idea about in her normal life, and kind of channels this into this book called Initiation. So I'd recommend checking that out if you want to know more about the ancient history of Egypt. Meanwhile, they built King Solomon's temple with octave walls, right, to radiate out, and they would put the ark in the middle of it. This would amplify the field. And if you wanted to go into the innermost chamber, they would only send the highest priests in there, and just in case, they would put a rope around their ankle. In case they died in there, they weren't pure of heart, they could pull them out so they wouldn't just rot in there and stink up the place. So a lot of stuff that didn't make a lot of sense starts to make sense when you think about interpreting the Ark of the Covenant as a piece of galactic technology, a little star. Then it makes sense why they had to wear veils in front of their eyes, because they can't, they didn't have sunglasses in the day. They had to wear veils to protect themselves from the brightness of it. And to see the vortex going down to singularity, you need particulate in your atmosphere. Just like you wouldn't see a galaxy without the stars in it. You wouldn't be able to see the curling of space-time to that black hole unless you saw the stars moving. You wouldn't see a hurricane unless there were clouds. If there was a hurricane with no clouds in it, you wouldn't be able to see it. And if you need particulate to be able to see the vortex going down to a black hole in your cathedral or whatever, you might need to burn incense, which is maybe why you see these guys burning incense all the time on a pendulum in cathedrals and stuff like this. So a lot of these dots start to connect. My favorite insight of Nassim, practically of all time, is the analysis of the Tetragrammaton. If you look back in ancient Bibles, the word for God is Yahweh, Yud-He, Vav-He in Hebrew. There are 4 letters. And so they say that by arranging the 4 letters of the great name of God, Yud-He, Vav-He, in the form of a Pythagorean tetrachus, otherwise known as a tetrahedron, the 72 powers of the great name of God are manifested. I remember hearing about this and thinking, 72? What does that have to do with anything? 72 powers of God? Oh, it's encoded information, right? They're not just going to give it all to you. If you want to build a 64 tetrahedron grid, you need 8-star tetrahedrons put together, right? And what do you need to make 1-star tetrahedron? You need, again, a tetrahedron pointing up and a tetrahedron pointing down. And so if one tetrahedron makes 72, you need the other one. 72 plus 72 is 144. You've heard about this number, right? The 144 faces of God. That's right out of the Bible. Or the 144,000 people that are going to ascend and all the rest of us suckers are going to hell. No, they're talking about this. How many faces are there on the outside of a 64 tetrahedron grid? Exactly 144. The Bible is talking about the same geometry that the I Ching is talking about, that the Mayan calendar is talking about, that the DNA molecule is encoding. It's just beyond coincidence that the Bible would point to the very same encoded information as all these other objects. Even pre-Christian, going all the way back to the Kabbalistic tradition, here's yet another 2-dimensional symbol that encodes a whole bunch of information. Don't even try to decode this, they said, because you'll go insane. And then Nassim's like, well, everybody thinks I'm insane already. I've got nothing to lose. And he's decoded the tree of life, figuring out that, they talk about how the tree of life comes in pairs and that it's made of 10 golden globes connected by 22 channels. And the golden globes are called sephirots. And so you add up how many sephirots there are with how many channels. How many is that? 22 plus 10, that's 32. And if they come in pairs, that's 64. So there's 64 encoded in the tree of life, male and female versions, if you will. And they also talk about the Sephirot in the middle, but this one in the middle isn't exactly in the middle unless you push the bottom up into the top. When you do that, then you get the geometry of the star tetrahedron and Metatron's cube. So you've decoded it correctly because it's like 3-dimensional tree of lives, again, a two-dimensional symbol trying to encode for you a three-dimensional object. You push three-dimensional tree of lives together, 8 of them, and you get the nodal points you need for the 64 tetrahedron grid, just like you did with the star tetrahedrons. And you know it maps perfectly because you can put the tree of life perfectly over on top of the 64 tetrahedron grid and get this information. This is all just literal, right? This is geometry. And then you can go to the next layer down and go into the interpretation of all this. The Kabbalistic tradition is super deep. And, I'm skimming it in 3 minutes. So obviously there's a lot more to be found here. But the point being is that the tree of life is actually a three-dimensional structure trying to give to you the underlying geometry that you need to build the structure of the vacuum. And there's another great animation here that I'll put a link in at the end of the talk for this animation showing the Kabbalistic trees coming together and contracting pulses to form the vector equilibrium in the center of a 64 tetrahedron grid. Again, that's in the Black Hole DVD, and also there's a Crossing the Event Horizon DVD. I stick this in here myself. This is the first time I've ever put this slide into one of my presentations. I don't know why I waited this long. I think this is really important. This is an evolutionary tree of religion. And I like to show this because in the middle of that yellow part, you'll see the Christian cross, the Judaic star, and the crescent of Islam. And you'll see that they're all very close together in time and in space. And it shows that they came from an earlier religion, which came from an earlier religion, which came from an earlier religion, which branched off from an earlier. In other words, all of the religions and all the spiritual traditions of the planet come down to the same seed set of information. If that's true, we can stop killing each other right now. My book says this, and your book says that, so I'm going to kill you. There's people within one religion that are saying, you're interpreting our one book like this, and I'm interpreting our one book like this, so I'm going to kill you. When it's ridiculous, when really all of the religions all are doing the same thing, trying to figure out how to answer the most foundational questions that we have, and they're doing it in a different way. Guess what? I play bluegrass and dubstep at the same time together. I play an ancient instrument called the hammer dulcimer, which originates from Persia, Middle East, and then I stick Ableton Live and a computer on it, and I make giant bass sounds, and I play 2 totally different styles of music together. And the dubstep fans are not killing the bluegrass fans, and the bluegrass fans are not killing the dubstep fans. In other words, we have different styles of music, we have different styles of dance, and we have different styles of faith. And hey, we could celebrate the diversity of faiths that we have on this planet right now and just call it Festival Earth. That's what I'm talking about. That's why I'm doing these talks. I'm not just doing it so that we can figure out the physics of the universe. Yeah, I do want to know that. What I want is for people to stop killing each other. I want them to stop killing each other because my book says this and your book says that. I want Festival Earth. I want us to celebrate. How about a Jewish stage and a Hindu stage and a Muslim stage all next to each other, right? We're going to go over here and we're going to get the Hindu music with sitars and incense, and there's a different deity for everything. And then we're going to go to the Islamic stage, unbelievably beautiful Islamic sacred geometry tiling all over everything, beautiful oud music and stuff like this. Then we're going to go to the Jewish stage, and I want to get on that chair and do that circular vortex dance that they do at bar mitzvahs. I want to practice all the religions at the same time because I feel like all faiths are tapping into the foundations of our reality, and they've described it in their documents and their monuments in different ways. The I Ching interpret it into these 64 hexagrams. In the Bible, it's the Tetragrammaton, the 4 letters of the great name of God, spelling out the powers of the great name of God is 72, which is 144, the number of faces on a 64 tetrahedron grid. Everybody's interpreting the same set of information, the structure of our reality, in a different way, encoding it into their monuments, their documents, and their traditions, and it came out into all these various religions. So sweet, Festival Earth, here we are, all on the same team, all celebrating the fact that we exist. This is awesome. We're on a spaceship that has no directions. We're trying to figure out how to navigate ourselves. It seems like we're headed for a brick wall. We should probably figure out how to steer the ship in the direction of more fun and less pain and suffering, because we can, because we know we can, because we have the information. It's right here. And guess what? The technology already exists. These ideas already exist. The mere fact that I went from being, a street musician to a touring musician to finding this one guy, Nassim Haramein, who taught me all this stuff, and now I'm on this, conference call that I organized myself through the internet, and there's people around the world all, aligning our vibrations together. We are proof that we are doing this right now, that we can spread this information. That's why I'm saying, please be an emissary for the universe. And if you find something that's coherent and makes sense to you, put that information out there, because you are the universe teaching the universe about itself, so that we can finally come into coherency and move out of the dawn ages into a new era of acceptance and fun and letting people pray however they want. You guys pray like this, and we'll pray like this. It's all good. We're going to stop putting bombs over the walls. We're going to take the walls away. There's no such thing as boundaries. We're just going to all move forward together. And that's where I'd like to see this happen. And it's going to happen not just through spiritual practice. It's going to happen through technology. Any advancement in consciousness in the history of humanity has corresponded with a advancement in technology. And I know that's hard to swallow for the spiritual people. I'm like, no, we can ascend and get to next levels without technology. But wait a minute. How did we even get more people on this planet? The plow is an important piece of technology. Without the plow, we wouldn't have had the agricultural age. And without the Industrial Revolution, we wouldn't have been able to make the pieces of technology that we use to communicate, to have the computer age of the internet happening. These are 5 spiral evolutions of consciousness, from the Dark Ages to the Renaissance, to the Agricultural Revolution, to the Industrial Revolution, to the Information Age, to the Computer Age, to the Internet Age. These are smaller and smaller periods of time. That's us right now. We're at the very edge of riding this wave of consciousness with people like Nassim Haramein and others coming up with new ideas, putting it out there. We go, oh yeah, I think you're onto something. I'm going to talk about that too, and ride it, and that wave builds, and then eventually we make massive change. And I never expected, for example, that we'd see gay marriage be legalized in the United States. That's a huge change in our level of awareness and consciousness. And the legalization of drugs and not, persecuting people for what's a medical problem or an addiction and not putting them in the jail for that is another evolution. And then we're starting to get more and more coherency. Same things with our technology. This is an early rendition of a piece of technology that Nassim put together. For a long time, I wasn't allowed to show this picture, but he recently got a patent for his device. You can go check it out on the U.S. Patent website. Check out Nassim Haramein on U.S. Patent Office. You'll see pictures for this piece of technology. It's basically, as you can see, a dual torus with a sphere in the center. And the idea is to spin the magnetic field very quickly. You can spin objects, but then you have friction. But if you can spin a field fast enough and get plasma to collapse in on itself, you might be able to create a singularity in the lab. So yeah, a black hole, a sun. If you had a little sun inside your car, you could probably go really far with that. And so the idea is to create the same technology that I just outlined from all these ancient cultures, but do it now, today, modern technology, maybe not brought down by the galactic family, but no, human beings are starting to figure out this for themselves. They don't need to have it brought to them. We're going to make it from scratch, because now we understand the geometry and the dynamics of the fabric of the vacuum, and we know that space is full with quantum vacuum fluctuations, and we're going to get those little Planck spherical pixels to perfectly coordinate together and form a little vortex in space-time, like water going down the drain, and make a little star, and then we're going to get energy off of that. And if you could do that, you have energy wherever you are, because space is everywhere you go. It's in the middle of planets. It's in between galaxies. It's in the middle of the ocean. If you can extract 1/1,000,000,000 of 1% of the infinite amount of energy in every point in space, you have an infinite amount of energy. Nassim made this. He turned it on briefly and then turned it off. And he put water into these coils and put it around the object to cool it off. And after he did this experiment, he noticed that the floorboards in his lab were warping. And his neighbor came by and said, there's something weird with our water. What's going on? It tastes weird. So he sent it to the lab, and the water that he was using to cool this device, which he calls a resonator, because it's resonating the fabric of the vacuum, had crazy changes in its sulfates, carbonates, dissolved salts, calcium, all these various things that the water lab was able to measure. And so he thought, well, maybe there's something special with this water. So he went and he found a tree that bloomed all these various flowers. And on the same day, he picked various flowers off this tree and put them in petri dishes with different water samples. One was from his tap water, one was from Foster Gamble's filtered water, and one was the lab resonated water. And then one was from a well nearby. And after a month's time, all the other dishes, the flour deteriorated and kind of, degraded. And the one from the lab resonated water, the flour looked like the day it was picked a month later. Sorry for the formatting on that slide. And so perhaps we have figured out now that you can align water molecules with more perfection by resonating it. It's already been documented that just by taking a water bottle and another water bottle with a little connector and making it spin, that spinning water will help purify it and take out particulate and stuff. And so if we can learn how to highly charge and resonate water, it might have reviving properties. Maybe that's why the fountain that's near the Kaaba in Mecca is said to be the fountain of youth, and that people were drinking this and living to very old ages back in the day. A lot of this stuff definitely sounds fantastical. I had to weed my own consciousness through all the conditioning that I was given by being told, about this is how it is, and this is how it is, and this is science fiction, and don't tell me that there's aliens. That's just a story being made up. And then as new information comes, I have to say, wait, open up your mind to the possibility of this, because when I did and I looked into it, then I saw, oh wait, there's logic behind this. It actually makes sense. I don't take anything for granted. I don't think for a second that Nassim's got it figured all out. I don't think for a second that every single thing that Nassim's come up with is 100% correct. What I do think is that it's closer to correct than the stuff that I've been told and the stuff that we currently believe to be correct in the standard model of physics, certainly, in the standard model of archaeology, certainly, and in other aspects of other disciplines that are maybe not as directly researched by Nassim. But the point being that we have an opportunity here at this time on this planet together to make massive change over a short amount of time. We have to. We have no choice. The climate change thing, there's no debate anymore, okay? We can let go of the debate on this. We need to learn how to sustain life on this planet and ultimately how to get off this planet. Planets are only around for a few billion years. Comets happen, asteroids happen, stars eventually blow up. Our Earth will be consumed by the sun in billions of years. So if we want to be around for more than billions of years, we have to learn how to go across the ocean, meaning across the galaxy, meaning learn how to deal with the gravitational field. Not just build a giant phallus and stuff it with a bunch of flammable liquid and put some sucker sitting on top of this thing. We're not talking about blowing stuff up to make energy. We're talking about propulsion directly from the fabric of the vacuum. And guess what? It's already happening. Google NASA space drive, NASA impossible space drive. It's a space drive that NASA tested that gets a very small amount of thrust from the quantum vacuum fluctuation space-time. In other words, an engine that has thrust with no propellant, which is supposedly against all laws of physics. It shouldn't be possible because you have to push against something, right? And so what are you pushing up against? And it's really just the quantum vacuum fluctuations vibrating back and forth in a vortex that gets smaller and smaller. And I'm very simplifying this, but Google the information. NASA basically did a study saying, we don't know why this works. We're just saying that we got an effect of some thrust out of this engine. And I have a feeling that this is going to become now common knowledge, that the powers that be that have been trying to hold this back for a long time know that the cat is already out of the bag. There's not enough hands to play whack-a-mole with all the inventors of the world. Watch Thrive, and you'll see all these inventors that got whacked because they came up with some invention that was going to do a paradigm shift. Now there's so many people making devices in their garages everywhere, thanks to people like Nassim putting this out, and NASA, releasing these plans, or this study about this drive, and Keshe Foundation and the quantum energy generator and the breakthrough energy movement, and Nikola Tesla, Occupy Tesla movement. I mean, it goes on and on, right? This word is out. They can't smash it anymore. And so now you've got the Rockefellers and these guys divesting themselves out of oil into renewable energy because they know that that's where it's going to come next. And it's a good time to be alive. We're really, it's an amazing thing that we are witnessing this transformation. Even people like Nassim are getting awards now for his work in like the Cassie conference and stuff like this. And he's able to put out his information on his own, crowdsourcing films and putting out his own DVDs. So like, if you're not going to publish me in peer-reviewed journals, I'm going to put out this information in any way I can. I'm going to teach musicians like Jamie Janover to go out and do unified field presentations for people around the world. And more people are getting interested in this. And I'm watching the whole wave grow. The pages are growing. The attendance for these types of talks are growing. I was astounded to see 3,200 people say they're going on this event. We have far less than that who actually signed up, which is the case with any Facebook invite. But the fact that we're seeing this kind of momentum is highly encouraging to me. You can support Nassim and his work and the foundation called the Resonance Project Foundation by becoming a member of the Resonance Project, or you can go and learn more about this through the academy called the Resonance Academy, and go through these 6 modules over many weeks and have live sessions with Nassim where you get to chat with him and ask him questions and meet people from all over the planet. You'll see on this feed on the chat over here, and you'll see from my post on the event invite for this saying post a photo of where you are, that there's people from every culture, every religion, every part of the world, all interested in this. Everywhere I go, people are equally as interested. It's not just Western countries in North America. I've been seeing it all across South America, Africa, Asia, all over the world. It's very exciting to know that this is building and that we can all play a part in increasing the coherency of our local environment and creating, more fun and less pain and suffering. And what I'd like to see is that we really, learn to accept everybody for how they are and let everybody do whatever they want to do in terms of their faith, and create Festival Earth right now on this planet. And you guys are definitely a part of that. So I really appreciate you guys being here. Someday, hopefully, I'll get to see some of you on something like an emissary program where you learn how to do these talks. If you want to go out and do these talks yourself, you can take the delegate program and eventually the emissary program and do stuff like go to a cenote with Nassim and a bunch of folks, like this picture here. This is from November 2011. It's about 80 people that learned how to do these talks. These are all the emissaries from the second batch, people from all over the world, France and Spain and Australia and New Zealand and Romania. Radu from Romania is in there. Great people. And so I'm excited. I'm going to go and do a tour myself. I almost did a tour in Europe this November, but I realized that I needed to take care of some other things first. So I'm eventually going to go do talks in Europe and all over the world. So keep your eyes out for the events coming up on resonance.is, and the academy is academy.resonance.is. And stay in touch with me personally. You can check me out on my Facebook page, Jamie Janover, and my website, jamiejanover.com. I'm also on all the other, Twitter, Instagram, all that stuff. And it's been really great and an honor for me to be in this position and be in contact with all these people all over the world. I definitely feel different and I definitely feel connected, and nothing makes me happier than to have received aha moments and be like, oh, really? All I have to do is go like this for 5 hours. And then I get people going, oh, I'm getting goosebumps and writing me emails like, I was going to do this. And now that I heard you say all that stuff, I'm not going to do that. Now I'm going to do this. In some cases, it's somebody saying, I was going to go into the military, but instead I'm going to teach children. And then I go, yes, that's awesome. All I have to do is go blah, 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 and I can make really cool changes in the world. We can all do that. And we should all do that right now. And we should spread the word, because we are absolutely at a transitional key point. And I have a feeling that they're watching us and they're going, yeah, you can do it. And they're patiently waiting for us to get our act together amongst ourselves so that we can then go join them. And boy, is that going to get fun when it becomes Festival Galaxy and we can celebrate faiths of other beings on other planets. That's what I want to go. Let's have a festival on another planet for a weekend, and then we'll come back. So maybe the next delegate program we do online, I'll be doing it from Jupiter. I'll see you guys then. Much love. Jamie Janover signing out. Thanks to Portal to Ascension. Thanks to Nassim Haramein and the Resonance Project Foundation. Much love to all of you guys, and spread the word, and I'll see you next time.